6 hours of a full stack plus Web3 project. If you're gearing up for the Web3 cohort, if you want to get into Web3, understand Solana, participate in one of these hackathons, this is a great idea. In fact, this idea was the winner in one of the tracks in Colosseum this year, very close to, not this idea, but like very close to what we're building. What we're building today is a data labeling platform. It lets people on one side put up a bunch of data and people on another side, usually in developing nations, label that data. A very common use case here is machine learning models. That a lot of times this data needs to be trained by humans. So companies like OpenAI put up a bunch of data. For example, they put up images of cats and dogs and they make you identify which one of these is a cat, which one of these is a dog. This is humans labeling data so that the machine learning model can eventually be trained on it. We're building something similar. Another use case that can be built from this is every video that comes on YouTube, at least my video, for example, this specific video had 6 variants of thumbnails that we had to choose from. And it's very hard for one person to tell which one will perform the most. But what if you could broadcast this to 1,000 people in some developing nation and they can click the most clickable one. And even before the video is released, you can figure out which will have the highest click-through rate. So these are like standard manual tasks that a big company might want to outsource to a user farm or, developing nations. And Web3 is a decent use case here. Why? Because you want to do micropayments. You want to allow people to do some small tasks and then, eventually get paid as soon as possible. If you bring in standard Web2 compliances here, which you can, the platforms that currently exist, of course, do not use Web3. But, this is a pretty not forced use case of Web3, where you let one party pay a lump sum amount, let's say $50,000 for a lot of data to be labeled. And then a lot of people all around the world, usually on their phone in some developing nation with internet, solve all of these problems, label them, and then get paid micropayments, which means they just get a chunk of the $50,000 for doing all the work that they did. That's exactly the platform we're building. By the end of it, we will have a platform where people can come and post a manual task. For example, a YouTuber can come and post all the variants of their thumbnail and pay a small amount for that task to be solved by 1,000 people. On the other side, we should ideally have a mobile app, but we'll have a web app for now, where a bunch of workers can come, solve these manual tasks, and by the end of it, get paid a certain amount for all the work that they've done. All the payments will be done by crypto, and we'll be using the Solana blockchain for this. Without any further ado, let's get into the video. Alrighty, hi everyone. Let me set the context. We're going to build a full stack application that requires some portion of Web3, but it's also, a Web2 problem to solve. Here is a gist of the problem statement. Let me open up Accelerator here. I don't know how many of you have had YouTube channels in the past or know how YouTube works, but generally all good channels, all big channels that you might see have a decent chunk of thumbnails ready per video. For example, for my most recent video, we had 5 variants, and there is something called CTR, which stands for click-through rate, which is something you optimize for. You want to increase the CTR as much as possible, which means, you have these choices, which are usually built by 1 or 2 disjoint teams, and then you choose one. Problem is, it's really hard to know which one will perform until you actually throw it out there, and then eventually YouTube gives you back data and then you change thumbnails, which is super irritating for the audience. So what we're building is a website similar to Mechanical Thumbs, Mechanical Turks. I don't know if you've seen Mechanical Turks or have heard of, these subletting websites. They basically let a big company hire a bunch of cheap people to do menial tasks. And this, for all practical purposes, is a menial task. You wanting to just click a button, you needing an audience of maybe 1,000 people to just select what looks the most appealing, click on it and then go from there. Another good alternate requirement might be data labeling. Okay. Most machine learning models need some level of data labeling, as in, is this picture a cat or a mouse? And all of this needs to be done by humans, because that data is what models are eventually trained on. So if you've heard of this company called Scale AI, which is a pretty big company, they do a bunch of things now, but this was their initial pitch, which was make the best models with the best data, basically labeling a lot of data. And they work with companies like Google, Waymo, all big companies that help them label data. How do they do it? If you look at Scale, they have another subsidiary company, which they keep pretty separate for most practical purposes. And you wouldn't even know they have 2 companies, but the other company is an Upwork-like platform where people can come and help them label data. Basically hire a bunch of people. They hire a bunch of people in developing nations, give them all these labeling tasks, which are actually taken from Google somewhere in the US, that help them label data. So this is suddenly very popular. A friend of mine recently left Goldman to work in a company that exactly does this. which is data labeling for machine learning models. Today, a lot of people are building a lot of models. They need humans to, label them. Eventually, this might go away when models become really strong. But right now, you need people in developing nations to do menial tasks and get paid for it. Where does crypto come into the picture here? Why do you need Web3? And the answer is micropayments. If you ever want to do micropayments, which is going to be a thing here, because someone will come on this platform. This will be the user side of this, or YouTuber side. A YouTuber will come, upload a bunch of thumbnails of theirs, let's say 6 thumbnails, click on a button, maybe pay $50, and then these $50 sort of need to be distributed amongst the 1,000 people who have actually paid. Harkirat, $50 divided by 1,000, nothing, is really small amount, yes, but it's less than 1 second of effort for the user. And when these users get thousands of thumbnails to choose from is when they will make substantial money, or even money at all. So this only works at scale. You need a lot of YouTubers or data labelers, whatever, to come and use the platform so that these 1,000 people don't sit idle. So network effects become super important in a business like this. If you're ever thinking of making one, we are just going to focus on the technicals of it. What are we going to learn throughout the video? As I said, the payments will all not be done through Razorpay, not be done through Stripe. We won't be doing any Web2 payments. We'll be doing Web3 payments. Simplest reason for that is micropayments. It's very hard to do, 1 rupee payouts or pay, 2% transaction fee on such a small amount. It's not difficult to do, but you could think of this being a forced use case. But this is one of those use cases that can actually, that crypto actually ends up solving a little bit, because you can program money and distribute it to 1,000 people, or let people stack money and take it out together, whatever they feel like. Versus if you have a standard Web2 Razorpay like model, you're sort of restricted. Even though I get this problem can actually be solved using that as well, and you can always just integrate Razorpay, make the user pay via Stripe or Razorpay, and then eventually pay out via the same. But we're going to use crypto. What will you learn? We will learn about number one. Let's see. So on the user side, the user will come and upload photos. So we'll understand how to upload photos, generally assets on S3. We'll learn about something called pre-signed URLs. Most probably, this is the easiest and the best way to do. Take user generated content that includes videos, photos, PDF, whatever a user might be uploading. You might have heard of tools like Multer in Node.js that let you upload a file directly on a server. This is bad. You shouldn't do this. You should never store user files on your server directly for security reasons, and also otherwise, if you have a distributed system, those files will die if your server ever dies. So you should always persist user given images or PDFs on an object store. So that's the first new thing you might learn from this. Second new thing you might learn is definitely Solana. Specifically, how do you let people pay via Solana? New keyboard, my bad. Pay via Solana and dispense via Sol. You'll probably learn about the Sol, what's it called? Wallet adapter, which basically lets you, it's a very easy bootstrap for you to let people pay via various wallets. For example, I have Backpack over here, Phantom over here. As the website developer, what code should you write? So you can open the person's Phantom and, ask them for some money. For example, in my wallet right now, I have $3,800. So how can I ask the person who's uploading to pay me $50 amongst these $3,800? How can I dispense it eventually here? We will not be doing any smart contracts. I will share a little bit of how to do this via a smart contract, but we won't be doing it in this system. Are smart contracts needed here? No, they're not. This should be a very Web2-like system, but there are downsides to why not using a smart contract here. We'll talk a little bit about the downsides next, but high level, this is what you should learn. Is there anything else? You learn a bunch about, handling payouts. This will be a place where we over-engineer, because you have to. Whenever you're paying people, you have to make sure you don't pay them out twice. If there are 1,000 people here, you need to make sure when you're paying them via the blockchain, they don't get paid twice, because once that money goes away, no government can help you recover that money. That money is gone. So this will be a very big hot path for us, specifically handling payments. So I'll share what that means. What is a hot path, and how do you make sure it's fairly secure? My bad. Yeah, there you go. How do you make sure it's fairly secure? Is there anything else you're learning? Standard full stack stuff, which is Nextjs, maybe creating a pretty UI, at least on the left side here. The right side that, the workers see is fine, can be fairly ugly. Yeah, that should be it. I think that's all we learned today. The most, hard to find thing might be the Solana bits, and, some knowledge here as to how you should ideally charge people. How should you ideally dispense people? We're not doing the most ideal thing here. So I'll discuss what is the most ideal thing and what we're doing and why we're doing what we're doing. That's enough context. Let's get into it. Let's write some code. Alrighty, I have broken everything down into the Web2 bits that we are going to learn about. Slash, if you already know, great. If not, we'll try to understand these things. And then the Web3 bits that you'll need to most probably learn. I'm assuming most people don't know a bunch of these things, what they are, and more specifically, how you implement them in a project. The Web2 bits include generally what are object stores, how can you take some content from the end user and put it in S3 or an object store for Cloudflare, an object store for GCP, whatever cloud provider you're using. What are pre-signed URLs? What is this approach of using pre-signed URLs to upload things onto S3? CDNs or content delivery networks, and why do you need them? You don't really need them here, but we'll use them and hence understand what they are. HTTP servers. If you don't know this, might be a good idea to do a refresher, but most of our application will be exposed over HTTP. So Express, how do you expose your functionality over the world, is something you should know / we will learn. Databases, Postgres is what we'll be using, and slightly asynchronous architecture. We will need workers to do something, specifically talk to the blockchain and check if a transaction has succeeded. So we will need, along with our core HTTP server, we'll need another asynchronous process that's running. What is that asynchronous process? Why do you need it? What is it doing on the blockchain is what we'll understand. These are the Web2 bits. The Web3 bits, first thing we'll understand is the wallet adapter. There are sort of very commonly available adapters on Solana, on Ethereum, that you can simply, well, as a name says, it's an adapter, right? So you can put into your React project and pretty much get something like this. If I open a random website, if you see a connect button here at the top right, you don't right now, but if I disconnect from here and click on connect wallet, this thing that you see, a pop-up that lets me choose a wallet adapter lets you sort of bring this in your application fairly easily and talk to the wallet that the user has already. Can you build it from scratch? Yes. Should you? Probably not. So what is this? How do you integrate it? Specifically for the Solana blockchain. Throughout, we will be using the Solana blockchain. We will not be doing ETH or any other blockchain yet, or at all. For this use case, you need extremely low gas fees, and hence Solana seems like a decent blockchain to pick. Signing messages. What are signing messages? Why do you need them? How does someone prove to a Web2 backend, to an HTTP server, that they own a specific wallet? For example, I own this wallet whose address is C2SH, so on and so forth. How do I tell an Express server that it is indeed me who owns this wallet? You do that by signing messages. We'll understand what they are and how do you do them. Transactions and signing transactions. The thing that we're learning here is just signing a simple text message. Hi, I am Harkirat. Transactions actually let you debit and credit money from someone's wallet. So how do you debit, let's say $100 from someone's wallet? How do you credit it into someone else's wallet? Is something we'll learn. If you understand this much, signing messages and signing transactions, there are a lot of use cases you can build yourself. If there is any Web2 use case where you have to accept payments via crypto, a good example might be, Amazon. Let's say if you have an e-commerce website where you want to allow people to buy, let's say, a camera, but allow them to pay via crypto. If you understand this, how to create sign transactions, or more specifically let users sign transactions, you can build this yourself. So for a lot of Web2 use cases that need Web3 payments, if you understand this, you're good to go. Indexing blockchains. We won't be indexing any blockchains, but why you should index blockchains in a use case like this. How ideally I would accept payments, or dispense out payments if I was building this in a super production worthy manner. Today we will not be doing this, but I will explain the architecture of why indexing a blockchain is good, what even is indexing a blockchain. We'll understand RPCs, what they are, why do you need them, and lastly, workers talking to the blockchain. This part is pretty much common on both the sides. The worker that we have here will actually be talking to a blockchain, which basically means we'll have some Solana logic here. What is that logic is something we learn. Cool. Those are the 2 bits. Let's understand the architecture. Let's understand the complete system that we'll be building. Let's do a high-level system design. All right, this is the final architecture of what we're building. There are a few boxes here. Let me explain each one of them and what they do. We'll also go through the system design individually of the Web2 bits and the Web3 bits. The first 2 things you see here and here are the 2 front ends for the users. This is the front end for the YouTuber / the machine learning model creator. They can come, upload a few photos that they want labeled / a few thumbnails that they want to know the click-through rate on, and pay a certain amount, let's say $50, and hit our primary backend. This will be a standard Web2 backend where this YouTuber / machine learning modeler would come, hit an endpoint with the payment transaction. Okay, I've paid $50, as well as a bunch of images. Okay, hey, this is a task that I want to create. They'll send a post request to create a task. How do they create an image? How do they upload an image to S3? And how do they pay is something we'll discuss in the next section. But once they have paid, once they've uploaded the photos, all they have to do is send a post request to /task that should generate a task for this user. They can keep polling the task, checking the status, have people already labeled it. And eventually when 1,000 people, 10,000 people label it, they'll get the final response from the backend that, hey, this is your final result for the thumbnails. On the other side are a bunch of, call them workers, call them mechanical turks, call them people who will be labeling all of this data. They will need to support, or the backend will need to support 4 endpoints for them. Number 1, an endpoint from which they can fetch the next task. This should return all the images that need to be labeled the worker needs to find the most clickable one, or just click on the most clickable one. Post to /submission, which basically lets this worker submit to the backend, hey, this is my result for these set of images. An endpoint to get back their balance, how much money they are owed by the backend, considering they've done, let's say, 1,000 tasks, then how much money have they made? How much money can they pull out eventually into their Solana wallet? And lastly, a post endpoint on /payout that lets them actually pull out the money from this parent wallet right here. These are the 4 endpoints that we need to support for the workers over here. These are the 3 endpoints we need to support for the YouTuber / machine learning modeler over here. There is a first endpoint I haven't talked about, which is get/generate pre-signed URL. I'll be getting to that in the next section. There are a few more boxes here. Let me quickly take you through all of them. The parent wallet is pretty much a wallet that looks like this. For example, I have a wallet here that has $3,800. Whenever someone comes and, pays $50, these $50 reach my, or, the admin of the website's wallet, which basically means this amount goes up to 3864.62. And as people label this, as people, earn some money on this side, eventually, whenever these people want to take out the money, they will take out some portion of this $50. If there are 100 people labeling, each one of them will pull out 50 cents from here, so that, the money is distributed to all the people who have worked on this specific assignment. The database is a standard Web2 database, Postgres database, where we'll be dumping all the tasks, all the submissions that these guys have made, the final results, how much money is owed to each one of these workers on the right. Workers / transaction sweepers is something important. We'll be coming to this in the next section. But basically, whenever you let people pull out money, right, the blockchain is extremely unreliable. So you have to keep checking on the blockchain. Hey, has this payout already happened? Did this payout fail by any chance? If it failed, you need to allow the person to re-withdraw the money. But generally, the blockchain can be highly unreliable when it comes to, payouts like these. So you have to have a worker that's constantly checking, hey, was this payment that Harkirat asked for paid out or not? And if it hasn't been paid out, then of course you let the party know, hey, the transaction failed, please try again. Lastly, RPC and the Solana blockchain. RPC stands for remote procedure call, or RPC servers in this case stand for servers that let you talk to the blockchain. Whenever this person pays $50 to the parent wallet, right? Whenever this $50 transfer happens, it happens by this person signing a transaction and sending it to an RPC server. If I go to my Phantom wallet here and try to send, let's say, 50 USDT to a certain account. Oh, oopsie daisy. When I click on send, an HTTP request goes out to an RPC server. The same happens for a wallet like Backpack. You can't directly talk to the blockchain. You have a bunch of people, or, a bunch of miners, a bunch of smart people who have deployed servers that directly talk to the blockchain or are actually part of the network. Whenever you want to submit a transaction, whenever you want to send someone money, not receive money, but like do anything on the blockchain, you have to talk to these RPC servers. These are just a network of computers that make up the blockchain. If I go to settings over here and somewhere here, I'm sure I can find an RPC connection. As you can see, it right now says Backpack default RPC, which means Backpack has an RPC server that they pay for And if I click on send, my request goes to this RPC, but I can change that. I can change it to a custom RPC of my own. I can put my own server on the blockchain. Usually you rent these RPC servers, and that is where you send out your final transaction. Why do we need them? Considering Harkirat, this person will come on the website and pay via their Phantom wallet. So the transaction would go directly to the Phantom RPC, or in this case, the Backpack RPC. Why do we have to have our own RPC server? And the answer is, whenever our backend, pays out money, or more specifically, whenever this user asks, "Hey, I need my $20 to be paid," they will send a request to /payout. And this needs to send a request to the blockchain. Okay, hey, this person has asked for a withdrawal, so we need to withdraw their money. There you go. Let this person withdraw $20. This transaction goes to an RPC server from which it reaches the Solana blockchain, which is why we need to have the backend or the developer, just like how they have an AWS account, they need to have a QuickNode is a company that lets you create RPC servers or get RPC servers. Tritium is one. Helios is one. So just like you have a Solana, just like you have an S3 account, an AWS account, you will need to have a Tritium account or a QuickNode account on which you get this RPC server URL that your backend will hit with a specific transaction that says, hey, pay out $20 to, whatever, Harkirat, who is one of our workers who's done 1,000 tasks and hence deserves $20. That's a brief of all the systems over here. If you don't understand some of them, it's fine. Let me break this down to 3 important tasks. There are 3 high-level tasks that our backend needs to support. By high-level tasks, I mean harder tasks. Everything else is fairly straightforward. Creating a task is simply an entry in the database. Submitting a task is another entry in the database. The difficult bits are, or the bits where we need to learn something new, are these 3. Letting a user upload a photo, letting users pay and verify that they have paid, and allowing labelers to pull out money from their own wallet. Let's discuss all of these one by one. Alrighty, letting a user upload an image on S3. We're going to discuss a very common pattern. If you ever have a website like YouTube, where people need to come and upload videos of their own, or a teaching website where a teacher can come and upload a PDF, for example, or in our case, someone can come and upload a bunch of images. There are a few architectures you can follow to do this. Architecture number 1 is, hey, the user directly sends an image to your backend, and then eventually on your backend, you store the image in some folder like a.jpg. This is a bad approach. You should never take the image from a user and directly store it on your backend. Storing any user-generated assets on your server, number 1 is a security vulnerability. You don't know what the file has and if somehow they're able to execute it. Number 2, they could fill up your servers. Your single server could have 10 GB files. What if they send you a lot of files? You could argue, Harkirat, I will limit. They can only send 2 MB files, or have some sort of a limit. Reasonable. But the biggest problem in this approach is you can never create a distributed system. You can never have multiple backends, because when the user uploads a photo, it goes to backend 1, and then backend 2 has no idea of this image. This image should ideally go to a centralized store so that all of your backends can share it. You should never, take photos from a user and directly upload it on a backend. A lot of companies do. In fact, a GSOC organization does. We had a video on it where we saw it directly getting stored on the backend server. But this is a bad thing, bad practice generally. You shouldn't do it. Then where should you store user-generated images? And the answer is you should store it in some sort of an object store. The object store, as the name suggests, is a place where you can dump objects. In this case, we are letting users dump objects in an object store. The one that we're using is S3, which AWS provides, but GCP has its own, DigitalOcean has its own. You can use whatever object store you want. Here also, there are 2 architectures. You can either take the photo from the user, bring it to your server first, and then dump it from your server over to S3. The reason for this is your AWS credentials, your password for AWS is stored on this backend server. You will never give it to the front end of the user. If this front end has your AWS password, then this user can, pretty much tamper with your AWS, do a bunch of shady things here, delete all of your S3 buckets, stop your servers, so on and so forth. So you don't want this password to be stored on the client, which means this AWS password is stored on the server, which means this user first needs to send a video to the backend or image to the backend. And since we have our AWS password here on the server, we can forward it, this specific image, over to S3. This is one architecture to follow. Okay, you take the image from the user, bring it to the backend, and then from the backend, you dump it over to S3. Then you have an entry in your S3, an image in your S3 that your user uploaded. The problem with this approach is your backend server is doing a lot of heavy work. It is first bringing an image here and then eventually dumping that image here. This can be a very long process, can take up to 10 seconds, let's say. A lot of times these backends run on serverless architectures where you can't access the file system. You shouldn't put images on the file system, which is why AWS or generally object stores have this concept of pre-signed URLs. What is the problem letting this client directly upload the image on S3? The problem is you don't want the browser, you don't want the client to have complete access to your S3. And hence S3 has this concept of pre-signed URLs. Okay, hey, if this person wants to upload an image, they can ask the backend for a pre-signed URL. What is a pre-signed URL? It means the backend will sign a specific URL, or it'll tell S3, okay, hey, I'm going to send you an image eventually. Give me one URL where I can send it. And S3 responds back with a URL, okay, hey, whoever wants to upload the image, give them this specific URL and I will let them directly upload the image here. So what is the first request that the frontend should send to the backend? They should send a request to generate the pre-signed URL. This URL will be generated by the backend because the backend has access to your AWS account, and return the URL here. Now using this URL, the client can upload directly on your S3. It can send the a.jpg directly over to S3. It doesn't have to send it to a backend that needs to proxy it. It has access to upload one photo. A pre-signed URL is just an access for one photo with certain limits. Okay, hey, it should be a JPEG, should be under 2 MB. Allow whoever has this pre-signed URL to send one photo to my S3. It's fine. I give them permission. You are giving them limited permission on your S3. You are not letting them hack your S3 or take over your AWS account completely. You are not giving them the AWS password. You are giving them a single pre-signed URL, which allows them to directly upload a photo in S3 and get back a URL. Okay, hey, your photo has been uploaded on something like this. This lets this admin over here, or sorry, the thumbnail generator, the YouTuber, directly upload images, get a bunch of URLs that where they've uploaded the images. And now whenever they're sending a request to create a task, they can just let the backend know, hey, these are the 3 places where my images are present. These 3 images are actually present on your own AWS. So, feel free to pull them from here. So the second endpoint, before it is called, there is a prerequisite of the user uploading the photos first directly on S3 and generating a bunch of URLs for it. That is the first hard thing we had to do. What did we learn? We learned that you should generate pre-signed URLs if you want to ever allow other people to upload assets on your S3. This includes use cases like YouTube. If you're ever building YouTube, you shouldn't take the MP4 and bring it to your backend server. You should take the MP4 and let the user dump it on an object store of yours, for example, S3. And this becomes even more prominent if this is an MP4. If this is a 20 GB MP4, you don't want the user to send you a 20 GB MP4 and then eventually dump it here. That's too much data for your backend server to handle. You want to give them a pre-signed URL and let them directly upload this 20 GB file to AWS. AWS handles all the heavy lifting of taking the stream and dumping it here on S3. That is the architecture we'll be using to upload photos. We'll be coding this very soon. It'll actually be less than 20 lines of code to, do the backend for sure. Frontend shouldn't be too difficult as well. So yeah, that's a scalable way to do user generated content. If you ever have user generated videos, PDFs, images, any file you want to take as input, never put it on your server. It could have a vulnerability. Always dump it directly on S3. How can you take an image from a user and directly dump it on S3 without giving them access to your AWS account? By generating a pre-signed URL, by giving them a URL, okay, hey, here is a URL. It will let you upload one photo at this specific path. Please go ahead and do it. And the frontend can upload a photo over here. Harkirat, what if there is a network issue? Then this user can just refresh, generate a fresh pre-signed URL and, upload a new photo there. That's a brief of how you let people upload photos. This is the most, generic way for you to take user generated content. Next up, we'll be going through the second difficult step, which is letting users pay and verify payment to their backend. This is a very complex, Web 2 plus Web 3 problem. Web 2 plus Web 3 problem. The same problem comes if you ever create an exchange. The same problem comes if you ever create a gambling website like Stake. In all of these websites, you want to allow users to deposit some Solana and the same thing, or some USDC. The same thing is what we want. We also want users come to our website, and whenever they want to pay, for example, whenever this person wants to create a certain task, my mouse is dead, they need to pay us $50, right? This in itself is a challenging problem, and we'll be discussing how you solve it the right way, how you solve it the wrong way, and how we found a middle ground between the right and the wrong way to get by today. All right, letting users pay and verify the payment to the backend. If you're thinking of building an e-commerce website where you want to accept payment via crypto, if you want to create some course website where you want to accept payments via crypto, if you want to build this use case, architecture remains the same. If you understand this, you can extend this and build your own crypto payment gateway, for example, that other people can use and integrate payments into their systems. What do we have to do? Whenever a user comes and uploads the task, which means the set of images that they want to be labeled, they need to make a $50 payment. This $50 payment needs to reach from here to the wallet address of the admins of the website. This is actually fairly easy to do. You can just ask this person on the front end, hey, please send $50 over to a different wallet address. So as you can see, I have a few wallets here. I can just ask the person over here, hey, open your Phantom, go to a specific wallet that you have and select Solana or USDT, whatever. And just send, for example, 1 Sol, which is equivalent to $144 over to this address. They can just come to their Solana wallet, click on next, click on send, and the money will reach the parent wallet over here. That's the easy bit. You can also show them a pop-up on the website that automatically opens a wallet like this and says, are you sure you want to transfer $50? They click on accept. The money goes from here to here. That's the easy bit. The harder bit is letting the backend know, hey, I made this transaction, this specific task that I want to submit, here is the $50 payment for it. I've done that. Why is this hard? Let's take a step back and see how this would happen generally. If I have this wallet, account 30, I will pay, let's say this is a $5 transaction that needs to be made. I can simply send the $5 over, which will be whatever, 0.05 Sol, over to the parent wallet address that the website would give me. Or as I said, the way we'll be writing the code, Phantom would automatically pop up with something like this. Hey, are you sure you want to send $5 to this other address? And you can just click on send. Anytime you send money over to a different account, a transaction is created. For example, a transaction is created here that I can track on solscan.io. If I go over here, it shows me that this was a successful transaction. If you look at the transfers that have happened, 0.05 Sol was transferred from here to here. As long as the user returns me this transaction signature, I repeat, after they've made the $50 payments, they can get the transaction signature here and they can send me that transaction signature, which is this very long string, along with the URLs that they want, and my backend can verify, hey, $50 payment was made. My backend can actually hit the Solana blockchain and check, hey, is this signature valid? Has $50 been paid? And if the answer is yes, I can sort of verify that this person has paid $50. That's how you would, in a naive way, make the person, after they've uploaded the images, make them click on a button that says pay $50. That will pop up a wallet like this. They can click on confirm. They will get back a signature. They just need to transfer that signature back to the backend when they're calling the /task endpoint, along with, of course, the images that they're sending. There is one small flaw in this approach though. Can you guess what it is? The flaw is this transaction has been made on the blockchain and then the front end is sending us this to the backend. What if the user's internet goes down as soon as this transaction was made? So the transaction succeeded. $50 were sent over here, but the front end went down, the user refreshed. There is no easy way for the wallet to tell the backend directly, hey, this transaction was made, or the blockchain to tell the backend directly, hey, this transaction was made. We are relying on the user to give us this specific transaction signature. Flaw number one, if the user refreshes the page, they have paid us $50, yet they weren't able to create a task. You might be able to get around this by storing this transaction signature in the local storage, and when the user refreshes, resending the task. That's fine. The bigger problem is, as soon as I pay this $50, someone else, some other YouTuber might say, hey, this transaction was made by me. Please complete my task. There is no easy way for you to connect the wallet of this user to the account of this user. So another people can snipe this transaction. A different YouTuber can come and say, hey, this transaction was made by me. Here is my task to it. We haven't associated the wallet address, whatever the transaction signature is, whatever this transaction is. This transfer happened from this wallet to this. We first need to associate this wallet address with this YouTuber's account. So we know that this transaction was made and the $50 belong to this user and not to a different user. So that is something extra we have to do. If we don't do that, then anyone can send this transaction signature to our backend and be like, hey, I made this transaction. We don't know who owns this 8FCXUD wallet, right? So since we are expecting the user to do sequential things, we are first expecting them to upload images, then expecting them to do a transaction, and only then asking them, hey, send us both of these together to a post endpoint. Because we're doing it this specific way, which is an insecure way, the transaction can be hijacked by someone else. The transaction was made by this user. Someone else might be like, hey, it was made by me. Please create my task. How can you get around this? Ideally, you should do something called indexing of the blockchain, which is how an exchange would, if you go to backpack.exchange, if you go to Binance, if it opens at all, the way you submit money here, or if you go to stake.com, if this is a gambling website, oh wow, where also you can, send money or on-ramp crypto, send crypto to them. There the architecture is slightly different. We are not following that architecture, but that is the right architecture. We'll be learning about that architecture when we build an exchange in the Web3 cohort. But this is good enough. This is secure. If you first put in your database, if this is your DB, if you first put in your DB, okay, hey, whoever this user is, whoever this person is, their wallet address is this. So user with ID 1 has wallet address of this specific thing right here. Then if this transaction signature comes from a different user, you can reject it. You can be like, hey, you didn't pay the money. It was paid by the user with ID 1. So I will not let you create a task. Only if this user sends me the transaction will I create a task in my database and say, okay, yes, you have paid the $50. So what have we learned? We have learned a slightly ugly way to accept transactions from the users. In this ugly way, we first expect the user to link a wallet to their account. We expect them to come to the website and tell us, hey, I own this specific wallet address. Please put it in your database. Then we expect them to create a transaction like this and, send us the transaction signature, which we eventually create a task from. The backend, of course, verifies this transaction signature is for $50. 0.05 Sol is like $7. So, the backend can verify this transaction indeed paid the right amount, and hence will create the task. If there is anything fishy, if the amount isn't right, if they did not send USDC but send some random token, the backend can always reject this specific transaction and be like, sorry, you have not done the right prerequisites. What are the prerequisites for a user? First, upload your images, then do a transaction, and then let the backend know, yeah, these are my images for which I want to create a task, and this is my transaction signature. Please create a task for other sides to deal with it. That's how you do payment acceptance in a slightly ugly way. What is a better way? Maybe I'll discuss towards the end of the video. This is complicated in itself if this is the first time you're doing it. Let me quickly recap. What will happen? The user will come to the website, use a bunch of pre-signed URLs to upload these images to the S3 account of the developer. Then they will do a transaction on the blockchain. They will send over $50. They will have a button over here. They will click on a button. That button will pop up their wallet as long as they have a wallet. If they don't have a wallet, they of course cannot do any tasks, create any tasks. This website is a very crypto native website for people who do have wallets and do have money in there. They click on the button that says $50. A pop-up comes up. We'll go through the code of how you can, ask a person for $50 or ask them to make a payment. A pop-up will come. They will confirm the pop-up. The $50 will go from here to here. The front end will get back a transaction signature. And then this transaction signature along with all of this content is what will be sent to the backend and a task will be created. That's how you let users pay and verify payments to the backend. Are there any flaws in this? There aren't any flaws anymore since we are storing this mapping in the database. So no one else can snipe your transaction. But there's an extra step. We are asking users to link their wallets to their accounts, which people are a little finicky about. People don't like that. And generally also, there is a leaner way to do this, how exchanges do it, how gambling websites do it. We'll come to that probably towards the end of the video where I'll explain this architecture a little bit. Let's get into the third thing. The third thing we have to do is allowing labelers to pay out dollars to their wallet. What is happening right now is this is the front end for this user right here called thumbnail CTR finder. The user comes, pays $50 to a wallet, and this wallet now has a balance of, let's say, $50. This is the backend. This is the workers front end, which the Turks from, what should I call them? Helpers front end. What are helpers? The people who are actually labeling the tasks, the people sitting on the other side who are trying to label the CTRs or thumbnails. As these people do more and more tasks, as a bunch of people submit tasks, these people do 100 tasks, they will see in the Postgres database their balance. Their balance, let's say, is $20. All these users will see that they've worked so much, and hence, let's say one such user has a balance of $20. We need to allow labelers to pay out dollars to their own wallet. We need to allow, since the company owes you $20, you should be allowed to pull out 20 amongst these $50 to your own Solana wallet. Whoever is the helper has their own phantom wallet over here. They have their own address and they can pull out money from here to here, or they should be allowed to pull out money as long as it reaches a certain threshold, let's say $10. If it's just 5 cents, then they probably shouldn't pull out because they probably shouldn't take out the money because 5 cents may you have to pay, 5 cents in gas. So you pretty much will not make money. So there should be a minimum threshold. As you keep doing tasks and if you reach the $10 threshold, you can pull out money. You can ask the wallet, the parent wallet, to send out money to you. How do you do this is the third thing we're dealing with. If one of the helpers told you, okay, hey, I have a balance of $20, please send it to me. How can we take money from this wallet and send it to them? The request that the user will send would be, hey, I am user with ID 1 and I need to take out all of my balance to a wallet address that, maybe looks like this. So please send me all of my payout over to this wallet address. This is the request that will be sent by the helper. And what does our backend need to do? It needs to debit $20 from here and send it over to the blockchain. Now you might ask, the backend though doesn't have a phantom wallet. How will the backend be able to send money? That's a good question. Backend is a simple EC2 machine. It's not a browser. So, the phantom wallet you see here exists in the browser. Whenever the user is paying, we can make them pay through a pop-up. This is a user-friendly way to ask for payments. But our backend is a simple terminal. How will our backend send $20 amongst this $50 over to someone else? And the answer is, this is just a front end for your wallet. Your wallet has a private key. If I go here and, click on export somewhere here, show private key. If I click here, I will get a private key. It's like a password of my wallet. If I show this private key and whatever that private key is, I put it on my, this is that long private key. I put it on my server. Then I can just use the Solana command line interface, the Solana CLI, to send over $20 or whatever I want to a different wallet address. I can simply call, Solana .send $50 to some, address, whatever is the address that the user gave me. So all I have to do is do a function call like this, which will hit an RPC server and eventually do the transfer. So it's not too difficult to send the money. The problem is that the blockchain is highly unreliable. You cannot do this. You cannot be like, okay, you sent me your address. Let me talk to the blockchain. Let me do a Solana.send and assume it will succeed. You cannot from your database remove, make this $20 go down to $0. Hey, we have already paid you until you have verified the transaction. So this Solana.send function, we need to send the transaction. We also need to keep verifying it. We need to make sure that the money has actually reached the other side. And if it hasn't, we should revert this back to $20. So we'll have to add some locking mechanism, which means when the user comes and sends the transaction, we will lock the $20. We will say, hey, we still have your $20, but it's locked. You can't re-ask to pull the money out. This $20 is no longer, we still have your $20, but it's locked. And whenever the transaction does succeed, then you can take the balance down to $0. If it doesn't succeed, then you can take that money down back from logged to the normal state. So you need to do a lot of reconciliation. You need to have the worker. If you remember the original architecture, in the original architecture over here, I had an extra thing called the worker/transaction sweeper. After you have submitted the transaction to the RPC, hey, the parent wallet needs to pay the other side $20. This worker needs to keep checking the transaction signature. Every 20 seconds, it checks, hey, is this transaction succeeded? Has this transaction succeeded? If it doesn't succeed for 5 minutes, then the transaction will never succeed. And you can revert the user's $20, or you can retry the payment. You can again call Solana.send money. Or if it does succeed, then you can make the balance in the database 0 and let the user know, hey, we have made the payout. You should receive $20 in your wallet. If you do not understand this, it's fine. You will understand it when you reach the final thing. The only caveat, the only thing to know here is we do need a worker that keeps checking transaction signature. Blockchains are highly unreliable. So you cannot simply call a function and assume that the money has gone from here to here and take the balance of the user down by $20. You need to wait. You need to have a worker that's constantly checking all the transactions. Let's say there are 50 people who ask for money, then the worker will need to go over the 50 transactions from time to time and make sure have the transactions succeeded. If they have, great, take the money down to 0. If they haven't, then in the database again change the balance to $20 and let the user know the transaction failed, please retry. The user can then retry, or you can manually keep retrying until the transaction succeeds. That's how an exchange does it as well. If you ever go to an exchange, click on withdraw after you've signed up and you have your wallet balance. If you click on withdraw, it doesn't immediately come to you. Sometimes it takes hours. If the blockchain is clogged, you will see in Binance a lot of times people tweeting out, hey, I'm not getting my money, I'm not able to withdraw. The reason for that is the blockchain itself is clogged. So whoever has written the logic of the exchange will slowly keep retrying every few minutes, every transaction that is there. That's what this worker's job is. People have submitted that they want to withdraw, but the blockchain is clogged right now. So we will keep retrying, sending them out money. And if it doesn't happen for 5 hours, then of course you can just revert the database and tell the database, hey, the money isn't logged anymore. The user can try to pull out $20 again if need be, but we weren't able to send them the money over to their wallet. Did not understand it, it's fine. We'll reach there when we reach there. This is the last part of what we'll be implementing. The very first part would be just implementing this bit, fairly Web2 bit, allowing people to upload a photo. Second part we'll be implementing would be, allowing labelers to be able to label it and, storing something in the database. Okay, hey, every user has made $20, $10, whatever that amount is. And then we'll be getting into the crypto bits. Okay, how can you accept payment over here? And how can this user click on a withdraw button to withdraw the money out from the parent wallet over to them? This is still an insecure way to do this. If you ever go to an exchange or even stake.com, a gambling website, the parent wallet's private key is not present on an EC2 machine. What will we be doing? We said, the backend will have a private key over here and on an EC2 machine. And all I have to do is Solana send $20 to some address and the money will go away. But this is highly insecure. You shouldn't store the private key that I have here in my browser. If you remember, I was able to export the private key, right? I was able to go to settings, accounts, open an account and export private key. I have currently stored it somewhere in my browser. It's in a secure place. So, it's very hard for any random application to read it on my machine. But still, if I have a malware, they can actually read this. And similarly, if you have an EC2 machine, if some AWS engineer opens your EC2 machine and gets your private key, you're screwed. They can take all the money from here. So this isn't the right way. Storing private key on an EC2 machine isn't the right way to do payouts. And you should do a different way. What's a different way? Very complicated. Something called, you can do a few things. MPC is the most common architecture for this, where you have, don't even worry about it. We'll be building the most simple bit here. And this is good enough for most use cases. In fact, a lot of companies holding billions of dollars in value also do this. Shouldn't do it, but they do. If you look at exchanges though, they are highly regulated. They cannot do this. So, you cannot be storing a single private key on a server. One of your developers could just go into your server, get the private key and, screw you up. So that's a brief. Let's start the coding. I think that's enough architecture discussion. And just to quickly recap the complete architecture, what are we building? We're building a website like this, where on one side, a machine learning modeler, a YouTuber can come and submit a task. Task could be anything. A simple task could be a YouTuber can come and upload all the thumbnail variants. They first upload it to the S3 of the user using S3 of the developer using pre-signed URLs. Then they do a $50 transaction using a wallet like this. And then they let the backend know using this /task endpoint, okay, hey, I'm creating a task with these images and this payment. Please create this task and let the other side know, let the people in a developing nation know, okay, they need to click on the most clickable thumbnail over here. They can keep polling the tasks as well. Okay, hey, what's my status? Have people started to vote? How many people have voted? What is the most popular thumbnail right now? For these guys on the right side, they have a few endpoints. The first endpoint is, hey, can I get the next task to do? They will constantly want tasks. They want to make money. So they'll keep polling this endpoint. What's the next task? What's the next task? They have a post endpoint to create the submission whenever they click on an image that they think is the most clickable, that reaches this backend and hence reaches the database. They have a balance endpoint to get how much money do they currently have based on all the submissions that they've made. And lastly, an endpoint to initiate a payout. This will initiate a payout, but a payout is a highly asynchronous process. It doesn't happen immediately. This endpoint needs to, number one, submit a transaction on the blockchain. Number two, the worker will keep polling the database. Okay, what are the pending transactions? Whenever this guy submits a transaction on the Solana blockchain, it will also put it in the database, and the worker will keep polling the database. Okay, hey, any pending transactions? Okay, there are 5 of them. Let me check. Have they been succeeded? If they have been confirmed, then great. It can let the database know, okay, the payout has been made. You can do a minus $20 on this person's account. But if it did not succeed, then it can let the database know, okay, the transaction failed. The user will see the transaction has failed and they can reinitiate a transaction. Again, hit the payout endpoint and then the process restarts. The payout endpoint again submits a transaction, submits it in the database, worker polls it, and then eventually if it succeeds, the worker debits the account in the database minus $20 and lets the user know, hey, you've been paid out. The user can just go into that wallet and see the $20 that they've been paid in a wallet like this. If you're not completely crypto native, you might ask, Harkirat, where is the INR? How will these people get paid by INR? And that's a good question. You can always off-ramp money, which means, convert your crypto over to INR. In fact, if you ever want to do this, you'll get much more than dollars. If you have $1, you'll get like 90 rupees versus 83 rupees because the demand for USDC and USDT in India is slightly higher than the dollar price, which is why if you ever want to sell $1, you will get back 90 rupees. And there are like standard exchanges in India that let you do it if you ever want to off-ramp. But that is not a task for this application. This application is a pure crypto native application. Take money from one side, send it to the other side. With that, let's begin the coding. Let's get the Web2 bits out of the way. Let's quickly code a simple system that lets people upload photos on one side and, other side vote on those photos. All right. I've written down a list of steps that we need to follow to build something like this. I think this is a fairly comprehensive list. So if you go from top to bottom, you should be able to build the application by the end of it. I've broken it down into Web2 bits first. So for the people who just want to understand how you would build an application like this and not worry about any Web3 logic, you can follow steps from 1 to 6. Then there are a bunch of extra steps if you want to actually, log in using your wallet and then pay using your wallet, so on and so forth, and then dispense it out. So feel free to pick and choose which one to choose. But the first section is pretty much going to be extremely Web2 heavy. So if you only know full stack and are not here for any Web3 bits, feel free to just, focus here. Let's get into it. First step is we need to create a Node.js Express backend server. This is pretty much this backend that I've talked about, our primary backend that both the front ends will be hitting. Ideally, this should be a monorepo. There are 3 applications here, a backend, front end 1 and front end 2, and a worker. So there are actually 4 applications. Feel free to pick and choose. I don't think I'm going to use a monorepo just to keep things straightforward. But ideally, there should be a lot of code sharing between both of these. So you should have some sort of a monorepo setup so you can share code between front end 1 and front end 2. Let's create a simple Node.js Express backend. I would call this decentralized Fiverr maybe. It's not really Fiverr, but you get the idea. Let me open this up in Visual Studio Code and let's go from there. All right, inside this, I'm going to first create our backend. I'm going to call it backend. I guess that should be straightforward. I'm going to initialize an empty TypeScript project in here. npm init-y is the first command that I ran to create a package.json. And then I'll run npx tsc --init to initialize a tsconfig.json, since this is going to be a TypeScript project. Inside our tsconfig, I'm going to change out_dir to be /dist and source_dir or root_dir to be /src. If this command doesn't work for you, you can also just copy over tsconfig from some random project and bring it over here. Next up, I'm going to create a source folder inside which I'm going to create index.ts, which will be our primary entry point file for this specific backend code. Eventually, we'll be adding more folders here: frontend 1, frontend 2, and the worker. Index.ts needs to be an Express application. So the first thing you have to do here is npm install Express and add types/express and create a simple Express server. There are a few endpoints we need to support. So let's look at what those endpoints are next. Or let's just follow the steps. Maybe there's something else. Create a Node.js Express backend. Done. Create AWS credentials. We need to allow the very first endpoint that we need to support, if you remember, is the generate pre-signed URL endpoint, which means our backend needs to be able to generate this pre-signed URL, which means our backend needs to have some credentials of my AWS account. So if you don't have an AWS account right now, you can either get one and follow the steps I am doing, or you can just expect the user, whoever is coming, to post URLs. Okay, give me the URLs of your images. You don't necessarily have to upload them to my S3. So you can change the application logic a bit. Okay, whoever is the end user that comes, they need to put in URLs. They cannot upload an image, on your website. So if you don't want to get into the complications of pre-signed URLs as well as hosting data yourself, then feel free to just change the application a bit. I am going to build it the right way, which means allow users to upload images to one of my buckets. So the first thing I have to do is create a bucket for the user to put in images. The way you do that is you go to S3, which is the object store of Amazon. Again, if you do this on GCP, fairly similar steps. You create a bucket over there or whatever is there alternate for a bucket. If you do it on Cloudflare, you create a bucket over there. I'm going to name it decentralized Fiverr. I'm going to add 2 R's because this name used to be unique across all AWS accounts. I'm pretty sure this is already taken, but we'll see. Everything else should be straightforward. Block all public access should be checked. You can check this off if you want to keep your life simple, but we like to keep things hard, which is why I'm going to block all access and eventually add a way to expose my images. If you don't do this, your bucket is basically open to the world, so anyone can visit your S3 URLs, which is mostly fine for this use case. You're not storing anything weird here, but yeah, this is the right way to do it. Disable all access, create bucket. And now I have a simple decentralized Fiverr bucket. I can upload images here. So if I want, I can go here, click on add files, select a random image from my desktop. Oopsie daisy, probably. Yeah, this one's fine. And then click on upload. When I do, it's like Google Drive. So, I was able to upload an image somewhere that if I try to access, it is blocked by default. If I try to go to decentralizedfiverr.s3.amazon.com/ whatever this PNG file is, it doesn't work. And this is good practice. You should have your S3 closed to the world and you should expose all of this over a CDN. If you remember the initial set of things that I shared, the things that we're going to learn, oopsie daisy, there was S3, pre-signed URLs, and CDNs. This third thing is what we're going to focus on next, which is how do you expose images over the internet, over a CDN, given you already have them in your S3 store? And the answer is, you can use something called CloudFront, which is the CDN or the content delivery network of Amazon. Content delivery network, as the name suggests, lets you deliver content. Why should you do this, Harkirat? Why should I not just expose it like however it was exposed, something like on this S3 URL? And the answer is, number one, S3 URLs are expensive. CloudFront is significantly cheaper than directly hitting your S3 URL. Number two, content delivery networks, as the name suggests, are used for content delivery. They cache a lot of data. So if a lot of people all around the world ask for this specific, file, this image that I just uploaded, if this is the world map, this image is present over here. But the CDN, the content delivery network has a bunch of servers all around the world. And if a lot of people in India from this location ask for that image comes from the source to this POP, which is called what is the full form of a POP? I don't remember. But this is every CDN, or specifically CloudFront in this case, has a bunch of POPs, which means edge servers all around the world. This is your S3 where your image is stored. But if a lot of people in India ask for that image, it gets cached over here, and everyone in India gets it from here. That is why you would want to use a CDN over directly, everyone in India also hitting the S3 URL. This is also why S3 URL, getting data from there is much more expensive than, getting it from POPs. So what's the next step? Create a CloudFront distribution. What does distribution mean? You are trying to distribute your data, right? You have images in S3, this thing right here. You want to create a CloudFront distribution that can sit on top of your S3 and, serve all of the images from there. What is going to be the source of my images? It is going to be decentralized fiverr.s3.amazon.com. This is where it needs to, pick all the images from. Origin access bucket must allow public access. We don't have this, so we need to add origin access control settings, which basically means, our bucket isn't public. There needs to be some origin access control, and need to most probably create a new one here. Call it Fiverr, and then for the specific name, all right. It gives you a hint over here. You must update the S3 bucket policy. We will eventually. CloudFront must provide you that. That's fine. Everything else should be the same. There is no need for you to do any more optimizations. If you want, you can change how the caching should happen. Doesn't really matter in our case. This is not a, just select no over here, else you'll get charged. This is something I forgot in the cohort, and a lot of people got charged. You must be verified before you can add a new CloudFront URL. What the fuck? All right. So this will take me some time to get verified. For you, it should be fine. You can create one CloudFront distribution for free, and after that, you need to upgrade your account. I don't know. So what happens when you click on create distribution is it gives you a policy. You must update the S3 bucket policy. It basically gives you a very big JSON, and you need to go back to your S3 bucket, which in my case is, the decentralized Fiverr S3 bucket, and go to permissions over here, click on bucket policy and paste the bucket policy that you got, click on save, and then you're good to go. If you do follow these steps, I thankfully have another bucket called Harkirat CMS. I also have another CloudFront distribution that I had already created for it. If you look at this distribution, it points to Harkirat CMS.s3. whatever. So if I click over here and copy this URL, this is my CloudFront URL. This is how I can distribute my files. For example, if I, in this Harkirat CMS repo, if I put a new file over here, for example, maybe this screenshot that you see. If I click on open and upload, this thing gets uploaded where? To the Harkirat CMS bucket. If I go here, I can see this image. But again, if you remember, if I click on it directly, it doesn't work. By default, it is blocked, but it is exposed over this CloudFront URL. If I go here, then you can see the image that I had just uploaded. So this is how you, number one, create an S3 bucket. Number two, expose the S3 bucket over CloudFront. What is the benefit of using CloudFront? Number one, it is cheaper. Number two, it is distributed. It has it's called a content delivery network because it delivers content in a more efficient way than, directly serving from these URLs. Can you directly do this? Yes, you can open your S3 bucket totally by going here and, oh, this isn't S3. By going to the specific bucket that you have, going to properties, permissions, and then, disabling block all public access. Should you do it? No, you shouldn't do it. You should have an S3 plus CloudFront. CloudFront. S3 plus CloudFront usually go hand in hand, which basically means, if you have a use case where you're uploading videos, PDFs, images, you store them in S3, you distribute them via CloudFront. I've shared the steps. This is the bucket that I will be using because I already have a bucket called Harkirat CMS. And I can't create a new distribution, but you can create your own bucket, you can create a corresponding CloudFront distribution for it, just like I have, and you will get a URL like this. Now, any image that you upload to this S3 can actually be accessed from this URL. For example, if you go here, course thumbnails /adhoc.jpg, if I open this URL directly, it will not work. But if I replace the base URL with the CloudFront URL, then I can get back a course thumbnails /adhoc.jpg, which is this photo right here. So that's a brief of, creating number one, an S3 bucket. Which one did we create? We created decentralized Fiverr. Why did we not pursue this one? Because I wasn't able to create a distribution because my AWS account only lets me create one. So I'm using an old one. I already have a bucket called Harkirat CMS. I will just reuse this. I also have a CloudFront distribution for it. So I can allow my end users to now upload a video, maybe in a folder somewhere. Let me create a folder here called, Fiverr, and all the incoming images that my users will send, I will send over to this Fiverr folder so that, my bucket isn't polluted and, the subtitles remain separate, thumbnails remain separate, and all the Fiverr logic that comes remains separate. Let me also delete this image. Now, if I go back to Harkirat CMS, it has a new folder. This is where I'll be uploading all the end user files. Question is, how do you do it? How do you create AWS credentials? So your backend can generate a pre-signed URL and return it to the user. That's what we'll be understanding next. We have an AWS account, and I can access it from this GUI, but I can also access it programmatically. What does accessing it programmatically mean? It means I can have a Node.js backend that can create a pre-signed URLs on this account and return it to the user. I can also have a Node.js backend that can directly upload an image over here. We're not doing that, but you can always export a key from here, or, create a user over here that has limited access and take the key of that user and put it in your Node.js process. That's what we're doing next. For that, go to, I totally forgot, probably security credentials. Click on users over here. We are creating a fresh user. I already have a user called Autoscaler. I'm creating a new user called pre-signed generator. What is the goal of this user? The goal is, you will have access to generate pre-signed URLs. So whenever this Node.js process, as long as this Node.js process has the password of this username, it will be able to generate pre-signed URLs. I don't want to provide this user GUI access at all, or access to this console. So I'm going to uncheck this. This will purely be a programmatic access. Attach policies directly. I want to attach some policies to this. I would assume there is S3 all access. Amazon S3 full access should be good enough. There can be a more restrictive access. I'm assuming, this user will now have access to delete photos as well, delete the bucket as well. If I give it Amazon S3 full access, I should ideally give it some narrower access key. You should only be allowed to put objects here. For example, Amazon S3 read only, Amazon S3 write only, but full access is also fine for now, just to, just so we don't run into any more permissions. You shouldn't select all the permissions. You shouldn't give it all permissions to your AWS account. You should keep it as narrow as possible. And Amazon S3 full access is good enough, even though it's not as narrow as it could be. For now, we're giving all access. Next, create user. This has created sort of a sub user. So if you ever have employees, you can create users for them, give them GUI access, and give them limited access and share the credentials with them. But for us, we don't have employees. We want to create security credentials that I can put in my Node.js process, so that this Node.js process has access to S3, and this Node.js process can create pre-signed URLs. So I'm going to go to security credentials and create an access key. This access key needs to be accessible via the command line interface. No need for a description. And I have an access key and access secret. I'm going to keep it handy for now. I will of course revoke this before this video goes live. So, even if you have them, you hopefully won't be able to do much with them. But this part is done. I have a access key, which looks like this, and an access secret, which looks like this. If anyone has access to these two, they can put data in my S3. They can take data out of my S3. So this is something you should keep very secure. I'm not doing it, but you should. This is something that people, a lot of times I've seen companies directly put this on the front end. On the front end itself, they put their AWS credentials so that, you know, the user can directly upload a photo from here to S3. But why is this problematic? Because now this user has complete access to S3. They can delete your complete S3 and you're screwed. So you should never store them here. You will store them in your backend, and the backend will of course generate pre-signed URLs, return them here, and then the user can directly upload images to your S3. Alrighty, second step is done. Third step is creating two frontends. Let's go to Visual Studio Code. We already have a backend. We have not written too much code over here. We'll be writing it very soon. Before that, let's create two frontends. Let's keep them. Doesn't matter. You can keep React, keep Next. If you want to keep it simple, React is fine. Yeah, it doesn't matter either way. Whatever you guys want to do. I'm super conflicted. Let's just do Next. Create Next app. I think that's the right one. No, that looks wrong. Oh, that's right. Let's call it user frontend, which basically means the frontend for the YouTubers, the machine learning modelers, and then we'll create another one for, you know, the workers. We'll call that workers frontend. Fairly simple bootstrapped code. We're not going to write anything extra in it just yet. We'll first be completing the backend, then we'll write the front-end code. Worker front-end. All default should be fine over here. All right, we have both the front ends. Next step is designing the schema, basically adding either an ORM like Prisma, creating your database, and, you know, designing how will you finally store the user's details, the task details in the database. A place where you should spend a decent chunk of time, you know, designing the schema of the database yourself. Alrighty, designing the schema. We're going to follow a specific stack for this one, which is Postgres plus Prisma. But, you know, feel free to choose your own database if you'd like. This is just a commonly used stack all across, so we're going to stick to that. For this use case, your life might be a little bit easier if you used a NoSQL database, but we're going to stick to standard SQL databases, specifically Postgres and Prisma as our ORM. The first thing you have to do before you, even dive into writing the code is get access to some database. You can start it up locally, or you can get one from Avian or Neon.tech. They're both sort of free until a while. So I've created one here on Neon.tech. How did I do it? After you sign up on Neon, let me delete this and restart. After you sign up, it'll let you create a project. I think for free, you can create 1 or 2 projects over here. When you do create one, it'll give you a connection URL, where is it? There you go. That pretty much are the credentials to your SQL database. Of course, I will change this before the video ends. For now, you can all see my database credentials, which is fine. Keep this Postgres URL handy. We'll be needing this whenever we, initiate a connection from our backend over to the Neon.tech database. Again, you can also start it locally. You can also use a different provider. In the end, you need a string like this, which is a connection URL to your database. If you look at the string, it has a few parts: the username, the password, the host where this is stored, and the name of the database. So get this URL, keep it handy before you proceed from this point. Next up, we need to install Prisma. The steps to install Prisma on a node. Oh, oopsie daisy, I'm in the wrong folder. Go to the backend folder and then npm install Prisma. The steps to install Prisma are fairly straightforward. Let's go to prisma.io and it'll pretty much share the steps if you want to add this to, a Node.js application or a Nextjs application. Quick start. npm install prisma --save dev. I should have added this. I haven't added it. It's fine. npx prisma init. This much should be good enough. By default, it creates a Postgres database, which is what we're going to use. So we're not going to change the data source provider. We're going to stick with the default, which is Postgres. Once you run this command, you will see it says, or it generated a folder for you called Prisma, and it has a schema.prisma file. Here is where you add the schema of your application. This is where you'll be spending most of your time right now to design the schema of your application. For those of you who don't know what schema is, it basically is the structure of your database. How will your database eventually look like? And this is how you define a schema in Prisma. It pretty much gives you like a language of its own to describe what your database should look like. For us, we will have a users table as well as a workers table. The workers would be people who sign up on, the other front end. Users would be people who create the actual task. Each user will have not an email, since this is a Web3 application. They will actually have an address, which is their public address. Basically means, if I from this phantom wallet sign up on the website, this is how I get identified using this public address. And if someone else does, then their public address is what's stored here. We don't store a username password. We don't store, we're not doing login with Google. We're not doing login with email password. What we're doing is login with your wallet. We'll be writing the code for it, but the backend needs to support a very similar schema. Same is true for the worker. So they won't have an email. They will have an address, which will be unique. The name isn't really needed. Probably should just move it and keep it as lean as possible. Every user can create tasks. So the first thing we probably should create here is a task. A single task can have, of course, the title, which will be, should have an ID as well. Can do an int at ID at default auto increment. This can also be a UUID, doesn't matter either way. A title, which, for most YouTube videos would probably be select the most clickable one. For a different machine learning type use case, it will be select the thing that looks like a cat. It will also have options. So you have to create another task here called options, which means every task needs to have multiple options, which are like the thumbnails that you can choose from, or, a bunch of cat images, dog images, so on and so forth. This will also have, each one of them will have an ID. So we can pretty much stick to what we've done above, at ID at default auto increment. It'll have, doesn't really need a title. All it really needs is, image URL, which, as the name suggests, is a URL where the image will be stored. This will be a string, and this is required, so needs to be not null. At db default ignore. Oh, it is not null by default. Only if I add question mark does it become nullable. Another thing I'm adding here is option ID. Basically, if the user sees 4 options, they should have some sort of an index on them. Option 1, option 2, option 3, option 4. And hence, this needs to be an integer. Why do you need this? We'll eventually come to why we need this. This will just help us make our queries a little faster eventually. Options and tasks need to be related. If you don't know what related means or what are relationships, it basically lets you create foreign key constraints. If you don't know what foreign key constraints are, then you have to do a little bit of SQL. But basically, whenever data is related in tables, specifically SQL tables, you can explicitly tell the database, okay, hey, these tables are related. For example, every user will actually have a bunch of tasks, and every task will have a bunch of options. So you can actually relate data, something like this. Every task will have a bunch of options, which means options will have a task underscore ID associated, which will be an integer, and a task related, which will be a relation, which I totally forgot the this thing for syntax. I'm just going to copy from here. It will be a relation on the field task ID, which references the field ID of the task table. Something like this. Still an error. Field author ID. That looks right. What's the... I guess the other thing I have to do is options, option array. Something like this. Option. This will probably should be called option. There we go. All right. That is how you add relationships. You're saying, okay, every option needs to have an associated task. This is basically a one-to-many relationship. Okay, every task will have multiple options, and every option will have a single task. If you don't understand it, yeah, you'll have to do a bunch of SQL Googling. You don't need them. They only let you enforce a few things. So this will work without it as well. But the more stricter your schema, the better. And this is adding more strictness to our schema. Every user will have multiple tasks. So you can also do this task array. And then every task will have a user ID, which will be an integer. And every task will have a user, which will be of type user, which is a relation from user underscore ID field here references the ID field above. Alrighty, that looks pretty good. Every worker will create a bunch of submissions. So model submission ID integer at ID at default auto increment. Every submission will be for a specific worker. So worker ID, which is an integer, and worker, which is going to be a worker, which is a relationship between here. Every worker will have a bunch of submissions. There we go. And every submission will be an option. It basically means, whenever I submit, I select, okay, I'm submitting option number, option ID A, B, C, D, or whatever the option ID might be. So the other thing that a submission needs to have is option underscore ID, which will be of type with integer. But you can also do something like this. Okay, it will be enforce a relationship here at relation. This will be a 1 to every option will have multiple submissions, but the submission will have a single option. So it will again be a 1-to-many relationship. ID, alrighty. Every option will be associated to a bunch of submissions. There we go. What else? This is actually good enough. You can calculate everything from this, but this won't be fast. Basically, what will happen is whenever the user finally comes to your website, whenever this guy finally comes to the website and they ask the backend, hey, what's the result? The backend will have to go to through 1,000 queries and respond back, hey, this is the final result. 1,000 people may say 300 did this, 200 did this, so on and so forth. We have all of that data in submissions, but we haven't cached that data at all. Which basically means this query, every time the user asks for it, we'll have to iterate over 1,000 submission records. That is fine, but you can actually make it slightly better by adding another model here called submission cache, which pretty much stores, given at ID at default, given a question or task, so task underscore ID, how much was option 1 voted for, or how many times was option 1 voted, which will be an integer, and then how many times was option 2 voted, 3 voted, 4 voted. This isn't the best way to do this. This is a little ugly, storing option 1, option 2. The options are not dynamic. What if someone has 20 options? You'll have to store 20 over here. And we might not even do this right now, but this is something you should do. You should, store all the submissions finally, or cache the number of submissions somewhere here, so that whenever the user asks for it, you're not iterating over the submissions array and, getting all the submissions for that specific task and going from there. Every submission is associated with an option, and every option is associated with a task. So the way to get all the submissions given a task would be getting all the submissions given all the options for task. This query will become very complicated. So I might just keep this. Doesn't matter either way. Feel free to make your life easier, if I'm being honest, and use the submissions cache. The only downside here is, we're restricting ourselves to only 4, or let's say, if you really want to get fancy, you can put 8 over here. But what if someone wants to upload 9 options? Then your schema itself doesn't support it. So, it gets a little weird. So yeah, that's how I would design a submissions cache, so that this final query is much faster. And also, yeah, if you don't do this, then the query to get back all your responses will get a little complicated. Let's begin from the top. What all do we have? We have a users table and we have a workers table to begin with. To keep things very simple, we have 2 tables. Whenever a user signs up using their phantom or whatever address they have, we create an entry in the users table. Whenever a worker signs up, okay, I want to get paid on this platform, we make an entry in this table. Whenever a user creates a task, we create an entry for the task, put a title in there, which by default, actually, you can put a default value here, which looks something like this. Select the most clickable thumbnail, because most people will just be, let's say we only support YouTubers right now. Eventually, machine learning model people would come and, they're allowed to select their own title. And whatever options they select, we put all of these options in this options table. This should have an image URL. It does, and we generate an option ID, which will basically be 1, 2, 3, 4, 5, something like that. So that whatever is the option ID here, eventually we can store in the submissions cache. Here, option 1 was voted these many times. Option 2 was voted this many times. There probably is a better way to design this schema. I'm not doing it in the most clean fashion. So think about it and let me know in the comments. I'm sure there's an easier or a cleaner way to do this. Every option is associated to a task, and finally the submissions table, which is filled by the users. Usually, or not usually, in this case, whenever you add an entry to the submissions table, you will also be adding an entry to the submissions cache table, which basically means, if the user selected option 1, you will first store their submission as well. So this person has already voted on this task, but you will also, make an entry here in the submissions cache. I probably should add task underscore ID here as well, which is going to be an integer, and task, which is going to be a task, which is a relation on the field task underscore ID, references ID. And for every task, there will be a bunch of submissions, which something like this. This will make our life a little bit easier. Now you don't really need the submissions cache. Feel free to pick and choose. If I'm being honest, I'll just remove it to keep things simple. Even though this will be slower, it'll still make our life a little bit simpler. That looks pretty good. Yeah, cool. I think this is pretty foolproof. Well, one thing that's missing is, payments. Anytime a user makes a payment, we probably should store it. So, every task should probably have payment underscore signature, which stores that this person did indeed make a payment and, how much money they have paid. We'll just write signature, which is a string, and the amount, which is the amount of USDC sold this person might have sent, should be a string only, because this can be really small, like 0.001. Every task has an amount, and then every worker needs to have a balance, basically, which is how much money they're owed right now. So that will look something like this: integers at ID, and then amount that they're owed, which is going to be an integer, at default going to be 0. And of course, this will be for a worker. So worker ID, which is an integer, and worker, which is a relationship between fields worker underscore ID and references ID. And every worker will have a balance, which is of type balance. You actually can store these directly over here as well. Should you? Doesn't matter. You should probably keep it separate, if I'm being honest. But this is a one-to-one relationship basically. So you probably have to do something like this: at relation balance underscore ID balance fields balance underscore ID references ID, something like this. Oh, that's not how you create one-to-one relationship, is there? How do you create a one-to-one relationship? It's fine. We can just, I'm thinking, we can just keep this here. Since it's a one-to-one, there's probably benefits of normalizing this, but I'm not going to. I'll just store the pending amount here itself. You probably should have it in a separate table though. Alrighty. Pending amount, which is going to be an integer, which is the amount that's pending to be paid out to this user, and then maybe logged amount, which is currently being processed and hasn't yet reached the blockchain. All right, pending amount, logged amount. Lastly, whenever the user makes a submission, they should probably be paid some amount. So we should have amount that they are paid for this specific submission, which again, let's keep it as a string because can be really small, 0.0001, something like that. I think this is pretty foolproof now. Every worker has a pending amount and a logged amount. This pending amount keeps on racking up as they make submissions. And whenever they want to withdraw, pending amount goes to logged amount, pending amount becomes 0 again. And after the submission, after the money is actually debited out, you make logged amount 0. If it doesn't If the blockchain is down right now, you move the money back from logged amount to pending amount. Looks pretty foolproof to me. I could of course be wrong, but we'll see. For now, let's save this and let's start to replace the database URL. If you remember, I had it handy over here. I can copy this database URL and paste it in the .env file that Prisma generates for you by default. And now you've given your database credentials to Prisma. So now you can migrate your database. What does migrating your database mean? Letting the database know, okay, this is the structure of my database, creating a bunch of tables in your SQL database. You don't have to do that for NoSQL databases, but for SQL databases, you have to migrate your database, which basically means you have to tell the database, hey, I'm putting some fresh tables over here, the ones that we just defined, and let it know upfront what the structure of your data is going to look like. When you run this command, let's wait for a bit. Write a new name for the migration. We're going to call it init because we're initializing the database. If you look at the migrations table that has been created here, it'll have all your SQL to create a users table where there is a constraint of a primary key, and it will also have all your foreign key constraints. Every task actually depends on a user ID, and every option actually depends on a task ID, so on and so forth. If you understand SQL, should be straightforward. You did not have to write all of this though. All of this SQL was spit out by Prisma. That's one of the benefits of using Prisma. You describe your schema in a very clean fashion, and as you update it, it finds the diff and figures out what to put over here. My database is also migrated. If I go to neon.tech now and open the specific database that we had just created, if you open your database, as you can now see, it says storage 32 MB, which means I have actually started to store some data in there, told it the tables that I need to create. If you go to the SQL editor, you can select star from worker, select star from user. If you run this, it'll give you back some response. It says query completed with no results because there are no users right now. But if I put some random thing over here, it says relation doesn't exist, which means the user relation does exist, which means we have migrated our database. The database now has the right structure. We need to now actually write the code, which is probably going to be the next step over here. After we design the schema, we need to start supporting all the endpoints. So, store things in the database, talk to Amazon and generate pre-signed URLs, all that jazz. Let's get into that next. Now that we've designed our schema and migrated our database, let's start to write the meat of our logic, which we'll be doing here in our index.ts file. Alrighty, one extra thing. I've also added a sign-in endpoint here for both the users. There's no real need of a sign-up endpoint. Doesn't really matter. Like the user clicks on a button, connects their wallet, and then eventually signs in. If this is the first time they're signing in, then they sign up. We won't be diving into this just yet. We'll be diving into this when we reach, the Web3 bits. For now, we'll just hard code this endpoint to a single user, and go from there, both for the users as well as the workers. The very first endpoint to create is the /signin endpoint. Let me actually add some basic routing over here. All right. All of my user routes I'll write in this user router. All of my worker routes I'll write in this worker router. What's the very first endpoint I need to support? A /signin endpoint. Are we supporting sign in with Google? No, we're not. Are we supporting sign in with username password? No, we're not. What are we supporting? Sign in with wallet. You will see this across most decentralized websites. If I go to Tensor, which is a decentralized marketplace, when I come to the website, I actually have to connect my wallet. I will click on the connect wallet button, select a wallet. I need to have Phantom or some wallet present over here. And only then can I sign in here. As you might have seen, there was no login with Google, login with Facebook. You directly log in with your wallet. True for most applications. Question is, how do you let the backend know, okay, this is you, okay, this is the person who has this specific wallet address, for example? And the answer is, you have to make them sign a message. We will eventually be getting here what does signing a message mean. But for now, I'm going to make this endpoint fairly rudimentary, which means, I'll add a to-do over here, add sign verification logic here. And for now, I will just assume that the user has a specific wallet address. For example, const hard-coded wallet address equal to, let me copy over one of my wallet addresses. Maybe a cleaner one. Doesn't really matter. Like, can be any wallet address. Looks good. And then eventually, whenever the user signs in, if you are sure that if you've actually verified using some signing a message logic that we'll be eventually adding, you can return the user a JWT, very similar to how you might have done username password until now. That looks something like this: const token equal to JWT.sign. The data looks something like this. Address, hard-coded wallet address. You should also create a user over here. So you should do a Prisma dot. You need to create a Prisma client. You need to do a bunch of things here. So let's first add all the dependencies that we need to add. First dependency we need to add is JSON web token, which lets you create JWTs. If you don't understand this, this is the most common way to do authentication, or like the easiest way to do authentication. What happens is, whenever a user comes to your website, if this is the backend of your website and this is, let's say, your React application, when the user signs in on your app, which means they send a request to /sign-in and they give you a username, which is, let's say something like this, and a password, which is, let's say something like this. Your backend generates, if the username and password is right, which basically means the backend most probably hits a database, checks, is this username password correct? And if it is correct, it returns a JWT to the end user. What does JWT stand for? It stands for JSON web tokens. Basically a very long string that the backend can eventually use to identify the user. So what happens is, you create a JWT over here, return it to the end user. And now any future request that the user will send, for example, I want to create a task, they can send their JWT along, and then the backend can identify them. If there is any other request that the user is sending, they can send the JWT along. The backend can identify, this is the user harkirat@gmail.com, because this JWT has that information. Harkirat, why not just keep sending username and password again and again? It's just ugly, right? For you to send username and password with every request, or ask the user for a username and password on every request, which is why common architecture, you might have heard of cookies or JWTs. These are like two ways that you do authentication on the web. We are going to go with JWTs. Harkirat, even for sign in with a wallet, you have to use JWTs. Yes, you can use JWTs and make the user, rather than sending username and password, the user can send their address as well as a signed message. And using this address and signed message, the backend can verify that this address is indeed for the person, and then return a JWT. In every future request, the React frontend can keep sending a JWT along with the request that the user is trying to do. And then the backend can identify that this is the same person who has, this specific address, for example, address 1. We will get to this when we reach the Web3 bits. For now, we're hard coding it. We have hard coded the wallet address. We do need to return the JWT to the end user, and hence we have to do a first import JWT from JSON web tokens. You will see an error over here, which means I need to do npm i at types /JSON web token as well. Just doing npm i JSON web token isn't enough. And now the type error should go away. And I can create a JWT for the user, or token for the user, which looks something like this. Sign, the message is going to have probably the user ID, which we need to generate first. So what do we need to do? This might be the first time this user is signing in, or they might already exist as a user. So we need to check in our database, okay, const user equal to await. First, we need to create a Prisma client. So let's go to the top and create const Prisma client equal to new Prisma client. If you've done Prisma, you know what this is, where this comes from. If not, think of this as the Mongoose object. If you've done MongoDB, this object lets you update your database, put data inside. And what do we need to do? First, make this function async and then do a await Prisma client dot user dot upsert. What does upserting mean? It means if no user exists with this hard-coded wallet address, please create one. If they do exist, then just update it. Common thing you use if you want to either create or update data. We don't have to update any data, but you can also keep things simple and first check if Prisma client.user does actually exist. And if they do exist, then just return the user ID over here. If they don't exist, then create the user. Upserting is just an easier way to do it. If you want, let's keep it simple. Let's do this. Const existing user equal to await Prisma client dot user dot find first, where address is equal to hard-coded wallet address. If user does exist, then the token that you create and return to the user is simply existing user dot ID. We also need a JWT secret, which we should ideally propagate from an environment variable file. I will do that eventually. For now, I'm just going to create a global variable. This is the secret that you need to keep on the server that you're using to sign the JWT. If you give access to someone else to this specific token or secret, then they can sign in as anyone on your website. So you shouldn't do that. Keep the secret. If you've done JWT, straightforward. If not, this secret is needed for you to sign this payload. What does payload mean? Just some data that you're eventually returning to the front end, that the front end can use and keep sending you with every request. After you've created, I guess if you don't know JWTs, this is going to be hard. Just go to a video and understand basic auth using JWT and come back here. Else we need to create a user. So we can do user equal to prisma.user.create, and the data that you're putting in includes the address, which is the hard-coded wallet address for now. Is that all we need for a user? We need address and tasks. The tasks are empty for now. So that should be good enough. And now you can create the token using this user object. Once you have the token, you can return it to the front end so that the front end gets back this token. Let me do the same thing here as well. We have created a single endpoint /signin, which when the user comes to your website, they need to hit this specific endpoint first. They need to hit it with a message. We're not getting there just yet. We will when we reach the Web3 bits. For now, we're assuming that the message was correct. It was signed correctly. We have a hard-coded wallet address here. We find, does the user exist with this hard-coded address? If they do, we sign the token using the ID of that user and return it to the front end. Else, we create a new user in our database and then return the ID of that newly created user. If I try to run this locally, which I can do by running tsc-b to compile the code, and then node, I guess I have to do one more thing in index.ts. I need to do app.listen. Let's say 3000 so that it listens on this specific port. If I do node/index.js now and go to Postman, you will notice, hopefully I can send a request. Maybe not, we'll see. What is the endpoint? /v1/user/signin. That is the endpoint I need to hit. And it doesn't matter what payload I hit it with right now. /v1/user/sign-in. Doesn't matter what payload I hit it with, can totally be empty because we're not using any payload yet. Eventually we'll be adding a signed message thingy over here. Send, and it gets stuck, probably because either the database is really far or there is an error. I don't see any. There you go. The database is far, which is why it took a long time. I have gotten back a token. This token is something I need to keep safe and send with every future request of mine so that the backend knows this is Harkirat. This is like, think of this like let's say you went to a doctor and the first time you had to show them all of your documents, show them your, history, pay them for the first time, but then you get a prescription from them. And then in all future visits, you can just show the prescription. Yellow, this is me. You already have my data, right? In all future visits to the doctor, you don't have to do this initial bootstrap again and again. Signing in is similar. The first time you sign in, you have to send a bunch of data. We're not sending any data right now. We will eventually, but you get back a token. And then as long as you have this token, you can just send that token with every request. The backend will be able to identify you. Let's go to the database and let's do a select star from user now. And you will see now we have at least one entry. Okay, there is a user who has this address. We've stored that entry in the database. If I sign in again, do you think a new entry will be created? No, the existing entry only comes back. If I run this again, I still have a single user because we've written that logic. Okay, if there is an existing user, then simply return the token. If there is no user with this address is only when, we actually create an entry in the database. So that's the logic for the first one. Feel free to take a pause and, breeze through this. Of course, you'll find this on GitHub as well. Only the code that you find on GitHub will probably have all the verification logic here as well. That's the sign-in endpoint. We're done with the first one. Let's move on to the second endpoint here, which is generate pre-signed URLs. This is something new you'll probably learn today if you have not done this before. I have to Google a bit to do this as well. Been a while since I've done this. So let's see what APIs we have to use. We probably have to update the .env to put, AWS secret, the things that, if you remember, I had taken from AWS before. I need to put them somewhere in my environment file, get these environment variables in this user.ts file, and then, create the pre-signed URLs. Let's see how that happens. So the next thing basically might be an independent thing that you can learn. How can you expose an endpoint from which you can generate pre-signed URLs that the user can use to upload images on S3? Alrighty, I will have to Google this as I said. So I'll go back to Google. Generate pre-signed URLs Node.js S3. Alrighty, seems like we've reached a blog post. Yada yada yada. Bruh, don't think this is a Node.js. Oh, there you go. Get signed URL from AWS SDK /S3. Alrighty, let's add the @AWS SDK to our Visual Studio Code. /client-S3 as well as this dependency right here. All right, what does it say? Get signed URL command equal to get object command. This probably needs to be post object command for us. Pre-signed URL equal to get signed URL S3 client command and expires in an hour and then log it. Alrighty, let's try that out. Let's create a new route here. Let's call it, make this smaller, router dot post, or I guess it needs to be a get pre-signed URL. Put object command bucket name. What's the name of our bucket? It was Harkirat CMS, something like that. I think it was Harkirat CMS. Should probably be a global variable. And key needs to be, something random. It definitely needs to be, let's see. If you go back to the S3 bucket. Oh God, did I get logged out? Oh, there you go. S3. The name of the bucket was Harkirat CMS, which looks like it's the right thing here. The key, if you remember, I created a specific folder called /Fiverr. So let me do a /Fiverr over here. And then we can just, alrighty. Let's take both of these and let's shove them in here. The key can be something random, probably should have the user ID. So the first thing I guess we have to do is make this go through a auth middleware, which will identify the user, and then const user ID equal to rec.user ID. There are better ways of doing this. I would totally 100% fix this eventually, but I'm going to TS ignore it for now. The auth middleware is going to verify the JWT token. So basically, if I create a new middleware.ts file, again, this is standard Express stuff. If you don't know Express, this is what the fuck is happening. But basically, middlewares are places that let you, extract a bunch of common logic in the same place. For example, the logic that we are going to put over here is, okay, whenever a user sends a request, we first extract the token from the user, const auth header equal to rec.headers of authorization, and then we check if auth header const decoded equal to JWT dot verify auth header comma JWT secret, which I should export from. I should ideally just have it in a common place. So let me put this in index.ts for now. Eventually I'll move it to .env, but this JWT secret I'm putting in the top level index.ts for now. Go back to user.ts, and wherever I'm using this, I need to import it first. There you go. It's been imported now at the top. Same thing I need in middleware.ts. I need to import JWT secret and then JWT.verify. I should put this inside a try catch block because this function can throw an error. And if there is an error, it means the user wasn't logged in. So you return rest.status403.json message. You are not logged in. What's up here? Rest.status. Oh. Oh, response. Its type is most probably incorrect. Response of any record string number. Alrighty, let's copy that over. Oh, okay. There we go. Alright, I wasn't just importing it. That was a different response. Doesn't matter. Alright. String identifier is not defined. Let's do a question mark. There we go. If decoded dot, what was the thing that we put there? We put the user ID over there. So if decoded dot user ID, then rec dot user ID equal to decoded dot user ID. Here I'll probably need another TS ignore, which I apologize for. There are cleaner ways of doing it. But yeah, I'm going to TS ignore it for now. Else you just return the user. Okay, you're not logged in. This is a standard middleware. Even if you had username, password, login, this is what you would create. You will find this in many projects. If you go to any of the assignments from the cohort initially, the structure is fairly similar. Basically, if you understand middlewares, then this should be straightforward to understand. This is a very commonly used middleware to extract the authorization header from the user, which means any request that the user sends. If you remember, when we were here, where was that? I said you get back a JWT, and then in every future request you send the JWT. Usually this JWT is sent in the header, which is why I'm extracting it from the header over here. I get the auth header, and then eventually, use the JWT library to verify the header with the same secret that it was encoded with. And if I do get back a user ID, that means rec.userid is, I set rec.userid equal to decoded.userid. Why do I do this? Because so that when the next function is called, what's the next function in the hierarchy here? The next function after auth middleware is called. I imported this here at the top. Is this function right here where I'm using rec.userid. So it's a way to pass the user ID over to the next function. This is an ugly way to do it. There are better ways of doing it, but works for now. Our middleware is going to shove the user ID in the request object that I can simply use in the next router.get request, or whatever request uses the auth middleware, which is going to be basically all the requests. We can use this middleware and get access to the user ID here. If the user isn't logged in, control will never reach here. The control will be blocked right here itself. All right. Now let's see. Where do we want to store the image for the user? Basically, we can store it in a folder like this, /image.jpg, and const presend URL equal to await get presend URL. I can also force the type over here. I would assume, content type image/jpg, or this might be something else. So we'll fix that if not. Generate the presend URL. Let's just log the presend URL for now. Also maybe return it back to the user. There you go. Excuse me. Let's see if this endpoint does what it's supposed to do. The one thing that you might ask at this point is, Harkirat, where have you sent the credentials? And the answer is nowhere. So let me quickly put the credentials here as well. What's the way to put credentials? There you go. Credentials, access key ID, and secret access key. Where did we have both of these? If you remember, I put them in my Notion. You probably created your own and put them there. You need to put these credentials here. And you have to make sure this user, the credentials for which these are, that user does have access to S3, which when I created it did. You should not shove them here. We'll eventually move it to a .env file, but let's see, do they work? Are we able to generate a pre-signed URL that our end client can eventually use to upload an image? Node /index.js, go to Postman, and get the token that you had. Feel free to re-sign in, doesn't matter. But in the end, you need this token, and then send a request to /v1/user/pre-signed URL, and in the headers, you need to send a new authorization header, which is this JWT that you got. This is how the server identifies. This is Harkirat, a legitimate user asking for a pre-signed URL. That is also how we can restrict the user's images. The images that this user is creating, we can put them in /fiverr/user ID /somewhere. So if this user ever destroys their account, if this user ever stops paying, we can simply delete a single folder and all of their images go away. We don't have to pay for their images anymore, which is why this is like one way to structure your data. A lot of times people, put dates here as well. On date 1, they put this much. On date 2, they put this data, and then, you have expiry after 6 months, delete images. But this is fine for now. If I now send this request, hopefully we get back a pre-signed URL as long as the URL is correct. Let's try that. I think I need to restart the application. Send. Can't post /v1 because it's a get request. Let's change that to a get. Send. And the server died. It says region is missing. I think my region, I don't think there are regions on S3 if I'm being honest, but N Virginia, which is US East 1. So I need to put the region over here, US East 1. Let's try that one more time. Postman, send. I did get back a URL. Now let me try to send a request to this URL. So post request to this URL where I'll be sending a file. Question is, how do you send a file here? I think that might be it. Do we have a JPEG file here? Are these JPEG files? Doesn't matter. Let's try it out. I put a file over here. I put the post, like the correct pre-signed URL over here. Let's see. Only one mechanism. Without the X signature, query string, or the authorization header should be specified. Alrighty. Time to Google a bit. There we go. I got back a pre-signed URL, bucket, key, conditions, fields, content type, image.jpg. Question is, how are you sending the request there? What is the thing it said? It said only one mechanism allowed, only X Amazon algorithm query parameter, signature query parameter, or the authorization header should be specified. Oh, okay. I have an authorization header. I should remove this and try that one more time. The request signature we calculate does not match the signature we provided. Check your key and sign in method. Alrighty. I don't think I have done that. Let's see. /Fiverr. Maybe let's remove /Fiverr and try. Don't think that would be it, but worth trying. Let's generate a pre-signed URL one more time. Got the URL, copy it over, go back to one of these requests and paste it, send. Check your, okay, what is the Fiverr /1/image.jpg and the body. Oh, I'm not sending any body, that's my bad. Let's send an image. It's a PNG, but that's fine. Okay, let's change this to image/PNG to begin with. That might be one issue. I don't think it is it, but let's see. Get a pre-signed URL. Go back here and of course send some file in the body, which is a JPEG file now. Send. The request signature characters. All right. A little more debugging. I might not be sending the request the right way. We'll see. Shouldn't be too difficult. Where did that go? Okay. Create pre-signed post with that. Okay, let's try that. Seems like there might be different API that we can use. Let's go to Visual Studio Code. Oh, I don't have that. Request. Don't think it'll fix anything, but worth trying. All right, let's try that. What the fuck? Pre-signed URL looks weird. HKey.cm, that just looks wrong. First thing is bucket key conditions fields. Pre-signed post request to S3. Huh. Policy. Oh, it returns you. Oh, it returns you the signature that you eventually need to put on the. Okay, I guess I need to create the whole thing myself now. This is the URL. All right, it is a post request, and in the headers, in the body, I need to send a file. It should be a JPEG. In the headers, I probably need to send let's see, type hidden key. Oh, policy, and then is X AMD signature. And then the file already. Oof, I need to send two things. So body needs to send the file. Oh God. All right, let's go here. Okay, curl post update and thing dash form. So there's a lot of form data in there. Okay, that makes sense. So let's put the policy, which is this thing right here, as well as the signature, which is this thing right here, and the file. Let's go input type to file, name equal to file, input time equal to hidden, XML signature, policy, and then the key and the date. Oh god, I have to put everything. I have to put everything. All right. Bucket. Yeah, I like the other approach better. Let's see. And then what else? I don't know if you need this, but take a while we're at it. Alrighty, let's just add the file here and go from there. How do I add a file over here? How do I change the type of this thing? There we go. File, select a JPEG, send. Let's see. Bucket post must contain a field name key. Alrighty, I did add key though? No, I did not. Alright, key, which in our case is this thing right here. Let's keep it small k. I guess it needs to be capital K. A bucket post must contain a field named key, which is exactly what I have here. It is a small k. Order of the fields. What does that mean? Oh god. Content. Let's add everything. Content dash type. Image slash PNG. Okay, what does this guy say? This file isn't in your working directory. Teammates share. Oh, okay, don't care. Maybe add the file towards the end. Maybe that changes anything. Alrighty, there we go. So we need the date. Did this guy have a date? It did. Alrighty. Xstat. Oh boy, that took longer than I was hoping for. Let's just send this much. The policy for success is alright. I think good to go now. Let me put the file. Moment of truth. Invalid according to policy condition equals status success action status 201. What was that? Let's remove that. Let's try that one more time. Oh god, it'll regenerate the whole thing. I need to redo the whole thing. Alright, it's fine. Post request, you get back something. You go back here, you go to the body, and amongst the things that you're sending, bucket is the same. Algorithm changed. Huh. Okay, algorithm changed. Oh, it's the same. Credentials probably changed. Oh, it's the same. Date has definitely changed. There we go. Key has definitely changed. Policy has changed. And signature has also changed. File. I don't know if I want to select this one. Select a different one. Send. That's taking a long time. I like that. 204 no content. That might be it, guys. Let's go to our S3 and see if there's a new image there. Harkirat CMS, Fiverr, refresh. And do we have a new folder here? We do. 1. Do we have another folder here? We do. 0.722. Was that what we were sending? That's exactly where we were sending the image. Go here /image.jpg. If I go here, try to visit this, it won't let me. But if I go to the CloudFront URL, which is this guy right here, and copy this and paste this here. I do get the image. So good to go. We have created an endpoint that the end user can hit, get back a pre-signed URL, upload the image, and then eventually, they have their image on our S3. They can, of course, send this image to us in future requests. The second endpoint is done, basically. We'll get to the front end of this very soon, but the back end of generate pre-signed URL works. The only thing I guess I need to change is I need to return all of these things, the fields back to the front end, so that the front end can also, it has access to all of these and can send all of these with the request that it's sending out to the front end. Over to S3. Alrighty, this is done. Let's move on to the next thing, which is going to be let users upload images via front end. Okay, this is something we'll eventually do. We can move on to the front end. Let me think. Probably a good idea to move to the front end, right? Build the whole thing end to end. I don't know. Let me think, and I'll let you know in a second or so. All right, for no reason at all, I think let's just finish the backend first and then we can get into the front end. Specifically, this probably will be one of the more difficult bits on the front end. Everything else should be straightforward. We're done with 2 endpoints. Let's add the third endpoint for the user. It's going to be I have no idea what it is. Let the user upload. Yeah, we'll go to defer that. Create a task and then get a task. This should be fairly straightforward actually. Needs to be authenticated rec, res. And we need to validate the inputs from the user. This is something you should do. You should also, since this is a post request that will accept a bunch of parameters, I have to do a app.use express.json because we'll be expecting the user to send us data in the body, and that data isn't passed unless you use this specific middleware. Const body equal to rec.body. Ideally, you should use Zod. Let's quickly add it. I also forgot totally. I needed to put these into an environment file. Let's do that eventually. npm I Zod. That'll let you do some basic input validation here. Let's create a new file called types.ts. Import z from Zod. Const create task input equal to z.object, which will have images, or let's just do options, which is going to be z.array of z.object, which will have I guess the image URL is good enough. We might need text here eventually, but for now this is fine. An array of images, which are the options, and if needed the title, but you don't really need the title if I'm being honest, because for now we're just creating the YouTuber use case. So let's make this optional. Yeah, that looks pretty good. We have this input. What have I done here? I've used this library called Zod. Zod lets you do input validation. What does input validation mean? It basically means, whenever you take input from a user, you should validate it. You should sanitize it. User can send you any random data. So you need to make sure the user has sent you the data in the format in which you expect. This is the format that we expect from the user. Okay, they'll give us a bunch of options, which are, the images that they want for the specific task. And, maybe a title in case they're trying to label the data. The title might be, is this a cat or a dog? Or select the cat from the following images. The second one is optional because, most of the use cases will probably be the YouTube CTR use case. So options are the things that are necessary. Title can, be optional. Given you have this, you should export it from here and import it. Here you should basically do const parsed data equal to create task inputs dot safe parse body, and then if not parse data dot success, which means the specific input is incorrect of the right format. You can just early return right here with a status that looks something like 411, which means wrong inputs message. You've sent the wrong inputs. Else you can continue and you have a right type for the parse data, so you can actually now start to store data in your database. You pretty much need to create a Prisma client dot task dot create, which needs to have number one, a title, which if the user sent you a title, great. If not, then it can be undefined. So title parse data dot title. it'll be .data.title. There we go. If you remember the schema.prisma, every task will have an optional title. Well, this should have been optional. Don't matter. I think if you have a default, it should be fine. But yeah, this should be an optional thingy, and should default to this. So title is this thing dot title. Yeah, but unfortunately we did not have that. So let's just add the default underscore title over here as well. What else? Does the task need to have? It needs to have the options, which thankfully we already have from the user parser. Data dot options. I don't know if the type is right on these. Image URL string array is not assignable to this thing because this guy requires, what does an option require? Image underscore URL, option underscore ID, task underscore ID, or it requires a bunch of things. Options need to be created. So question is, how can you do that? Probably cannot do that. Let's create a transaction. There's probably an easier way to do it, but I'm going to just create a transaction, which basically means, send two separate queries together. And here, take as an input, takes an array as an input. So basically something like tx and await async. Let's create a task with a title, and what is it missing? It's missing signature and amount. Oh, signature and amount. Yeah, we will eventually need these. Let's just hard code them to $50 for now, or whatever, maybe one sol for now. And signature, let's hard code to something eventually. Whenever the user sends you data over here, they will also send you, the body needs to be different actually. If you go back to this create task input, it needs to have these. It also needs to have amount, which will be Z. Actually doesn't need the amount. You can take the amount, but you should get it from the transaction signature. So you just take the signature, which will be a Z.string. And yeah, you should eventually parse the signature here to ensure the person has paid $50 or whatever the amount is. And then amount you can get from the transaction signature, and same thing over here. It will be parsed data.data.signature. Alrighty, amount is 1, needs to be a string because it's going to be really small. Alrighty, that looks good. What's missing over here is user is missing. You need to add a user ID as well, which I'm sure you know by now. Needs to be rec.user ID. Will probably need a TS ignore here, which we should eventually fix. But yeah, there we go. Is there anything else that's left? No, I think that's fine. You create these, you also need to create all the options. So await transaction dot option dot create many where data is going to be parse data dot options dot map x image URL x dot image URL, and task ID will be response dot ID. Is there anything else that you need here? Option underscore ID. Option underscore ID on an option itself. That looks wrong. Schema.prisma mein options where you have option ID. What the fuck? Option ID should be ID only. You don't need an option ID. Why did I add this? You don't need this. Let me remove the option ID from here. I need to re-migrate the database. -- name. Remove option ID. I'm sorry if you were confused in the beginning, but yeah, you don't need an option ID here. This ID itself is the option ID. Oh, fucking A, it was something else. No. It's actually the index. It should have been called the index. Fuck. Yeah, you don't need it. We can just remove it. You do need this if you ever want to, cache data, but since you don't want to cache data, it's fine. And by cache data, I mean, cache that specific request that the user will be sending you from time to time. Okay, hey, what is the response of my task? Right now, the way we've written the code, we have to iterate over all the options again and again. If 1,000 people made submissions, so we have to, iterate over all the submissions. You can add an index here to make it faster, but even without it, you can actually cache this to make this a little bit faster by adding another table. We did not, which is why we don't really need the option ID that we had in the options table. That option ID was supposed to be an index, which means 1, 2, 3, 4, 5 if you have 5 options. But yeah, we don't have to worry about that yet. We're going to wait. Alrighty, I've removed the option ID. I've also migrated my database over. Now, if I go back to user.ts, probably need to do a npx prisma generate to regenerate the client. And now the type error goes, oh, well, it came back. What's up here? Yeah, it goes away. You don't need the option ID anymore. Create the options, create the task. I'm sure there's a cleaner way to do this, by the way, like in a single thing. I just created a transaction. What does a transaction do? It makes sure either both of them happen or, none of them do. That way, you don't partially create the task. You don't just create the title and forget to create the options, or vice versa. So we do this, and yeah, we can just let the user know rest.json. The response ID, I guess. Oopsie daisy. How do we pull this out though? Can you do this? Let's see. ID, yeah, I think that should be fine. ID response dot ID. Alrighty, that sounds pretty good. We have created a /task endpoint where the user can give us an array of options as well as a title and a signature. We are not verifying the transaction signature just yet. We will eventually when we reach the Web3 bits. But for now, just take the title, the options, put it in the database. Let's see if this works. Let's feel free to look at this, pause, and marinate it. I'm going to try and send a request to /task and see if it gets populated or not. So compile the code, run the code, go to Postman. /task body needs to be raw JSON. And what are the inputs? Options, which needs to be an array of type image URL. Let's put something random over here for now. Eventually we'll populate this correctly. Random image URL. And what else do you need? The signature, which, let me just put something random for now. Eventually we'll fix this. Send. And there's an error. You can't send a get. Post authorization looks right. Body. It's taking a long time, which is good. It means it's probably hitting the database. ID 1, that looks right. Let me create another task. We'll probably create one with ID 2. There we go, which means most probably it's working. How can we confirm? If I go to Google Chrome, do a select star from option and run it, it returns me 1 and 2. Should it return more? Should have returned more. I've created 2 questions. How many options am I sending? I'm sending 2 options, which means that there should have been 4 options by now. Let's see. Task ID 1 has 1 option. Task ID 2 has 1 option. Why is this other one not reaching? Image URL. That looks right. Let's look at the code. Data. Let's log this. Postman send. Look at the logs. Image URL 1. Image underscore URL. Why am I only sending 1? Why is this .data.options? What are the options here? It's an fucking A, of course. My bad. Yeah, that's the right input. Send. And now I see two inputs here, most probably. I see two options for that specific user as well. Yeah, for this task ID 4, I have two options. If I create another task with, let's say, 3 options, then of course I'll see 3 options for the task with ID 5. Let's see, create it and then run it one more time. 3 options for the task with ID 5. Let's see if there are tasks that are being created. Select star from task. And I do see, most of them have the same title, signature, user ID, amount, works. Alrighty. Third endpoint is done. Let's move on to the fourth endpoint, which is just let's the user poll for the responses on a task. So it will be a router.get /task and auth middleware const user task ID equal to rec.query.task ID. Let's enforce this to be a string. Probably need a TS ignore here. Should fix that. And then we will do, you can use Zod to fix this, by the way. You can do something like z.string.save parse, and then go from there, you get the right type. This is fine as well. You get the task ID, and then you need to const task details equal to await prisma dot task dot find first, where the user ID is rec dot user ID and task ID is task ID. It'll also be a number. If not, task details return res.json status 411 JSON message. You don't have access to this task. Probably just needs to be ID over here. If they do have access though, we need to. So this is where we're going to do an expensive operation, but ideally we shouldn't. We can cache, create a new table, and ideally we should get the responses from there, but this is fine as well. Const responses equal to await prisma client dot submission dot find all or find many, where task underscore ID is number of task ID, and then we need to reconcile them. There's probably an easier way to do it, like get the counts, but this is fine as well. Yeah, I'll add it to do here. Can you make this faster? There are a few ways to make it faster. Yeah, responses const result equal to, oh boy, yeah, we can get fancy here, but let's not. Responses dot for each are if not result of responses dot or r dot. You also need the, what do you put here? Create, get. Okay, what all keys does this have? There's a create, there's also find many, has include. There you go. Task, there we go. Task underscore ID result of under task underscore ID equal to count 0 and task under task. Okie dokie. Oh, you don't need the task actually. r.option_id. There we go. Cool, that should do it. You'll get the amount of votes that have been made on every option, and then you can simply do, rest.json responses. Result, I guess it's good enough. Alrighty, yeah, I think that pretty much covers it. I've created a few tasks. I don't have any submissions on them. Let's try this out a little bit, whether or not this endpoint works, but eventually we'll create the other side, put some submissions, and then, actually test this endpoint. This will be a get where there is a query parameter called task ID equal to 1, let's say, or maybe 5, send, and you get back an error because the backend says find first, invocation failed. Which means this failed. Why did this fail? All right, let's try that one more time. User ID nan. Why is that? Headers, authorization. Why is it nan? That sounds super weird. Middleware. If decoded user ID like.user ID equal to this thing. User ID nan. User ID 1. Oh, user underscore ID. Okie dokie. Oh, this needs to be like.user ID. That's my bad. That's why you don't use TS ignores ever, sir. You fix types everywhere. Send. Yeah, that looks right. And if you go here, result says empty. Yeah, because there are no submissions. Even if there are no submissions, you should still iterate over everything, which basically means, yeah, it basically means you need to get all the options, which means when you're getting the task, just get all the include options true, and then when you're iterating here, before you iterate like this, do a task details dot options dot for each option, and then do something like this. Option dot ID is equal to task is, this should be an option. Why is this task? Option, and this needs to be option dot image URL. Now you don't need this test anymore. Alrighty, that looks good enough. What we're doing is iterating over all the options, creating account 0 entry with the image URL here in this final result object, and then just iterating over it and increasing the values. Now if I go here and click on send, you will notice you get back 0 votes for everyone. The one with ID 6 has this image URL has 0 votes, 7 this image URL 0 votes. Same for this guy. You can make this cleaner. You can make this an array. Object is fine. Probably should make this an array, if I'm being honest. This is a little ugly. It doesn't matter either way. Your front end just needs to handle it and show it to the user. We have all the endpoints done for this side, which is all these endpoints. Next, we need to build all the endpoints for the other side, which are the workers, and then we'll move on to the front end. Let's do this really quickly. Shouldn't take very long, if I'm being honest. Let's go to worker.ts and let's start with the sign-in endpoint. Needs to be almost exactly the same as the other endpoint for now, which means sort of mocked out. Eventually, we can fix that and unmock it and add actual sign-in verifications. For now, a copy pasta from here to here, and of course, bring in the imports. Bring in JWT. Bring in this. And initialize the Prisma client and make this async. Hardcode the wallet address to be maybe something else for the user. For the worker. Existing user prisma dot worker dot create worker dot find first, and data address now needs to have a bunch of other things because we're storing a bunch of extra data for the workers. That includes balance ID. It should have been optional. Oh, you don't need this. There's no balance ID anymore. Pending amount and logged amount, which are going to be 0 initially when you sign up. So pending amount 0, logged amount 0. Anything else you need? Submissions, don't really need it. What's up here? Balance ID. Oh yeah, you just need to remigrate. There was something called balance ID here because we had balances separately. Now we don't, so I can remove it and I can migrate my database, remove balance ID. And that should take away this error. Sign it up, return it to the user. Yeah, you're fine. All right. Yeah, there's one problem here. A very big problem here. I don't know if you can see, but there's a problem here. The problem is that we're using the same secret for both the workers and the users. This will be a problem because, a worker can sign in and then, hit endpoints for the user. We don't want that. So let's just change the JWT secret to be a little more, const worker underscore JWT underscore secret equal to JWT underscore secret plus worker. That's good enough. And then, for the worker, we're not going to use the same secret as the other guy, the main user. We're going to use a different one. Let me also export this so we can use it in the middleware as well. We also need to go to the middleware and redefine a worker middleware. So let me just copy the whole thing from auth middleware, create a worker middleware. And this guy needs to get the authorization header, but rather than checking, this is fine, this is fine. The only thing, we never hit the database here. So the only thing that's changed here is this thing right here, JWT underscore secret underscore worker. Everything else is the same. There's a lot of reused code between these two, so you can actually, shove it together. It's fine either way for now. We have the worker middleware and all the authenticated endpoints for the worker. Now I need to go through the worker middleware. Let's go back to worker.ts. We're done with the first one. Let's migrate the database as well. npx prisma. Generate the client again, and then the error should go away most probably. What is the command that I ran? npx prisma generate after I change the schema. Alrighty. Worker. So this needs to be worker JWT secret. Did the error go away? It did not. What's missing? Balance ID. Thought I got rid of it. Schema.prisma doesn't have a balance ID anymore. Let me regenerate the client one more time. The error still did not go away. Hover over data, what do I see? Balance ID is missing in type this thing. Let's go to data. Oopsie daisy, where did it go? Worker update input. Oh, create, it should be worker create input. Oh, there you go. It went away. Took a while, but okay. The error went away. Yeah, we're good to go. Let's see if workers can sign in now. So node this /index.js. Let's go to Postman. Let's go to /v1/worker/sign in, and then the body can be empty because we're not sending any messages just yet. Eventually we need to, this guy needs to, this shouldn't be hard coded. We'll add sign verification logic here eventually. But for now, is this enough to support the worker sign in? And it seems like it. Wait for it. It is. Let me keep this handy because we'll need this JWT on all the future authenticated requests. The sign in endpoint is done. Let's move on to the next task endpoint. This one is going to be tricky. Oopsie daisy. We should have done a few things for this. Next task. All right. We need to get the next task for this user, which means we need to find a task where this user hasn't yet made a submission. The query for this is going to be tricky. Const user ID equal to rec dot user ID. Let's put it behind a middleware, which is going to be the worker middleware. And let's do a TS ignore here. We have the user ID. What do we need to do? We need to get the next task, which is going to be const task equal to await Prisma client. We need the Prisma client. Go back to user.ts, copy over a few things from here. Now we already have it. So Prisma client dot what do you think this will be? Dot task dot find one, find first where option. Oopsie daisy, this is going to be tricky. We need to find a task where there is no option, or sorry, no submission for this user, where submission Oh boy, this is going to be a very complex query. Or you might have to break it down into 2 queries, which is something I don't want. Where submissions, none. All right. Where the user, okay, what is? Come on, give me a user ID here. Option ID, worker ID. There's no submission for every submission should have a user ID. Why is there no user ID here? What am I missing? Worker ID, option ID, task ID, amount, worker. Why is there no user ID here? Food just came. Submission where input. Where submission is not there for a user ID. Does a submission not have a user ID? Probably it does, right? It does have it doesn't have a user ID. What the fuck? Oh boy, the schema is messed up. Every user will, it'll be a worker ID, right? That makes a lot of sense. I do have a worker ID though. Do we have worker ID here? We do have worker ID. My bad. Where none worker ID is user ID. All right. Cool. That was it. That should be it actually. I don't know. Where this thing, find first. Find the first one is probably sorted by ID. So I think this is fine. And if not task, which means this user is out of tasks to review, then you can do a restart. We should also check if this is done or not. So, every task, if you go to schema, every task needs to have a field called done, which basically means this, we're not accepting any more submissions for this, which needs to be a Boolean, which by default is going to be false. Sounds pretty good. What else do you need? You need done is false. So you need to migrate the database, I guess. Add done to task and then regenerate the client. But specifically here, you need to make sure done is false. Only then you need to get the client, get the task already done. If not task, rest.json, status 411 JSON. No more tasks left for you to review. Else, just return the whole thing. Can we return the whole thing? Select options true, and then you can probably return the whole thing. Task looks pretty decent. Let's try it out, even though there's a type error right now, but oh, that happened. So let's generate the client again, and it goes away. tsc-b done false is still not there. Why? I did add done to tasks, right? If I go to task, there's a field called done over here. Did I migrate? I did migrate. Let's migrate one more time. All right, migration succeeded. Let's generate the client one more time and go back to worker.ts. Oh, there is still an error here. Why? What am I missing? Find first. Oh, oopsie daisy. None. There's a worker ID. Oh, this is the wrong place. My bad. Where done is false and this thing. Alrighty, there we go. Cool. Time to compile. Time to run it. Node dist/index.js. Let's okie dokie. Router.get requires a callback function, but did not get one because this is worker middleware, which comes from here. Did we imported the right place? We did. Router. Router.post/signin. That looks right. .get. Where's the get? That's the get. Rec, res. Worker middleware. What a user. Export function. It's like a function. Maybe I forgot to save it. Let's see. Nope. Huh. Something is up with the workers middleware. What's up here? Workers middleware. Export function workers middleware requests next and has a bunch of things inside. What's wrong there? Route.get requires a callback function but got an undefined, which means this is not being exported the right way. That looks right. ./middleware. That looks right. Everything looks right. What's up here? Did I forget to save a file? No, I did not. I'm sure you guys can already see what's up. Let's log worker middleware. Huh. It's undefined. Can you guess why? I don't know. Auth middleware. No, that looks right. Export function. Auth middleware export function. Yeah, I have no idea what's up here. Seriously doubt that's anything but worth trying. tsc-p followed by why is worker middleware undefined even though it's being imported from here? I'm sure when I find out I'm going to be super annoyed. Console. Has to be a typo or something, I don't know. Let's see. The fuck? Control never reaches here. Why? What the fuck? I'm cursing a little too much on the channel. I shouldn't do this. Huh. ./middleware. What does Vue.ts have? It has the same thing. Auth middleware is this thing. Okay, let's replace this with auth middleware and see if that works. Pretty sure it will. I'd be super surprised if this didn't work. Oh, oopsie daisy. It didn't. Huh. Index.ts. Why does it work here but doesn't work here? Because I'm importing worker router, which is exported by default. That looks right. Huh. Alrighty, let's comment this out and see. Oh, it doesn't work in the other place as well. What the fuck? Hold on. Something is wrong here. Where is this undefined log coming from? Okay, let's try that. Alright, that works. So basically, I've done something in middleware.ts as soon as I introduced the second guy right here that's messing things up. The question is, what did I introduce? I did not introduce anything. Is there some circular dependency? There's probably some circular dependency. Pretty sure there's a circular dependency. This imports index imports router. There's a circle. There we go. Kar do debug. This is, where, oh god, experience comes into the picture. This would have been really hard to debug. So there's a circular dependency. Middleware.ts imports index.ts. Index.ts imports user-router.ts. User-router.ts imports middleware.ts. So this is what's called a circular dependency. So, one of them just gets ignored. The way to fix that is fairly straightforward. Just move this export. We should have done this in the first place itself into, some sort of a config.ts and you'll be fine. Config.ts. And wherever you are using JWT_secret, which, oh boy. There you go. Rather than doing dot, you have to do a ./config, and then the same thing over here, and then the same thing over here, and you're good to go. tsc-b node list / oh, whoopsie daisy. Oh, ./config, ./config. I forgot to save a file amongst these, I'm assuming. Let's try that one more time. And node /index.js still does not work. Fuck. Why? Still feel like this is a circular dependency and there's nothing else. Whatever was introduced here. Let's just log some of these endpoints that we just made. Specifically, just remove this much and see if it works. tsc-p node index.js, that works. As soon as you introduce worker middleware, which does a //middleware, which doesn't import anything now, it's fine. Does just imports config, which is fine. Oh, there we go. Even better circular dependency. So worker imports middleware, middleware imports worker. So, that's wrong. So let's just move this again to / basically config only. So yeah, let's do this. And wherever this was defined, which was, so we basically get rid of this and move this over to config and then import that from there. Get rid of or add back worker middleware here and then JWT _. There we go. Should work now. So I just removed the circular dependency. Circular dependencies are when one file imports another one, another file imports the original file, and then TypeScript doesn't know what to do. It'll just keep going in circles. So it just ignores one of the files, which is exactly what was happening here. Now, if I go to Postman and try to hit the sign-in endpoint, I get this JWT right here. I can refetch it. It's fine. Either way works. Then I'm going to go to next task, which is going to be a GET request, and it's going to send my authorization header along. When I do that, I get back, you are not logged in. Why is that? It send a authorization header. It still says you are not logged in. I need to go to the worker middleware and see what's up here. Did I get an authorization header over here? Probably did. Did I? Yeah, that's good enough, I guess. Worker JWT secret, and what am I signing with? I am signing with worker JWT secret. I guess I just need to probably resend it. Maybe I was not doing it the right way the first time. So let's resend a request to sign in on the worker. Get back a JWT. Copy the JWT. Paste it in next task and go from there. Alrighty, send. There we go. We get a task. We should get a title as well. And then we get the options for the task. This is the task I need to solve next. Until I make a submission on this task, this is the one I'll keep getting. When I make a submission, I'll get the next one. The only thing that's missing now is the title. So let's quickly go to worker.ts and add title here as well. You need not just the task, but the title. True, there we go. I think that should do it. Send a request, you get back not just the options, but also the, wait for it, title. So you're good to go. Alrighty, that's good. Let's add the other endpoints. What's left now is a post to submissions, a get to balance in, a post to payout. So post submission is the most critical one next, which basically lets a user make a submission. Pretty straightforward. Let me minimize the other two routes that we have. Let's add the router.post/submission. The first thing we should check here is probably, is this the next, is this the sequence of next submission this user should make, or are they trying to, capture all the future submissions? We might add some timeout, right? You don't want a single person to just take all the submissions. If there are a lot of workers, you want to distribute work amongst them. So we should, number one, check here, is this the next relevant submission ID or worker or task for this specific user, and only then should you allow the submission to be made. So this logic that we've written here, basically that gets the next task, is something we should extract out and use in two places. So I'm going to create a db.ts file that's going to do this. So let's extract out this logic in a file called db.ts that exports a function called export const and get next task equal to, it takes the user ID as the input and returns, gets the next task and just returns it. Of course, this Prisma client needs to be initialized. Probably should be done from the same place, but that is fine. Alrighty. Where worker ID is user ID, this can be a number basically, and then we're good to go. In both the places, let's return the task as well. In both the places, rather than having const task, basically reuse this. Wait. There we go. Let's convert this to a number and then we're good to go. Const task will await get next task, and what's up here? it has an implicit any type. Why is that? This does return a type. What's up here? Crowdsourced. All right, I'm missing something obvious here. That looks right. If not a task, then do this, else do this. Oh, there we go. Then use the same thing here, and then get the body from the user. The user that's making a submission is going to send you some data, so you should go to types and specify the submission task input, export const create submission input. Needs to do what? It needs to take the task ID as an input, which is going to be, of course, the string, and then the selection, I guess, which needs to be a string is fine, should ideally be a number, but either way is fine. All right, need to charge the laptop. All right, create submission input is done. We're going to parse the input from the user. So const body, let's make this smaller, equal to rec.body, const input equal to await. What do we need to do here? Parsed body equal to input dot save. Parse the body, and then if parse body dot success, then you do something, else you do something else. And if there is a success is when you get the next task, and then you what do you do? If not task dot id, oh, what the fuck? Equal to parse body dot data dot task id, return rest dot status. Number and string have no. If either not task or this thing, then it should be fine. Else, make the submission on the user's end. So you're going to do a. Okay, task has amount as well. I hate that, fuck. Amount true. All right. If yeah, we need some things to be unique. So basically, we want to prevent the same user making two submissions on the same task. That way they can make more money. So our schema should add some uniqueness constraints here. Okay, every submission needs to be unique given a user ID or whatever, worker ID and task ID. Every worker should be allowed to make only one submission on a task, so that you don't somehow you're able to spoof the requests here and you make two submissions and make more money. So yeah, this much is good enough to enforce that. Let me migrate the database, add uniqueness constraint. Again, why are we adding this? We're adding this because we want to make sure a single worker can submit to a task only once. If they bombard our server backend with a bunch of requests, they might be able to put two entries here, put two submissions for the same task, which is bad because then they can get paid twice, thrice for the same thing. Alrighty, this looks right. Then if that is true, then you do await submission, await Prisma client dot submission dot create data user amount worker ID option and task ID. All right, option underscore ID equal to parsed body dot data dot it's called selection. Fine, I guess. Selection Convert this to a number, please. Okay. A unique constraint on the table submission will be added. There are duplicates, this will fail. Oh, I need to add a yes over here. Submission equal to this thing, the option ID, the worker ID, which is going to be user ID here, and lastly, what else do you need? Task ID, which is going to be parse_body dot data dot task ID already. Needs to be converted to a number, and we're good to go. Cool, data is done almost, I guess. Amount is missing. How much money should this guy make? Depends. How many submissions do you want the user to get? Let's say const max underscore or total underscore submissions. Submissions equal to 100 is good enough of a sample size. Then the amount needs to be task dot amount divided by total submissions. That's the amount that you should send to the user. The only problem here is needs to be a string, so probably just need to do a toString over here. Yeah, good to go. Have to love and hate TypeScript at the same time. Submission is done, and then you can just, what do you want to do next? You need to give the user the next task. You need to let them know, hey, you've made the submission, great, and this is your next task, so that they can pretty much move on to the next task from the front end. Rest.json next task, and maybe amount that they've made from the specific thingy, which is going to be this. So amount equal to this thing. Alrighty, great. Let's see if that works though. tsc-b node dist/index.js. Let's go to Postman. Let's try to make a submission on the problem ID, whatever the next problem ID for this user is, which is 1. So go to body, have task ID be 1 and selection be 1, I guess. I think 1 is the option ID for the task ID 1. If I send this, what happens? Needs to be a post /submission. Looks good. There we go. I get the next task. I also get the amount 0.01. That's the money that I can make. One important thing I missed was we need to increase the payable amount for the user. So you actually need to do a transaction here. You need to do a Prisma client dot transaction, which needs to do 2 things. First, make the submission. Return the submission. Cost submission equal to whatever. It also needs to increase the amount of money that the user has made. So it needs to do a await Prisma client dot user dot worker dot update, where worker ID equal to user ID, and then data amount, or pending amount that this person needs to pull out, increment by the amount. All right, there we go. That sounds pretty good. Needs to be a number probably, or whatever, string, I guess. Nope, string is not separate number, so it is a number. Alrighty, there we go. So you take a number and you convert it into a string, and then you convert it back to a number. Welcome to TypeScript. That looks good. Let's try that one more time. Let's do a tsc-b. Let's do a node disk/index.js. What's the next submission? If I try to make the submission again, it'll probably fail. It'll tell me, hey, this is not your task. You cannot make a submission on task ID 1. You've already done it. So I need to get my next task, which most probably will be a task with ID 2, and it has one option, just one option ID 2. So I can just replace both of them to be 2 and 2. And when I send this now, it should probably return me back I made 0.01. And if I go to Google Chrome and select star from worker, you will notice that I have now made 0.01. I have not made 0.01. So what did I miss? Oh, I did not restart, did I? Visual Studio Code, restart, save. Let's try that one more time. tsc-b node disk/index.js. Pretty sure my next task is task with ID 3. Send. And moment of truth. This did succeed. Why is the next task a task with ID 3 when I've already done it? That looks wrong. Something is wrong here. I need to await this. That makes a lot of sense. Try that one more time. Yeah, it needs to be 4 now. Probably 5, I think. This might fail. It might be 4. I don't know. We'll see. Takes a long time. The database is like extremely slow. Or my queries are, I guess. Yeah, task ID with 4 submitted. Next task is task with ID 5. Amount that I made is $0.01. If I go here and rerun this query, I probably see some pending amount. I don't see some pending amount. Why? Why do I not see pending amount when I've done a prisma.worker.update pending amount increment number? Is this wrong? Is this not how you do it? That's not how you increment. Oh, it's an integer. Is it not? It is an integer. Oh God. Actually, come to think of it, there will be a lot of precision issues here. We should not be storing things in non-decimal places. So let's just make that a number. Let's not keep pending underscore amount as an integer. Let's make it a string. We can also make it a float, I guess. But I guess string is fine, or int is also fine. Actually, int is good. But we should be storing the amount in lampports. By lampports, I mean, const total underscore decimals equal to, let's say, 10 to the 9. And that way, the amount that you're storing over here, amount in lampports, 10 to the 9. This actually might not be lampports. I think lampports is 10 to the 18, but this is fine as well. I'll explain what I'm doing here. Might be obvious to some, but basically the thing that we're storing in the database is an integer. And you can't store 0.01 as an integer, but you can store 0.01 into 10 to the 9. So in our database, everywhere we're going to store, the amount in lampports. In fact, when the task is created and we created, whatever the amount over here should ideally also be in a number or, an integer, and should be stored in lampports. We shouldn't be storing the amount as such as a string. That's actually pretty bad. So what we can do is fix this from the top, which means first convert amount to be a number or integer. Then whenever a task is generated, so if you go to user.ts, whenever a task is created, rather than storing the amount as such, we are going to store the amount to be, 1 into whatever, 10 to the 9 or decimal, which I guess is something we can import. Did not export it, did I? Export const total decimal. Let's store this in config.ts, and from here, let's import it in both the places. Let's go back to user.ts. Yeah, so what we're storing now in the database everywhere is going to be the amount in lampports, which means, what is lampports? It basically means you should never store in your database floats when it comes to amounts. You should never store 0.01 rupees or 0.001 rupees. It leads to a lot of precision errors. And hence, wherever you see amount, it should ideally just be an integer. I did make that. Let me just migrate my database. Make it number. I should have selected a better name. But what does this do? It makes sure everywhere you're storing an integer. So even if the user says, okay, hey, I want to pay 0.01 rupees, what you store is 0.01 in 10 to the 9. Why is this good? This is good because your database has no floats when it comes to amounts. And if you do put floats in your database, it leads to a lot of precision errors. What are precision errors? Basically, when you bring 0.01 in your JavaScript thread, a lot of times, it becomes 0.01 becomes 0.0099999, something like that. And you basically miss out on some money here. You don't want that. So you sometimes do strings as well. They are fine. But the best thing you can do is, just store integers everywhere. Even on the blockchain, whenever you're storing data, you store numbers, you never store floats, and you have, this decimal number somewhere in your code, which usually is 10 to the 9 or 10 to the 18. And the smallest unit of money that you can transfer to someone is, in our case, it's going to be 1 divided by 10 to the 9, but in most blockchains is actually 1 divided by 10 to the 18. That's what WETH is, if you've heard of it, or WETH is, I guess, I don't know, on Ethereum. All right, amount casting is not allowed, so I just need to pretty much delete my database, go back to Google Chrome and delete from tasks. Before that, I'll have to probably delete from options. So let's do that. Delete everything from the options table. Submission. Let's delete everything from the submissions table. Then delete everything from the options table. Then delete everything from the task table. Then create a few more tasks. How do you create a few tasks? Go to Postman, select the endpoint which you had to create a task, which is this one right here. Create a few tasks which you cannot because your server is not up. Let's bring the server up. tsc-p node dist oopsie daisy amount is 1 into this number. Number is not available to string. We're stuck in what's called a deadlock. I cannot compile the code because it says this should be a string, but it is a number. But if I go here, the way to fix that is to migrate the database, but I cannot migrate the database until I add a new. I can migrate the database now, I guess. Let me just migrate the database. Yeah, my bad, there's no deadlock. I've migrated the database and made this amount an integer, and whenever a task is created, the amount that will be stored over there would be, in this case it's 1, but a lot of people will pay 0.5 sol, a lot of people will pay 0.05 sol based on how much sample size they need. Some people only need 1,000 people, some people need 100 people. So yeah, this amount will change based on that. The thing that's stored in the database would be 0.05 into 10^9, so that is always an integer. The smallest amount that's a task can be assigned is 0.000000001, which, or you get the idea, 1 divided by 10^9. So that everything that's stored in the database is always an integer. You never store a float in your database, which is generally true. If you're building Paytm, if you're building any financial app, never store number, or Razorpay, let's say you're building a payment gateway, never store decimals in your database. They'll come to bite you eventually. Database migration is taking a long time. Let's see if there's something left. What's up for us to do next? Submission is done. Get balance should be straightforward. Let's quickly implement that while this is happening. So let's go to worker.ts, and amongst the many endpoints that we have, let's add a new endpoint called router.get/balance, which thankfully doesn't have to do much. Should be a fairly simple endpoint. It needs to do a const worker equal to await Prisma client dot worker dot find one, or find first, where user ID is user ID clurec dot user ID ts dot ignore string. Alrighty, where ID is user ID, and then simply return amount that you have is worker dot pending amount, and maybe return the logged amount as well. Should probably return both. Okie dokie. Looks pretty good. I think this will just work. I don't need to test it. I will test it though. Migration is done. Regenerate the client. tsc-v, you'll notice the type error goes away. If you remember, there was a type error over here, and now it's gone. You still see it here because VS Code is a little slow, but the code is compiling, which means the error goes away. The amount that's being stored now is always an integer. Let's do a node disk/index.js. Go to Postman, create a fresh stack. Fresh task. Let's create a few more. Something is wrong here. Options are fine. I just need to remove this comma, and then good to go. The first task is created with an ID 6, another one is created with an ID 7, another one is created with an ID 8. Then let's get the next task for this specific worker by hitting the next task endpoint. This will return the next task that this user has to do. Basically, when they use they reach the front end, the worker reaches the front end. This is the page they will reach, right? They will get the next task, get the amount, get the ID, and make a submission on the 6,9. So let's create a submission for task ID 6 and option ID 9. When I do, now I think the worker should get some money in their account. If I go to Google Chrome, after this succeeds, it did not succeed. Amount could not be updated because unable to fit into integer value. Fuck. Yeah, 10^9 is a little too much. But why did this person make so much money to begin with? It doesn't matter either way. We don't. Yeah, I think for us, 10^6 is good enough. Probably even lesser is good enough, if I'm being honest. But yeah, let's start there. Oh, that's not it. Is that it? Let's see. We need to go to worker.ts. What was the amount again? Oh. It was task amount divided by total submission, which is 100. That's not a lot of money. Why was this not able to be stored in the database? What was the error? Went away. Let's try it one more time. What's the number being stored in the incorrect task ID? Oh, that sounds super bad. It seems like the transaction failed, yet the submission happened. Is that not how you do transactions? Oh boy, that just looks wrong. Maybe we're doing transactions the wrong way. Worker, run. Oh fuck, I deleted. No, I did not delete, thank God. Select star from worker, amount is 0, but select star from submission, and you will notice that a single submission has been made. And this is the amount associated to that submission, which means, oh, this is a string though, that's probably why it worked. Schema.prisma, change the amount in the third place as well to be an integer. And lastly, we decreased this thing, which is fine. The number of decimals, yeah, I just need to delete everything and go from there. So delete every submission, then delete every option, and then delete every task, and then re-add a few tasks. One, two, that's wrong. One. Is the database very slow, or are my queries messed up? This looks like, okay, I guess it's just the database is sleeping, and yeah, it just wakes up when I send the first request. All right, this is done. Let's try to, oh shit, what was it? ID is, I can just get the next task, I guess. The next task for this user includes ID 9, option 18. So that's what I'm going to submit. If I go to submissions, ID 9, selection 18. If I click on submit, you will notice something's up with transactions that we need to fix. But before that, let's see if this works. Socket hung up again. What does it say? Unable to fit integer value this thing into a 32-bit integer. That is fine. Worker.update. Basically, this failed. The biggest problem I have with this now is if this is actually a transaction, which it seems like it isn't anymore, how did this fail yet this succeed? They should fail together, right? So I'm not doing transactions the right way. So transactions in, what was it called? Prisma. Okay, that's how you do a transaction. That makes much more sense. And what is a batch query then? How do I use data from one in another one? That's exactly what I did, right? Example. Let's look at example. Imagine you're building an Olympic system. Transfer amount doesn't appear. Amount doesn't double. This is great use for it. Yeah, exactly. Return Prisma or transaction TX. Oh, am I doing Prisma client somewhere? Oh, fucking A. That's it. Chalo, we found a bug. Cool. So let's first see if this bug is fixed or not, because that's a big thing we should fix. Seems like it is though. Yeah, you should, whenever you're creating a transaction, the whole point of this TX object is that you use it here and not the Prisma client itself. I was using the Prisma client, which is why, one thing was happening but the other wasn't. But now if I get the next task, which is 1021, and if I try to submit on 1021, you will notice that the whole thing fails, and even the submission isn't made. If I go back to the submissions table after this is done, the whole thing failed. But if I go here to the Neon console and do a select star from submission, it should have a single submission and not two. If it has a single submission, you're good. It does have a single submission. The only question that's left is, why is the second query failing? Amount, pending amount, increment by number of, okay, that's my bad. I multiplied it by, you don't need that anymore. Alrighty, good to go, guys. Now if I do this one more time, go to Postman, send a request. We should be able to make a submission. We should also have an entry in the table of the amount that you've made. There we go. Everything is fine. You get back the next sort of thing to submit on, which is 1124. Let's put that as well, and have 2 submissions for this user, and then let's see the amount of money that they've made. Worked. If I go to select star from worker, this person should have 0.2. Oh yeah, exactly, 2 divided by 5. That's fine. Perfect. Seems like it worked. Seems like we have all the endpoints. Are we missing something? We probably are missing one. I remember there was one more. Post/payout. Oh yeah, this one's going to be tricky. This one's going to be pretty Solana specific, so we can come back to this. Let me just add the skeleton for it, but we can come back to this one, and then we're good to go. Hello. All right, I just realized I wasn't recording. Thankfully, I did not do much. I just added a dummy endpoint /payout. Let me close everything else. Let me move this to the top. And while I was adding the payout endpoint, I realized I need to add something else to the database, which is something called payouts. Payouts basically means anytime we're sending out the money to a worker, we need to have this entry in the database. We need to store ki, this is the signature of the transaction we've sent on the blockchain, and this is its current status. It will start with processing and eventually move to success or failure based on when the worker polls the tables and eventually finds this transaction. And if this transaction does succeed, the worker will set it as successful, else it will set it as failure. So this is a payouts table that we need to have. I did add this. It has an ID, a user ID. Who is the user who's trying to pull out money? Amount of money they're trying to pull out. The transaction signature from the blockchain that you've submitted. And you're waiting for the transaction to happen, and then finally a status, which could be processing success or failure. This is an enum. That's the only thing I added here. Now I need to add, eventually we will have logic here. There we go. To create a transaction, so we'll get a const transaction ID equal to. Let me put some random data here, but eventually we will create a transaction here. What does creating a transaction mean? You just use a Solana library, Solana/Web3.js, and create a transaction to transfer some money from your own wallet over to this specific user's wallet, which you can get the amount. This is actually worker, and then you can get the address of the user by doing this const address equal to worker.address. This should never happen. Control should never reach here, but still. There we go. You basically need to do something like this. Solana.web3.create transaction, or actually something like this. If I'm being honest, new transaction, and then where transaction comes from a Solana library, specifically Solana/Web3.js. We'll be getting to this very soon, but you create a transaction object first by doing something like this. Inside, of course, you put, I want to send money from this address to a different address, which is, the dynamic address here. And once you do that, you get a transaction signature. Before you actually submit this on the blockchain, though, you should make an entry in your database. So you should do a Prisma client.transaction again, because we need to do 2 things. Number one, we need to move the money for the worker from pending amount to logged amount. Since we're about to send this transaction, this amount needs to be logged for the next 1 hour or so. We need to make sure that this amount doesn't, we don't want to make it 0. This transaction might fail, which is why we moved it from pending to logged, which basically means it's logged for the next 1 hour. If the user tries to resend a transaction, we will prevent them right there. And the thing, this will be tough actually. The user can bombard this request. We need to actually add a lock here. We'll get there very soon. Await tx.worker.update, where user ID is whatever user ID, and you need to set data. All right, data. We need to take pending amount, and we need to do a increment, which needs to be How do you do increments again? Oh, there we go. Pending amount needs to decrease by amount. Where's amount though? And yeah, this is wrong, by the way. There's a bug here, but we can fix it eventually. Like, this is vulnerable. The user can send two requests together, and make their balance negative. We need to log the table basically here, which I think is fairly easily doable in Prisma. Let's see, locking a table in Prisma. Oh, they don't allow that, do they? We have to send a raw query. Oh yeah, they don't allow that. You have to send a raw query. We should fix this. We should add a lock here. You have to send a raw query when you're doing that. I suddenly remember I did this in the code. All right, number. This looks fine. Oh, what's up here? Oh, sorry, it'll be an ID. And you need to do one more thing, which is transaction.worker. Payouts. Oh. And payouts, let's try that one more time. I did try to migrate. I had to clean the database first. Just done that. Let's see if the migration succeeds now. In case it does, we probably need to do payouts.create data user ID, or user_ID would be user ID. Amount would be worker.pending amount. And what else? Status would be processing. Anything else you need? User ID, signature. Signature would be whatever is a transaction ID I had here. Alrighty. Yeah, once this is done, once you've actually put this in the database, is when you should send the transaction to the Solana blockchain. Harkirat, what if this succeeds but this fails? That is fine. The transaction will never reach the blockchain. The worker will keep polling this record and eventually be like, hey, this has failed. That is fine. What you don't want is, can you first send the transaction, and then let's say the server goes down right after this happens, or your database goes down. So you never have an entry to debit the account of the user, but you did send a transaction to the blockchain. You don't want that. If you're doing these sequentially, which we need to first do one thing and then the other one. The first thing you should do is make an entry in your database, and that is exactly why we have a logged this thing here, amount here, so that when the transfer is happening, the amount should be logged. The user should not be able to pull out more money. This is still vulnerable, as I said. The user can send two requests here really fast, and the worker that you see over here, both the in-memory objects will have the same amount, and hence, yeah, this will basically break. The user might be able to set the pending amount as negative, and be able to send out two transactions. So if they have a balance of 2 SOL, they might be able to pull out 4 SOL, which you can pretty easily fix by adding a lock here. What does a lock mean? A lock basically means, this transaction or this specific database is logged, or this specific row is logged. Specifically, the thing that you need to lock is this workers table/row over here. Here, this row, until this whole transaction succeeds, cannot be touched. No one else can update the pending amount or the logged amount, or even get the pending amount or the logged amount until one of these transactions happens. So if two come simultaneously, the first one will lock the database, the second one won't be able to proceed until the first one completes end to end. So that is why you need locking. Fairly easy to add. Prisma doesn't support it natively, I think, from my very vague knowledge. So you have to write raw SQL queries, and that pretty much does this. Alrighty, I think the database has migrated. It has. Let's generate the Prisma client again, and then hopefully payouts does exist. It doesn't exist still. Why? What's it called? It's called payouts. Let's try to regenerate it. User is there, payouts is not there. Why is payouts not there? That sounds wrong. It is there. There you go. Payouts. Okay, there you go. User ID is incorrect. That is because it's called user ID, and this is a string, should be a number. There we go. Alrighty. Cool. We've written a decent bunch of seriously. amount. There we go. What endpoint was this? Submission endpoint. All right. Oh yeah, I changed that schema. Cool. This works. Yeah, if I ever try to pay myself out now, if you look at /payout, you don't need to send anything. Yeah, I should do one thing here though. Message processing payout amount, the amount that the user has, which in this case is just the amount variable or worker.amount, I guess. All righty. That looks pretty good. Whenever the payout endpoint is hit, you first get the details of the worker. You make sure that the worker exists. You should probably lock this specific row at the very least at this point as well. Then you get the address of the user. You create an in-memory transaction. What does an in-memory transaction mean? It means you don't send it to the Solana blockchain just yet. You just create the transaction. You get the transaction signature. This transaction is different. This is a database transaction. This is a Solana blockchain transaction. Then you do two things inside a transaction, which means either both of them happen or none. What is the first thing that happens over here? You move the money from pending amount to logged amount. You want this amount to be logged for now. And then you create a payout for the user. Okay, hey, this user, this amount we've sent to the blockchain. We're about to send to the blockchain. So the worker, what worker? If you remember, this specific transaction sweeper needs to keep polling this payouts table and checking, hey, which transaction has succeeded. It is in processing right now. So it'll get all the processing transactions, check which one of them has succeeded. The ones that have succeeded, it will mark their status as success, and it will remove the logged amount because the money has actually moved. If the money hasn't moved, if the transaction hasn't succeeded for a really long time, then it will move the money back from logged amount to pending amount so that the end user can re-ask for another transaction. Yeah, that's a brief of what this endpoint does. We have not yet sent a transaction / created one. But that's where the Solana Web3 stuff comes into the picture. Let's try if this endpoint works. If I go to Postman and if I click on /payout, it breaks because the server isn't running. But if I do send it now, you will notice it says processing payout of 0.2 Sol. If you remember, decimal was 10⁶. This divided by 10⁶ is 0.2 Sol. And if I keep sending this now, what do you think will happen? How much amount? 0. Since the certain amount is already logged, the amount variable has now gone down to 0. The pending amount has gone down to 0. Logged amount has something, but the user can only ask for withdrawal on the pending amount. If they have asked for a withdrawal once, this pending amount has moved to logged amount. Now they cannot keep re-asking. They cannot pull out money twice from our system. This is like fairly common pattern you will notice in most exchanges as well. Whenever you go to an exchange, like Kraken, Binance, Backpack, and try to withdraw some money, if you had a balance of 20 Sol, it will show you 20 Sol, but in the locked state, which means you can't, ask Backpack to again send another transaction. Only one is happening. Whenever it succeeds is when, you get your money in your wallet. That's a brief of what we've built. We've built all the Web2 stuff, which means, all the steps from here to here. We need to build the front end next, I guess. So yeah, let me create the front end that lets the user, there's something else. Yeah, create the front end for the user side, create the front end for the worker side. Probably going to be fairly ugly front end because it's already a 3-hour video. We have to get into the Web3 bits next. So yeah, fairly ugly, front end most probably. Let's get into the front end bits and finish this off so we can move into the juicy Web3 bits. Alrighty, before we proceed at all, we should add cores because our front ends and back ends are going to be hosted on separate URLs. So npmi cores at types/cores, import cores from cores, and then add.use cores should be fine. This is needed because our front end and backends are going to be hosted on different URLs. The backend won't, or the browser will basically block requests to this backend unless cores is enabled, which we just did over here. Now let's get into the user front end first. This is the backend. This is the user front end. This is the worker front end. We'll kick things off by building the user frontend. Let's do a npm run dev over here. Let's click on user frontend app/page.tsx, and let's replace all this code with some basic, boilerplate code that lets people come and pay $50, upload their images, and create a task. Most applications in crypto will have an app bar at the very top. If you go to any crypto website here, you'll see there's an app bar that has a connect wallet button. This is like standard UX, irrespective of what decentralized app you're on. So let's have an app bar. Let me create component. I already have components / app bar.tsx export const app bar returns a div. Alrighty, let's import this. Let's do a hi there over here just to make sure things are on the up and up. Go to localhost 3000 and you see hi there. Let's go to main dot. I guess black background is fine. Next up, we're going to let's create a component called upload image.tsx, which will have all the logic to upload an image. So here return a div which can look something like this, w-40 h-40 rounded border, and have like a plus button in there. Let's render this in page.jsx, upload image. All right, something like this looks decent. Only text-2xl and then div class name equal to w-full and flex justify center flex-call. Basically centrally align the whole thing. Yeah, should be fine. Oh, sorry, edge-full, that's my bad. Alrighty, a plus button. Let's make this a cursor as well. When the user clicks on needs to be a client component. When the user clicks on plus is when you should show the pop-up for them to select an image. How do you do that? Oh god, HTML. I guess the pre-signed URLs in AWS. The blog post that we were going through pretty much should cover this. Pre-signed. Where did that go though? All right. AWS HTML. We'll have to write it ourselves. It's fine. Select file HTML. Try it yourself. You click. Oops, daisy. Go back. Run it. Choose a file. Let's say whatever some PNG file. And then click on submit, and then you hopefully see it. Yeah, you see something. All right. This is probably an easier way, but okay, let's just go like this. Div on click file select. Alrighty, that sounds right. Oh god. should move this to Tailwind eventually, or maybe right now. Let's see if that works. So if I go back here, click on plus, I can select file. What happens when I on select file, console.log file? You can also add constraints here. You probably should add constraints here. Otherwise, I don't see a dash pointer. There we go. All right, let's say you select the image. What do you see in the console? You see nothing. Why is that? On select, on change. There we go. The target dot value is the path to a file, but not the file exactly. Yeah, I just need the blog post. Why is clicking anywhere opening it? That just is wrong. Input. Whoa. That looks wrong. Oh, I guess do a relative here, and then I can do an absolute here. Stop recording. All right, I think I'm just going to speed ramp this. This is the next day, by the way. But let me speed ramp building the whole front end, at least the user side, and then I'll explain what I've done. Alrighty, quick call out here. You need to add this course origin policy, else you won't be able to hit the pre-signed URLs from the front end. What was happening right now is when I try to upload an image, I get back the pre-signed URL, I try to upload it to S3 and I get this error that says, well, it won't come now, I'm assuming. Yeah, now it gives a 403, but earlier it was giving a course error. And I still need to figure out why I'm getting a 403. Probably because this doesn't need to be a... Oh, I just need to refresh the page, I guess. Let's try that one more time. It'll work now most probably because I've added the policy. Yeah, I don't see any errors now. I see a 400 error, but earlier what I was seeing a course error. The way to fix a course error I found here on a Stack Overflow. I just need to tell S3 I want to allow people to upload directly from a browser, and I need to enable course for ideally a restricted origin, but like star is fine for now. Alrighty, let's proceed. Oh, undefined.
Twenty minutes later.
All right. I was being a little slow, and you know, when you're slow as a developer, there is only one thing you can do. By the end of it, I think in the last 30 minutes or so, this is where I've reached. I have a website where you can come put the details of your task. For example, create a thumbnail and add images for your thumbnails. For example, let's say I have 4 thumbnails to compare. Probably should be a bulk upload option, something like that. Alrighty. Once I've uploaded the 4 thumbnails and maybe given a task, you know, details / what the labelers have to do, there's a submit task button. If I open the network tab and click on the submit task button, you will see a request goes out to /task, which succeeds. Gives you back the task ID. It went away from here, did not preserve the logs, but you get the idea. A task was created and the user was redirected to /task/15. I still need to create this page so that the user can see all of their options and then also the number of votes that have happened on each one of them. That's what I'll be creating next. But for now, this is where we're at. If you look at the code, it's fairly decently structured. If you look at page.tsx, it has 3 parts: the app bar, the hero section, and the upload section. If I go back to the landing page, this is the app bar. Of course, it's fairly dummy right now. Eventually, we'll add a connect wallet button here, like the one that really pops up a phantom wallet, a bunch of text, and then eventually the upload section. This specific thing right here, this component is what renders all of this. If you go into the upload component, it has a function that gets called when you click on the submit button, and then a text called create task, an input box where the user can put their details, and then a label for add images, and then lastly iterates over all the current images that exist. Currently there aren't any, but if I add an image over here, a state variable is populated called images, which gets all of these images in an array. I iterate over all these images and render them. For example, as soon as one image gets added here, that's the first one that's rendered, and then I have a upload image component over here as well, which is what gives this plus icon. If you want to pretty much explore how I'm sending things to S3, you can reuse this upload image component in your thingy, or just look at what it does. To quickly take you through it, it renders a very big box. The most important thing here is a hidden input box, which when you click on it, it opens the type over here is file, which is why when you click on it, it opens this file explorer. You can actually add more restrictions and only restrict to images. But right now it does anything, and when the user does put an image in, on file select gets called, where we get the file from the user, we get the pre-signed URL, we pre-fill all the details like we did in Postman, and then we finally send a request over to CloudFront. Finally send a request over to the pre-signed URL, and we let the parent component know that, hey, a new image was added on this CloudFront URL /response.data.fields of key, which basically means the current key of the image. For example, this image right here, if you look at it, it's stored at the CloudFront URL /fiverr/1/0.77. This is the, /image.png. This is the URL where it's stored. We just let the parent component know that, so that the parent component can propagate it to the images state variable, and then we're just iterating over all the images in the state variable and rendering them here. That's how you create a task. Next up, I'm building the front end for viewing the task and all the responses of it. And then, we probably don't have an endpoint, do we? We do have an endpoint that gives you all the response details, so that's fine. Next up, I'll be building that front end, and then I'll go on to the the worker front end, I guess. Alrighty, I've created this page where a user can come and track all of their tasks. For example, if this user creates a fresh task, what is the best thumbnail here, and adds a few images. For example, image number 1 followed by image number 2 followed by image number 3, and let's say they create this task. Once the task is submitted, they're redirected to this task specific page where they can track the current set of votes. You can make this very fancy. You can add polling, you can add WebSockets, so the user can in real time get the votes as they as workers on the other side keep on voting, or the user can just refresh. Either thing works for now, and yeah, that's what we have. That's enough for the user side. Of course, we're not yet accepting payments. This connect wallet button does nothing, which is something we'll be getting to in the payments part. But yeah, I think we're going to call it here on the user's front end. If you want to look at the code, this is the app/task/task ID inside brackets, which means this can be a dynamic route /page.tsx is where I've written all of this code. We get the task ID, which is, this thing right here, which pretty much comes from here, the URL. So if it's 17, I get 17 over here in this task ID variable. I've made this a client-side component. The reason for this is we're storing all the authentication details in local storage, so you can't really use server-side rendering here, unfortunately. If you want to use server-side rendering, you have to use cookies. You also have to have your backend in Nextjs. Else, yeah, you just have to go with the React approach. So there's no benefit of using Nextjs here. We're just doing client-side rendering all along, by which I mean I have a top-level use effect which gets all the details for this task ID and then sets the result in this result state variable and sets the details of the task, the title, things like these, in this task variable. Then I render the title of the task, and then I iterate over all the images. And this should probably be an option. This should probably not be called a task. The component over here, this component over here, is renders image and the number of votes, image and the number of votes. Ideally, there should be some sort of a graph here that shows you, 30%, 40%, whatever. You can make this more fancy, but yeah, this is a brief of building this specific tasks page for the user. Now let's get to the other side. Let's create the second front end where workers can come, find the next thumbnail to rate, click on a thumbnail, make a submission, and go from there, track the amount they're currently owed, and we'll create a button that they can click on and initiate the payout. And then in the Web3 section, we'll actually write all the logic to actually initiate the payout. Let's get into the next bit. Alrighty, let's start by building the workers front end. The worker front end currently is the basic boilerplate code that you get if you ever bring in a Nextjs project. So let's quickly clean that up and start from a fresh slate. Let's return a div over here. Let's go to global.css and remove all the extra CSS that's present over here, other than of course Tailwind. Let's put a hi there here. Let's do a yarn dev really quick and ensure that we have an application running which prints hi there. Now what do we need? First of all, we need an app bar, very similar to the one that we had in the other one. Ideally, you should use a monorepo here and share the app bar across both the front ends. We're not using a monorepo right now, which is why I will just recreate the component that looks very similar to the one we already had. So components /appbar.tsx. If anything, it can just be a copy at the moment of the user front end. So I'm going to take it and copy it here. I'm going to call it Turkify worker. So we know this is the workers front end. Connect wallet button, and then paste that here in page.tsx. Already we have an app bar. Next up, When the user comes here, they will connect their wallet. And once they do, they need to see the next task for them to solve, which basically means the thing that we need to render is probably a next task component, where we'll just fetch the next task for this specific user and excuse me, let them select the task that they like to solve, or like the submission for that specific task. So export cons next task here. So what does this guy need to do? Again, we have to do some client-side rendering here. We unfortunately cannot use the benefits of server-side rendering because of the way our authentication works. Of course, firstly, the user needs to click on connect wallet, sign into the backend. We're ignoring all of that. We're just going to hard code in the local storage here a token for now, so that when the user comes, they have a token already here that they're sending back with every request. Eventually, this token will be propagated after you connect your wallet, after you send a request to the /signin endpoint. We're not touching the /signin endpoint at all right now. All right. So let me just first create a quick token for a worker. Let me go to Visual Studio Code. Let me start the backend, which says it's already running. Start the backend and then start the front end again on 3001. Let's go to Postman here and try to do a worker sign in. Right now, if you remember, worker sign in sends in nothing. We have a very dummy endpoint, but eventually we will, be signing a message using Solana and sending that to the backend. I have this token. I'm going to paste it here so that, my front end is pseudo signed in. Even though the user did not actually sign in, we'll be adding that logic later. At least we've hard-coded this in the local storage, so every request can carry this token to the backend and tell the backend that they're logged in. Now we need to fetch the next task, which can be as simple as this: whenever const current task, set current task equal to use state empty, and then whenever the component mounts, we need to send a request using Axios. So Axios. I need to do an npm I Axios here, and then do an Axios dot get. I need to again create a config.ts file here. I would repeat, you should ideally put all of this, create a monorepo and put all of this logic in the same place. You don't need to repeat everything in two different places. Let me just go to the config.ts of user/config. What did we call it in the user front end? We call it utils. Probably should follow the same format. So let's just call this delete config.ts, create a folder here called utils, and create utils/index.ts, which exports const. This I can copy from the user's front end. The backend URL is the same. The CloudFront URL is the same. Again, ideally you would want to keep this in the same place in a monorepo, and you shouldn't have it in two places. You should follow the dry rule. Do not repeat yourself. You get the idea. Let's do an Axios.get backend URL /v1/worker/ next task. I think that's the input. Let's confirm. Let's go to Postman. Let's search for, there you go, next task. It is a get request to /v1 worker next task. That looks right. Dot then response. When you get the response, you can set it in the state. So set current state res.data. I don't remember what kind of format, what format of data this is returned. Let's see. Okay, it looks something like this. So let's create a type over here. Interface task looks something like this. It has an ID, which is a number. First of all, this should be dot task. It has an ID, which is a number. It has an amount, which is a number as well, which is, I guess, the amount of this whole task, not the amount that you'll be paid. Title, which is a string. Options, which is an array of this type, ID, number, image underscore URL string, and then task underscore ID number. Ideally, the casing should be same in both the places. Mostly, you should not follow this casing. You should follow the camel case in everywhere, but since this is what the backend returns, we'll have to deal with this for now. there should be an array of tasks, which means, this should be a task, which task or null in case there is no next task. And let's initialize this to null. Let's also do const loading, set loading equal to use state true. Over here, let's do set loading true, and then let's do a set loading false here. And we should also say if loading, then simply return a loader, else return the actual details of the task. If not task, if there is no next task for this user to pick, then also we should return a div that says please check back in some time. There are no pending tasks at the moment. There we go. And then lastly, if there is a task, we are going to render we can render the same thing as we rendered in this thing right here. Task.tsx, there we go. Which basically means something like this. The title and then iterating over all the tasks. Again, if you had a mono repo here, you could get rid of all this code repetition. Unfortunately, we don't, which is why, you see this current task dot options. I think it's an array, so I don't need to do this anymore. Dot map task should be an option actually. Option function. What does this take as inputs? It takes the image URL as input, as well as daisy votes image URL string votes, which is a number, and again I can just copy the visuals from here and we're good to go. This would be task or option, I guess. Option dot image underscore URL, and you don't need the count. The user doesn't need to see the counts for other people. If anything, we should hide it from the backend as well, but it's fine for now. You see 4 images. Anytime you click on an image is when you need to tell the backend that this option has been selected, which means we also need the ID over here. ID equal to option.id. There we go. ID. And here is where we will tell the backend. You probably should just, call a parent function here called onSelect. Which we will pass from here. Axios dot post backend URL slash API v1 slash worker slash submission. And what's the types of this input? It's task ID and selection. So task ID, it will be current task dot ID, and submission, it will be selection, it will be option.id. Await const response equal to this. And if you remember, this would also return as the next task. So we would do a const next task equal to await response dot data dot next task. I think that was it. Let's see what happens when I do a submission. This will be really hard, won't it? Like, this won't work because this probably isn't the next task. Yeah, next task for this user is 6. Oh, daisy. It is 14 and 33. So let's do a submission on 14 and 33. And when we do that, we get back a response that looks something like nothing. Socket hung up, which basically means the backend died. Question is why? Unable to start a transaction in the given time. That sounds scary. We will have to check what happened there. It does not return the next task. Why does it not return a next task? Oh, there it does. Next task, which has, the same things. So yeah, basically can do something like this. Let's go to, oh yeah, there you go. Alrighty, that looks pretty decent. On select, don't need the ID here. Alrighty, let's look at the code really quickly. If it is loading, we show loading ... If we don't have a current task, which means all the tasks the user has done, then we show this. Else, we tell the user, hey, this is the title for the task. These are the images. Please select one. When the user clicks on any of the images, we call on select over here for that specific option, which lets the backend know, hey, this is the submission for this user. Gets the next task and does its thing here. One thing we should do here is refresh the user balance in the app bar. The user will probably see their balance somewhere here. Okay, you have 30 rupees pending or for 50 SOL pending. So this should get updated every time they pay some money. That's good incentive for them to work, I guess. So alrighty, localhost 3001. If I go here now, you will see it says failed to compile, probably because this needs to be a client component. Refresh, and there we go. I see loading, and then I see a backend error here. Let's see what it says. It says there is an Axios error. Why is there an Axios error? Because 403, you're not logged in. That is correct. Whenever I do an axios.get, axios.post, I need to send in a header, which is my authorization header, which is going to be nothing but this token. I need to do the same thing over here. Alrighty, that works. Let's do nothing. Let's just refresh. Still see an error. Let's see what's up. Still a 403. Am I sending my authorization header? I am sending an authorization header, yet it fails. Why? It fails because I've maybe logged in to the worker user when I was supposed to log into the worker. So let's do a sign in one more time. What was my last sign in? My last sign in was on the worker. That looks right. I signed into the worker, and that's the, oh, this is localhost 3001. My bad. I put this token on localhost 3000. This is the user token that I have here. Now let me replace it, refresh, and it should just work. I don't see a red error. That's a good sign. Loading, taking a long time, and broke again. Let's see what's up here. This time something else broke. 411, which means we're sending something wrong. Oh, did get back a task, but I also got a 411 status code. No, this is, yeah, I did get back the task, but also 411. Why is that? Let's go to worker.ts and search for /balance submission. There we go. No, next task. There we go. This is the one. And what's up here? When are you sending a 411? Oh no, there's an if and an else. It's sending a 411. Why did I do that? Alrighty, let me fix that. Let's try that one more time. Loading, followed by, there we go, the task. This is the next task I have to follow. I have to choose a thumbnail. Let me choose this one right here. I click on it, and then nothing happens. Network tab, click on it. Oh, there's a request that goes out. And it takes a long time. It takes a really long time. We have messed up the transaction somehow. No database call should take this longer time. Something is up here. What happens when I do a /submission? The body. It's fine. Submission to the transaction. We create a submission, we update the submission. If I update the worker, I increment the amount that they have made. Why is this pending for such a long time? Seems like when some sort of a deadlock, where future requests are not able to do something. Let's see. Try that one more time. This transaction seems fishy. I'm sure the control is reaching here. It's not reaching here, I would assume. Here 1, here 2, and then here 3. Alrighty. tsc-b node/index.js. Let's select it. Pending. Control reaches nowhere. Alrighty, that looks weird. Oh. Else I do nothing. Why? I should send back a rest.status 411.json. Message incorrect inputs. Alright, the point is that the inputs are incorrect, which means task ID is a string and selection is a string. I'm probably sending numbers. That's probably, yeah. Alrighty, let's convert them to strings and go from there. Let's go to next task.tsx, and when we're sending data, I should convert them to strings because Zord is extremely strict. You can actually make it less strict if you want, like allow type casting between numbers and strings, but that's fine. Let's keep it strict. Let's refresh. Says loading. Do I see my next task? I do see my next task. Wow, the database calls are like, or the images, I don't know, something is slow. Click here and it tries to submit it, and it's still pending. Oh, here 1, here 2, here 3, and it does. Please rate the best thumbnail. That's the next photo that should have ideally come, but I don't see any thumbnails. Why? Console. What was the next task like? Let's see. If you go here, I sent a submission, and what response did I get back? I don't remember. Okay, please rate. So the title came back correctly for the next thumbnail, but it seems like the options didn't. Question is why? What's the input required? ID, amount, title, and options. And what do I send back? Oh, probably the image URL is messed up, something like that. Let's see. If I go to here, get rid of this, get rid of this, get rid of this. Oh, it looks right. Oh, .next task, which is what I did. Excuse me. Which comes from the same function as this one. Oh. No, it looks right. That looks right. What we can do is we can go back to nextjs.tsx and here render the whole thing. Alright, this is what it looks like. Why are options empty? Why are options? If I refresh, oh, options are empty. Oh, I created one with no options. I suddenly remember. We should block that. Let's go to worker. Let's go to types, and here, whenever you have options, not min one, you should have minimum 2 options, else you should not allow the user to be able to create a problem. Now the question is, how do you get around this? I probably have to add an option, so I'll go to neon.tech and quickly add an option for this specific problem. The way to do that is go to your table SQL editor, select star from option. Let's see what that looks like. No, it won't. Oh, thank God. Select star from option. That's better. I have a bunch of options. I need one for task ID 16, so I can just do insert into options values. Eesh, I totally forgot. Image underscore URL equal to, really bad at SQL, so I'll probably have to fix this. Task ID 16, image URL can be something. Oh, it needs to be something proper. Cloud front, cat image, copy image address, paste it here. Copy image address, that looks better. So I need to fix this SQL query now. Insert SQL query, insert into table name, columns and then values. All right, so columns are these, and then values are, how do you do it? These, and then you do a, all right, let's see if that works. Probably needs to be a single quote. All right, run it. Query complete with no result. That looks right. Sounds right. If I refresh, I see an option now. There we go. So yeah, the problem was I just had a task with no options. I just manually added an option in the database, and now if I click on this, hopefully after this submission succeeds, I see the next task. It says what is the best thumbnail. I click on this. I hopefully see the next task, which is done. Please check back in sometime. There are no pending tasks at the moment. So if I search for this, probably clean this up a bit. Class name equal to h-screen and flex, and just a center and flex dash call. That will make it vertically centrally aligned. The database is like extremely, incredibly slow. I don't know why that is. Oh, seems like if you don't have a pending task, it just fails. No, it doesn't fail. It does fail. It gives you 411 with a message that says no more tasks. So yeah, what we can do is whenever we're doing an axios.next task, we can put it inside a try catch, and if it ever, or probably do something even better, dot catch e, and I can do a set loading false, and I can do a set current task to be null. Alrighty, now I refresh. I see a vertically aligned thingy. Let's make it centrally aligned as well. How do you do that? Div class name w dash full flex justify center. There we go. And probably should do the same thing here. Go. Let's add some more tasks, shall we? Let's start the user frontend. Let's add another task here, which is select the best thumbnail. Let's select a few images here. That's one. Oh, something happened. Is the backend down? 403. Oh, oopsie daisy. I need to add a token here as well. So go to applications, go to local storage, go to token, and add a token over here that you can get from Postman if you sign in into not the worker but the user. There we go. Copy it, paste it, and now try doing it. Select an image. It's uploading. Select another image. Where did it go? Oh, looks right. Let's get the third one. Maybe go with one more. Alrighty, we have 4 thumbnails. I'm going to submit this task multiple times. I'm just going to click on this button like 20-30 times. Oh, whoopsie daisy. Few errors came, but that's fine. I think I have a few tasks now. /task/18 gives me an error. Why is that? Backend is down. Why is that? Unable to start transactions at given time. We need to fix this, whatever that is. But okay, we have a task 18. Do we have a task 18? We do. Do we have a task 19? We don't. 20? We don't. 14? Probably do. 15? Probably do. don't. 16 was the cat. 17 is this guy right here, and 18. So we got two of them in. Let's see if we can go to this guy and refresh now and see both the tasks. I do see the first task right now in 3, 2, and there we go. Let me vote for this guy right here. And then the next task is the same as this task. So I'm assuming nothing changes. Just to confirm things are working. Oh no, it says pending. How many did I add? Maybe I just added 1. If I refresh this page though, it does say 1 vote over here, which means, as workers vote, the user can see if there's a 1% vote, 4% vote, 3% vote, so on and so forth. One thing that should be done is the workers, let me just add another one. But there's something up with transactions. I feel like transactions are blocking. They're doing something. That's weird. Wait, why was task 19 created when I sent no images? I thought I explicitly added that Zord check. Maybe I forgot to. Refresh. Let's try that one more time. tsc-b node dist/index.js. If I go here and if I click on, if I try to submit it without it, it'll now fail. What I can do is let me change the user for the worker. So I'm going to worker.ts and the hard-coded address that I had. Let me change that a bit. And then let's re-sign in as a new worker. Let's re-sign in as a new worker so that I can, start from the very first thumbnail and go from there. So if I go here, go to localhost 3001 and change the token over here and then refresh, you will notice now pretty much start from the beginning. I'm assuming the first thumbnail I have to vote is one of these 4. I vote for this guy right here. Should probably show some sort of a loader when this happens. Shows me an error. Great. Network. Refresh. No print assignment. Why is that? Sounds weird. It's very, very weird. Oh. Okay, let's see what's up here now. I need to fix this. Under high load? I have no high load. This is seems like there's some sort of a solution. Index.ts. I actually might have to do this in both the places individually. So let's go to worker.ts and paste this right here, right after initializing this guy, and then same thing on user.ts right after client is created. You do this. Alrighty, let's try that one more time. Let's restart the backend. Let's re-sign in as a fresh worker, and the way to do that is if you go to the sign in endpoint in worker.ts, we have a hard-coded wallet address. I should change this to something different, and that should do it. tsc-b to compile it, node disk/index.js to start it. Let me go here and refresh. Oh, I need to take this token and replace it as well. So let me take it, go to application tab, token, replace, refresh. Alright, I should also render the ID, I guess. That will help. So let me go to next task.tss, can add a few things. Number 1, along with the title, let's just render the current task.id. And secondly, it should be 1 hopefully, or not 1, 6, 7, something like that. We deleted a few entries. Yeah, there you go. So 14. Why is that 14? If I refresh, what comes? 14. It remains 14. Alright. If I go to what else did I want to do? I want to add a loader. So when the user submits a task, they can probably do something like this: submitting, set submitting equal to use state false. And then whenever the user submits a specific task, you can be like, hey, that task is being submitted, so set submitting true and then make it false later on as well. Probably should have a bunch of try catches here if I'm being honest, else it'll stuck. It'll remain stuck in submitting. If an error comes, you should do something like this. All right, that looks right. I don't see any flaw here. And now you should, show the user submitting and submitting. All right, refresh. Click on it and it says submitting. And once, oh, the fuck, why does it still say submitting? Set submitting, oh, false. Great, refresh. Task number 15, I click here, it's submitting task number 15. 16, I click here, it's submitting task number 16. I think 17 is the, 17, 18, task number 18, I think that's the last one. 19 had no title and no options, unfortunately, so it'll remain stuck here. I pretty much have to do the same thing as I did a while back. 19, run, add the cat image, refresh here, see the cat. 19 is submitting. You're good to go. Please check back in some time. If this guy adds more tasks, new task, and adds, let's say, a single image here and submits the task once, it gives an error. Why does it give? Oh, because I was sending an empty image, I'm assuming. Now if I do it, still says the same thing. You send the wrong inputs. Yes, I had added a restriction on the backend that there need to be at least 2 thumbnails, which is why it's throwing an error as it should. Now that I have 2 images in 3, 2, everything is so slow. Okay, now I have 2 images. Now let me try to submit a task once. Probably happened. Oh, okay, it did. And now if I refresh, I see the second task. Let me select the first one. It says submitted. If I go back here and refresh, I see in my results that it's one over here. The other thing, that will be good over here would be select star from worker. You will notice that workers have started to make money because, as you saw, a few workers have been doing some work. The one with ID 1 has logged amount. Probably did a simulated payout here, which is why. But yeah, each one of them has some pending amount, which means workers are being paid correctly. They're able to label tasks correctly. If they just come to the website and eventually sign in, they'll see all their tasks here. And then people who want to get tasks done can track their tasks over here, all the existing tasks that they've created, for example, 10. And they can also, of course, create a fresh task. The only restriction is they need to post at least 2 images in there. For example, 1 and looks decent, 2. Of course, ideally, this should probably be picked up from CSV files. No one's coming here and putting data like this. Also, you see a bug here. All right, refresh. And let's say I select the data structures and algorithms image. And if I go back here, refresh, I see 1 over here. Here, it isn't real time. Yeah, it doesn't have to be real time. You can always poll from this front end and keep updating the counts. That logic should be fairly easy to add. Just go to task / this thing, and wherever we have the use effect, just put it inside a set interval. Set interval every 5 seconds. Get the task details. Something like this. Ideally, you should do something better. Only when the first thing succeeds, then you should have a timeout of 5 seconds and then recall it. But this is fine as well. Now, if I create a new task, test. Let's say I create a new task. What's the best thumbnail here? And click on submit. Now, if I submit and get redirected, this page, the admin page, will constantly keep polling this guy right here, the backend. And so these values will automatically update. If I go here as one of the workers and, try to vote for this guy right here, After I voted, if I go back here, you will see one automatically appears. I did not have to refresh because we're constantly polling the backend. One thing I missed is I should also call this explicitly once, and only then, should have the set interval. Otherwise, the very first time you come here, only after 5 seconds will it poll. So you should call it once, and then you should again call it every 5 seconds. Ideally, what you should do is something like excuse me, something like this: let timeout equal to null, and then return clear timeout null, and have a set timeout here, which basically calls the same thing. The reason this is better is because what if the request itself takes more than 10 seconds? Then you're restarting 2 requests when the first one hasn't even succeeded. So set intervals are bad for that reason. You should do a timeout after the thing has succeeded. If this takes 10 seconds to succeed, that's fine. Once this does succeed, start the next clock for the next poll. Don't start an interval, because if the backend is slow, you're just pumping the backend with a lot of requests when the backend is not responding back in 5, 10, 15 seconds. Cool. Yeah, that's pretty decent, I think. Of course, you should fix the front end. And add bulk uploads, things like these. But let's get into the juicy bits. We have a connect wallet button here. We have not done any crypto stuff. I think we've done all the Web2 bits now. We have a decently looking front end, back end. Let me push it to GitHub as well, and have the current checkpoint on a commit. Next up, we'll let the user sign in and link their wallet. The thing that's a pretty independent thing compared to this application. If you're building any decentralized app, this is how you would sign people in. This is how you would ask them to pay some money. This is how you would verify the signature and the messages on the backend. This is how you would store private key. You never store private keys on the server, but we will be doing it. So I'll show how you can do that and execute payouts. How to create an RPC server, let the user request some payouts every few minutes, and then finally write the worker that polls the database and marks the entries as succeeded. Yeah, this is straightforward. Alrighty, let's get into the Web3 bits next. Alrighty, let's get into the Web3 bits. If you ever want to build a DApp, which stands for a decentralized application, if you ever want, you don't let users sign in via Google or Facebook, but sign in via these wallets. A good example of such a website would be Tensor, which is a NFT marketplace, OpenSea, which is an NFT marketplace on Ethereum. This has Solana as well, but no one uses Solana on OpenSea. Tensor is primarily Solana only, which means any Solana wallet, for example, Phantom it's a multi-chain wallet, but primarily Solana, same for Backpack. As long as you have this, as long as you have some funds in here, you can buy NFTs, sell NFTs. Our use case is the same. Okay, you need to have some funds in your wallet. For example, if I open my wallet here, I have some money here. If I want to transact, if I want to delegate this task, I will have to pay some amount from whatever money that I have. Let me pick a slightly less anxiety inducing wallet here. There you go. This wallet of mine has $195 or $200 in it. I have my money somewhere. It's not in a bank. It's not in HDFC Bank. It's in a wallet. Harkirat, how do you create a wallet? How do you put money here? I will explain very soon. But once you do have a wallet, and in case you do have some money in it, you can come to this website and start to submit tasks. And on the other side, for the workers, you don't need any money. You just need an empty, fresh Phantom wallet. And as long as you're able to do all the tasks that are being given to you, you can eventually pull out money. If you're a worker and if you're on this specific site, here also we would ask users to connect their wallet and then get their address and pay them money directly. In either of these cases, you need a wallet. What is a wallet? It's primarily a way for you to store your private key. Now the question is, what is your private key? So let me give a very simple Web3 101. If you already know this, feel free to skip. But in the standard Web2 world until today, where do you store your money? You store it in, oopsie daisy. You store it in HDFC Bank, right? Or whatever bank you might be using, which basically means your money is nothing but a number in the HDFC Bank, let's say Postgres DB. If they tell you, Harkirat, you own 500 rupees, it's just a number sitting in that specific database. And of course, you can always visit the branch and they will pay you 500 rupees cash. You sort of have that kind of an agreement with them. If they do something shady, government kicks in and government will help you bail out. But that's a brief of about how banks work. You already know this. How does the Web3 world work? The whole point of Web3, the whole point of this, and money being here, is that you don't need any banks. There is a global currency. Doesn't matter which country you are in. Doesn't matter, if your country has bank account or not. Doesn't matter if you have a government or not. We will let you store money as well, and we will let you transact using money as well. You might ask, Harkirat, where is this money stored? What even is this money? And that is a beautiful question to ask. Harkirat, how can you say $196 are here? Which bank account has this? Which person has this? How can I convert it into cash is the most common question. And the answer is, just like any other asset, for example, gold. If you have gold, how do you convert it into money? Someone else is hopefully willing to pay you something, right? If you have 10 grams of gold, hopefully if you go out in the market and say, hey, I have 10 grams of gold, does someone want it? Someone might pay you whatever the current gold price is, which I think is rupees close to 80,000 right now. So if you look at my wallet over here, it says that you have 1.27 Solana, which equates to around $196. This amount is calculated purely based on currently there are people out there who are willing to pay $196 for this much Solana. Why, Harkirat? Well, why does anyone pay for gold? People think it has utility. What is gold's utility? No one knows. People wear it to show off, and it's considered a good store of value. Other than that, if everyone today says, bro, gold is invaluable, the price of gold will go down. It hasn't happened historically, but could. Same is true for Solana. Same is true for any other coin that you see over here. If you look at Bitcoin, Ethereum, if ignore Tether for now, BNB, Solana, ignore USDC for now. All of these coins have a certain price. For example, 63,000. Whoever has one BTC, currently there are people out there in the world willing to pay 63,000 in lieu of one BTC. Why are people doing it, Harkirat? God knows. Why are people buying gold? God knows. But currently there is enough liquidity in the market. There are enough people. If you want to sell 10 Bitcoin, you can get back $63,000. But this price fluctuates. This fluctuates very heavily. If you look at Solana price in the last 1 year, it was as low as $17 at some point, went to as high as $200. Now is back down to $150. So the problem is this goes up and down a lot. It's not the best measure of a currency, which is why there are two tokens currently. Well, there are multiple, but the biggest ones, USDT and USDC, that are pegged to the dollars. What does pegging to the dollar mean? It means if I have 100 USDT, someone out there almost always will give me 100 USD in lieu of USDC. It's called a stable coin. What is it called? A stable coin. The name itself says, this coin will remain stable no matter what. Harkirat, how does a coin remain stable? You said everything is supply demand. The price of Solana is purely supply demand. How many people are willing to buy and sell right now? Same for gold. But how does this stable coin remain pegged? And the answer is, some really smart people said, we need a coin that needs to be pegged to the dollars. So they said, we have bank accounts. We have multiple bank accounts. There is an organization, let's say, called Circle, which is the issuer of USDC. They said, we have opened multiple bank accounts. We have multiple gold treasuries. We have other places where we have bought assets. And we are the ones who issue the USDT token. I repeat, USDC says, we have, if anyone wants USDC, if anyone wants this specific token, let's say I want to get USDC in my wallet. Right now my wallet has just Solana. But if I want USDC, I can either swap. I can be like, hey, I just want to convert 0.1 Solana into USDC. If I click on swap, you will see my 0.1 Solana got converted to $15. This is me doing a swap with someone else who had USDC. But initially, no one in the world had USDC. The Circle organization said, whoever wants USDC, first wire transfer us $100,000. If you give us $100,000, we will mint 100,000 USDC to you. And in the future, you do whatever you want with it. You swap it, you give it to other people, give it to your friend. But there is a contract, whenever people come back and give me, let's say 100,000 USDC, I will return them USD. They have all your money, all your tokens backed by something, and most of the times by real US dollars. That is what makes USDT stable. If a lot of people begin to buy USD, if let's say, I place a very big order here. Let me show you a small thing. If I go to a swap and I say, I want to convert 5 Solana into USDC, or even better, I say I want to convert 500,000 USDT into 50,000 USDC. What am I saying? Here I have 50,000 of one stable coin. I want the other stable coin. Technically, what should happen? If I am giving 50,000, I should get back to 50,000. I clearly said over here that both of them are pegged to the dollars, which means this currency and this currency should be swappable, right? If I give 100 USDT, I should get 100 USDC. If I give 100 USDC, I should get 100 USD. But if I make a very big order, $500,000, how much USDC do I get? I get slightly lesser, $120 lesser. If I make an order of $5 million, what happens? I get $300 of an impact. If I place an order of $50 million, I get 2.5 million USDC only. So Harkirat, you lied. You said this is also pegged to dollars, this is also pegged to dollars. But I can clearly see at some point, if you want to sell a lot of USDT, you only get very little USDC. The answer is yes, but that is because I'm swapping here. If I give this $50 million directly to the Circle organization, they will return me my 50,000 USD. However, if I'm stupid enough to place an order here and convert my $50 million into 26 million USDC, then the price of USDC will crash. In fact, you can go here and you will see for a brief moment the price of USDC crash. It has never happened unless you were alive here on March when it did happen for a while because of some reasons, but it hasn't happened for a while. It remains very closely pegged to dollar. If a whale comes and places this order, then technically if you look at it, USDC is not worth $1, it's worth 0.5 cents, because if you try to convert one USDT into one USDC, you just got half the price. So you will see this tank a bit, but you will see it go back up. Why? Because arbiters will come. Arbiters will be like, "Arey, itna sasta mil raha hai. I am getting a USDC only for 0.5 cents. I will buy a lot of it and then I will go to Circle, give it to them and get back my USD." That is what arbiters do to stabilize the price of a stable coin. Why does a stable coin remain stable? Because there are people out there that say whenever the price is going up by a bit or down by a bit, right, I will directly go to Circle and give them some USDC, take US dollars from them and stabilize. I'll close the loop. If you understand how you close the loop in arbitering, if you don't, then it's fine as well. Just wanted to share, this is sort of real money. Why I say this is sort of real money? Because if I own 15 USDC right now, if you look at my wallet, ignore Solana, but I own 15 USDC, you can almost say I have 15 US dollars sitting in some bank in the US that are on my name, because USDC has said if you ever return us USDC, we will return you the US dollars. We follow that contract. So you can sort of say I'm holding 15 USDC. Why do I say sort of? Because what if the government wants to ban this bank account? Government says USDC is illegal. We are going to kill this bank account. And then the whole math goes away. Even Circle doesn't have the dollars. Government took it from them, and hence this money will not make any sense. Circle will no longer be able to abide by the commitment that they made. This is why this crash happened, because there was a bank in the US that failed called Silicon Valley Bank around March of 2023. I was in the US. I remember this vividly. And a lot of my friends had their money in Silicon Valley Bank, especially people who have raised in the US. Silicon Valley Bank is the primary bank where you keep your investments. My closest friend had like 5 to 10 CR, something like that there. And even he lost. He would have lost. In the end, the government came in and bailed everyone out. But if they wouldn't have, even USDC had some money in there, and hence there was a lot of fear in the market. Everyone started selling, and the price went down to 0.85-ish for a while. Eventually stabilized because number one, the government stepped in. They got back access to this bank where they had a decent chunk of their money, and arbiters came in, closed the loop, and eventually the price went up. That's a brief of why this is real money. Is this really real money? Hard to say. Unless people start really transacting in Sol or really transacting in USDC, this isn't real money. Currently, primarily people transact in INR. If you go to a shop, the prices are in INR. So unless that gets replaced by this won't happen. But thankfully, people today understand that this is not very stable, but stable enough. USDC has been stable historically for a really long time, for years now. So people are okay accepting payments in USDC, which is why for a use case like ours, where we have a website where someone can come and pay, and you have to do a lot of micro payments, this works. As long as the workers on the other side are okay getting USDC, this model will work. If they are not, then of course you will have to off-ramp their money, which is also not too difficult. A lot of companies in India give you APIs where you can, take some US dollars and convert it into INR and directly dispense. But we're going to stick to being a Web3 application. Okay, that's a brief. Now the question is, if you have a wallet, firstly, how do you get a wallet? And the answer is you simply go to backpack.app or you go to phantom.app, I think. And just click on download here. Most wallets are extensions. So if you click on download over here, click on Google Chrome, it will take you to an extensions page like this. Why are they extensions? Because extensions get a lot of access on websites. For example, if you go to this website, this website can ask the wallet for some money, which is why most wallets, one of the most common use case is for wallets to be an extension. So if you go to wallet Phantom over here and install it, it will take you through a few steps and ask you to store your private key somewhere. You should do it. By the end of it, you will have an empty wallet, which means it will have no money. It will be similar to this thing right here. It will say $0 over here. It will say 0 Solana. So throughout this application, you will not be able to test anything unless you move to DevNet. So DevNet is like a test network of Solana. So if you click on active networks, no. If you click on preferences, no. If you click on security and privacy, no. Developer settings, testnet mode, Solana DevNet. If you select Solana DevNet over here, now if I go back, it says you are currently in testnet mode, and you can actually put some test Solana in here by going to Solana airdrop. By going to a faucet like this. Just search for Solana faucet. A lot of times it's really hard to get DevNet Sol, but let's see. Let me copy my address. Let me paste it here. Let me select DevNet. Oh, that's the amount. Sorry. 1 Sol. And it makes you connect your GitHub to unlock a high limit, which we don't need. But why is this? Maximum of 2 requests per second. Confirm airdrop. It's disabled, most probably because there is no DevNet Sol. It's very hard to get DevNet Sol, but let's try out DevNet. Successful transaction. Let's see if that worked. No, it did work. Oh, pretty cool. If I go to my Phantom now, you will see I have 1 Sol over here. This is not real money. This is not real Solana. This is just testnet Solana that you can use to test it out. So what do you have to do? Go to solfaucet.com. Number 1, change your wallet from here to be settings, security and privacy. No, sorry. Account networks. No. Developer settings, and then turn on testnet mode, and on Solana, select Solana DevNet. That's step 1. Now you're connected to the Solana DevNet environment. Number 2, when you're here on solfaucet.com, just paste your wallet address, which you can get from here, copy it, paste it, and click on DevNet. It will send you DevNet Sol. All right, cool. So if you want to do that, if you want to do it with real money, then there are ways to send real money here. Just go to an exchange, buy some Solana, and then send it over here. I'm going to revert back to the main network, but yeah, feel free to pick and choose which one you'd like to do. Alrighty, let me go back to if this wallet looks good. Now that I have this wallet, let me see if there's one which has less money that I can share my private key of. This is fine. So now that I have this wallet, the question comes, Harkirat, given you have this wallet, what apps do you use? And I said, Tensor is one such app. What does Tensor let you do? It lets you buy NFTs. For example, if I go here, it says, hey, if you want to buy this NFT, click on the buy button. If I click on the buy button, it makes me connect my wallet. Okay, hey, which wallet do you want to connect to? You have 2 wallets. I say I want to connect to my Phantom. When I click on connect, Phantom asks me, are you sure you want to connect to this website? I say yes. And then if I click on this button, buy, it says insufficient balance. Oopsie daisy. I need a cheaper NFT. There you go. Open Sol Maps. So if I click on buy over here, you will see a transaction gets prepared, and then this pop-up comes up and it says, are you willing to pay this much Solana for one Sol map? If I click on confirm, I'll be able to buy this specific NFT. Let's say I did that. It says the transaction is sending, and once that succeeds, you will see I have a new NFT over here called Solana Maps or whatever I bought. It'll come in a while. If you look at the last transaction, there's a pending app transaction right now. It'll eventually succeed. What does this tell you? It tells you I own money in a decentralized fashion. I did not need to have an HDFC bank. I did not need to pay via Razorpay. I could directly pay from this wallet. That's exactly what we need to do here now. We need to pop the wallet up. We need to make the user connect a wallet, pop up a transaction to pay $50, make them click on submit, and then, make them submit a task, and then finally pay out the other side. Let's get into how you do that. Alrighty. So there are a lot of wallets out in the world. Phantom Backpack are just two. There are like multiple Solana wallets, and most blockchains you'll find something called as the wallet adapter, which, as the name suggests, is basically an adapter that lets you connect to any of these wallets. There is one on Ethereum. I forgot the name totally forgot. But there is one on Solana called the Solana Web3 adapter. No, it's wallet adapter. Sorry. Solana wallet adapter. There we go. And if you look at this specifically, if you look at the demo of this, you will notice it pretty much lets you do the same thing. It lets you select a wallet, click on a wallet, connect to it, and then do a bunch of things on it. Sign a transaction. What is a transaction? We'll come to sign a message, send some Solana on DevNet, request some airdrop, so on and so forth. So this probably, they've already written all the code to connect to wallets and, request transactions. You can simply use this adapter on your website and, basically use all the hard work of these people to bring a wallet adapter to your website. Are there downsides to this? Not really. I mean, this has been well audited, I would assume. Most websites that you go out and look at will use, the wallet adapter. Unless it's a very big website, they'll probably create it in-house. But most standard projects will just get off the ground by using this wallet adapter. So we need to now use this package and, bring it into our Nextjs application, both the user application as well as the other client application. Let's kick things off with this one. There are thankfully good docs here. Maybe not actually, I'm speaking a little too soon. TypeScript docs. It's been a while since I've used this. I also know this has some troubles with Nextjs. So we will see if this, is an easy road or not. But there we go. These are the dependencies that you have to add. All of these are most probably, from this wallet adapter. Solana/Web3.js is a different library that is used not just on the front end, but on the back end. But everything else that you see here are pure front end libraries, I would assume. If I copy this, I don't need React, but everything else, let me bring into my project. Let's kick things off with the user app. npm install all these dependencies. Oopsie daisy. There we go. And while this installs, let's look at the next steps. It says setup over here, which tells you to import a bunch of things, import a bunch of styles, and then wrap your main application inside all of these providers. If you've gone through the context API, if you've used recoil, if you've used any other way to, pass variables from top to bottom using context, this might sound straightforward. If not, a lot of times when you bring external libraries, for example, Material UI or a library like this, you need to wrap your application around a bunch of providers. What does wrapping mean? Basically, if this is your main application or your, final component, wrap it around these three sort of components that come from this library. So that's the next step for us. This is much easy to do in React. This is slightly harder to do in Nextjs, but I'll explain how to do it. First of all, let's copy this. You might have heard of this file called layout.tsx, or maybe not, but Nextjs gives you this layout.jsx file, which says, every page that you have. For example, I might have, this landing page over here at page.tsx that renders our app bar, hero, and upload section. And then I have a task/task ID page. You can wrap all of these inside this layout.tsx. If I put hi over here, then, let me do a yarn dev as soon as this succeeds. Then this hi will appear on every page because I've wrapped my complete application in this HTML tag followed by hi, followed by a body tag, and then the real application renders. So, this is a way to wrap the whole thing inside certain code in case you want to. In our case, we do want that, and hence this is where we'll be, wrapping all of these components, but we'll get there when we get there. Let's wait for this specific thing to install and then we'll go from there. Actually, I can just do it. Oh, there you go. Succeeded. Now let me do a yarn dev again. If I go to localhost 3000 now, you will see you don't see a hi. There we go. We see a hi. Let's put this right next to children or before children over here. And you will see your application. This is your main application. This is where your actual page renders. But before that happens, we render hi over here. I can also put, hello afterwards. So that basically means this is my main application. Hi should render before it. Hello should render afterwards. What do we want over here? We want a bunch of Solana providers, specifically Solana wallet providers to be technically correct. So basically means all of these providers, which, provide you the Solana connection, not collection, a bunch of other things. God knows I've not gone through any one of these. I can just wrap my application or specifically children around this and we're good to go. I need to, of course, import all of these things from here. Import all the styles and the things that you need. Const network equal to, so this is where if you're using devnet, make sure you have devnet here. Since I'm using mainnet, I will have mainnet over here. But if you are using devnet, make sure you still have devnet over here. Get an endpoint, get wallets. This sounds a little fishy, but let's see. Let's paste this here. Const wallets equal to use unsafe burner wallet adapter. What is this? Wallets that implement either of these standards will be available automatically. Okay, so let's remove this. So most good wallets follow like some standards, which means this library will be automatically able to detect them. We also added explicitly an extra one, which is, as the name suggests, an unsafe burner wallet. Let's not have that. Let's just not have any unsafe burner wallets. What does an unsafe burner wallet mean? Most probably it means it will store your private key in local storage somewhere. You don't want that. So you want the user to choose from one of these wallets, and thankfully both Phantom and Backpack follow these standards. So this library will be able to automatically detect them. We have this thing, we have the children. Alrighty, that should be it. The two things that they had over here were this wallet multi-select and then wallet disconnect button. Let me paste them, but I'll share what these are very soon. One more thing we might have to do is make this a client component, because all of this is, most probably going to be client side logic. So most probably we have to make this client. I don't know if you can do that in the root level layout.tsx. So we will see. Probably cannot do that. Yeah. So let's see. Does this work? It doesn't work. So we have to do something fancy now. Yeah, this would have been easier if we were in React, but since we're not, we cannot make this root layout a client component. So we'll actually have to create another layout over here. Let's call it root/layout.tsx and just paste all of this logic here. I'm going to revert the root layout.tsx, and I've added all the logic that we had over here. Let me just revert this completely. Let me get my food. Alrighty. What I did is, number one, I reverted the root level layout.tsx because you can't just convert it into a client component. What is a client component? Nextjs has two sides, server and client. When you do a bunch of things that are supposed to be on the client, for example, wallet stuff, you need to mark it as a client component by writing use client on top. Unfortunately, the root layout cannot be a client component, and hence what I've done is I've created this sub folder. The name can be anything here, doesn't matter. But the point is, whenever you want, a sub layout for a bunch of pages, you can do this. If you ever add, round braces and add a name inside, and if you move all your pages in there, for example, if I move the root level page.tsx here, as well as the task component that we had in here, what would happen is still on the landing page, this thing would refer, render. Still on the /task/task ID page, this thing would render, but I can have another sub layout for both of these pages where I'll do all this connection logic stuff. So let me remove all of this. Let me just stick to the Solana logic over here. And yeah, that's it. Hopefully remove all the unneeded imports and make this the client component. I think this should be good enough for us to bring a Solana wallet adapter into our code base. Let's see. Oh, let's remove that. Let's go to the root folder. And now you will see, I see, something over here. I see a select wallet button. I also see a disconnect wallet button, which if you scroll down a bit, if you remember, along with wrapping my children in a bunch of components, I also added 2 components over here, the connect component, or connect button component and the disconnect button component, which is why you see them here. Let me remove them for now. This much is good enough for you to now add any Solana wallet adapter logic in your code base. For us, most websites, you'll see a connect wallet button over here. So wherever I have appbar.tsx is where, number 1, I should convert it into a client component. And number 2, I should have this wallet MUI button. Oh wait, which appbar is this? User frontend, right? There we go. And as you can see, you can select wallet and disconnect wallet. I should conditionally render select wallet or disconnect wallet based on whether or not the wallet is connected. Right now it isn't, so I should see just the select wallet button. You can do that by doing this const public key equal to use wallet. Pretty sure there's a use wallet hook somewhere. There we go. And if the public key does exist, which means the wallet is connected, then you should render a disconnect button, and vice versa. If it doesn't exist, then you should connect or render the wallet connect button. If I now look at the app bar, it says select wallet over here. If I click on select wallet and select phantom and connect, it says disconnect over here. The other button now renders. If I disconnect from it, similar to me logging out. We've added a login logout functionality. Might not seem that we have without any Google, Facebook, email, password, but that's how login, logout, at least on the client, works in most dApps. That's what happens in Tensor as well, right? If I go to Tensor, I disconnect, click on connect wallet, and click on any wallet that you have, and you're sort of signed in. There is another thing here called authenticate, which is the next thing we have to do. This authentication means letting a backend know that I am Harkirat. Right now, with the code that we've written, or even on this website, this is just the front end knowing that this is Harkirat. We haven't yet proved it to a backend, which is the next thing we need to do. That is how the user will sign in, right? When the user comes here and selects a wallet, we need to send a sign-in request. We need to get back the Web2 token that we had created, and then let the user transact. So for that reason, the next step you have to do is similar to what Tensor does over here. If you look at the Tensor website, what did the authenticate button let you do? It said sign a message or verify wallet. When you would click on verify wallet, it would make you sign a message that looks something like this: authenticate wallet by signing below some big string. It makes you sign. And if you click on confirm, is when this doesn't charge you at all. You can do this with $0 as well. And if you click on confirm, it'll pretty much authenticate. This is, you actually own this. A backend, it does know this. So that's the same thing we have to do. We have to prove to our backend that we own a specific wallet, and whoever is the user that comes to our website, they need to do the same thing. So after the user connects, we need to basically pop them up for an approval. So anytime the public key changes, we need to make them sign a message that we send to our backend and sign the user in. What would this message be? It can be anything. It can be as simple as sign into Mechanical Turks, but usually it is a combination of something related to your website, which signing to Mechanical Turks sounds pretty good, and the current time, which could be, or the current date, which is, for example, today's 10th May 2023, so that this message was signed recently. And you don't want the person goes to a different website, signs in, and that website's developer logs in as that user in this website. Nahi samajh aaya na? Said a lot of things here. Basically, don't make this message be very generic. Have some flavor of your website in here, and preferably have the current time here as well, so that this was recently signed and this message was signed on your website only. Of course, no other website will make a user sign a message that says sign into Mechanical Turks, and hence this message should be somewhat unique and have a timestamp. We will not complicate things little right now, so we'll just do something simple. But ideally, you can get very complicated in what you make the user sign. We're going to keep it simple. All right, what does signing mean is a good question at this point. And think of this as signing a check. If you ever want if you are a bank and you want someone to prove that they own a specific bank account, what do you tell them? You give them a checkbook and you say, hey, just tell me how much money should I transfer, and please sign this specific check. And whenever this signature comes, the bank can verify that this is indeed Harkirat, and they can, debit your account. Similarly, the signing over here is actually significantly different. You need to do a cryptography 101 to understand public keys, private keys, and how you can, sign this message to convert it into some gibberish and send this over to a backend, which can, take this gibberish, add your public key on top of it to convert it back into sign into Mechanical Turks. This isn't exactly what happens. You just verify that this transition indeed happened using this public key, but let's not go there. To verify, you need to make the user sign using their private key this message. You need to tell them, you are saying you own this wallet, right? You are saying you own the wallet with public key 43NA, some very big number, and then 3B4N. You are saying you own this wallet. Prove it to me by signing this message. Sign this using your private key. What is your private key? If I want, I can go to, settings over here, security and privacy, click on manage accounts, go to an account, and then click on show private key. If you click on show private key, and if I actually put my password here, it'll show me a very long string. That string is like your password. If you give it to someone, all your money is gone. They can pull your money out basically. That is the private key that you sign your message with. The website can ask you, hey, can you please sign using your private key? And if you do sign, then the whatever string that is generated from you signing it can eventually be verified by a backend. This was indeed signed by this person, 43NA, and hence you can prove to a backend that you actually own this specific wallet. So if you ever want to tell your friend, or if there's ever a whale who has, $100 million, and anyone can be like, oh, I own this. There is no way to prove someone owns a wallet unless, of course, they share their private key, which no one will. And hence the best way to prove that you own a specific wallet is make the user sign a transaction or make the user sign a message. Why do you make them sign a message? Because signing a message is free, and they don't have to pay any gas for it. The message contents could be anything. In our case, it's going to be sign into Mechanical Turks. If the user does sign this using their private key and spits out some gibberish, this gibberish goes to our backend server, and the backend can be like, acha, if this gibberish and this public key, whatever the user has currently, the user will also send the public key to the backend. If you join these two, yes, it does make sense. I can verify, in sign into Mechanical Turks was indeed signed by the private key of this public key. And hence you can prove that you own a private key without sharing the private key with anyone else. Common practice to, verify yourself with the backend. Question is, how do you make the user sign a message? And the answer is, the wallet adapter, I'm sure, gives you some function. Send transaction, let's see. There we go. Const sign message equal to use wallet. And how do you call it? Simply const signature equal to signature message. There you go. This is how you verify it, by the way. We're just verifying. This is just being verified on the client, but you can use this similar verification on the server as well. What's the error here? Oh, let's just log the signature for now before we actually send it to a backend. But as you can see here in the code, after you make someone sign, you can actually use this library called ed25519 and simply call a function on it. Okay, verify, was this signature on this message made by this public key? And if that is indeed the case, you know that this signature was actually signed by this public key. And if this function fails basically, or returns a false, then you know there is some error. The user doesn't actually own the wallet. So this is how you make the user sign a message. This is how you verify this public key. When the user signed the message, they sign it using their private key. But while verifying, you just need their public key, the raw message that you made them sign, as well as the signature. You don't need their private key to verify. So someone was able to prove to you that they own the wallet without actually sharing their private key with you. String is not, you need to convert it to uint array. Okay, so basically you need to do this. Alrighty, signature. Let's see what that does. Let's go to localhost :3000, and as you can see, as soon as I reach, since I'm already connected, a pop-up comes up and it says, signing this message will prove you have ownership of the selected account. Sign this message, sign into Mechanical Turks. The Phantom wallet itself is telling you, okay, hey, if you do sign this message, you can prove to other people that you indeed own this wallet. And what is the message we're making the user sign? Sign into Mechanical Turks. If you remember, when I was on Tensor as well, if I go to tensor.trade, here also, when I clicked on authenticate, it made me, I already am authenticated here, but if I change the wallet, it made me sign a similar message. That's exactly what our website does as well. If I now click on confirm, and let's look at the logs, you see a uint8 array. It's basically an array of 8-bit integers that gets logged, which is something now you can send to a backend and verify. So let's take this uint8 array and send it to a backend and basically the sign-in endpoint, and then also implement verification on the backend. So if you remember, what did our sign-in endpoint look like? It looked something like this: axios.post backend URL /v1/user/sign in or sign in. That looks right. And what was the arguments that we used to send? Right now we sent nothing, but now we will be sending this signature along. All right. This is how we've changed the front end. This will return you a JWT const response equal to await this thing. Local storage dot set item token response dot data dot let's see, token. There you go. So that's how you actually make the user login, and not using a fake way how we did. Okay, we went to Postman and copied this thing and pasted it on local storage. We're not doing that. We're saying whenever the user comes to the website, we make them sign and send a message to the backend. And now the backend, if this does succeed, if the backend is able to verify the signature, then the backend will be like, great, this person indeed owns this wallet, and return a token to the user. If the backend faces any issues, then it will not let the user log in. Let's go back to sign. Where do you want to go? User.ts, and here in our sign-in endpoint, we need to now take. Oh, we also should send the public key over here, by the way. So I'll send the signature as well as the public key, which will be public key.toString. All right. Now the backend will take const public key, comma, you should add Zod validation here. I'm not, but like feel free to. Signature equal to rect.body, and don't need this anymore. This public key is what, you know, gets stored everywhere. And before we do anything, we need to first verify, is this signature correct for this public key? So what was the string that we made the user signed string? Sign, it was sign into Mechanical Turks. So I can paste this over here. I can be like message equal to new text encoded this, convert this into a uint8 array. And now I need to verify, is this signature on this message correct for this public key? For that, there are a few crypto libraries. Verify sig message on server Solana. Let's see, there you go. How to sign and verify a message. That's exactly what we need. Yeah, tween NACL is probably the library you want to use here. So go to the backend. npm I tweet NACL, sorry. This library gives you a bunch of crypto functions, which is exactly what we need right now, to verify whether or not this signature, for example, it lets you sign messages as well. If you have, you know, a wallet that's on the server, this is just one way to store a wallet. You can also store a wallet on a server. In fact, you can export this private key in this format of, you know, a uint8 array, a bunch of numbers basically. And on the server itself, sign a message and also decode a message. This is how you sign a message using NACL. We did not sign it using NACL. How did we sign it? We signed it using the Phantom wallet. How do we verify it? You can use the NACL library, which is what we're going to do over here. So if I go to the top of this file, I can import NACL from tweet NACL, and then I can verify like this. There you go. Const result equal to NACL.sign and verify message bytes, which is nothing but this thing, signature, which is something that came from the front end, and public key dot 2 bytes. There you go. Is that right? That's not right. It'll probably be something like this. New public key or 2 bytes, where we need to include another library on our backend called at Solana/Web3.js. This will be the most popular library you will use throughout. So you like get comfortable with it as early as possible. And the public key that the user sends us is, you know, in the string format. We need to convert it to bytes. So you can just use new public key, pass in the public key in string, and then .2 bytes. And this public key comes from at Solana/Web3.js. Alrighty. Feel like I'm moving a little fast in explanation. So let me know in the comments if that is the case. But there's like a lot to cover in less than an hour before I have to release the video. So, you know, sped up a bit. Result, and then, you know, yeah, let's just log the result for now. Result. Let's see what happens when we log the result. If it's true, if it's something else, actually, I don't even know what it returns. So let's start the backend, or tsc-b node this/index.js. Let's go to Google Chrome. Let's go to localhost : 3001, and oh, sorry. Let's start the user frontend again. Yarn dev, probably run on 3000. How is this running on 3000 when the backend is also running on 3000? Never mind. Confirm, sign the message. Okay, before we sign the message, let me open the network tab so we can actually see the sign-in request go out. And make this slightly smaller. Click on confirm. You will see a sign-in request goes out, but it returns a 401 because /v1/ because, yeah, both of them started on port 3000. Oh, that makes a lot of sense. Can't reach database. Why? The backend didn't start, which is why the frontend started on 3000. Looks better now. Backend is up, frontend is up, probably on 3002. If I go here, click on select wallet. Since it's a new URL, I need to reconnect my wallet. I connect it, makes me sign a message. I sign it, and this sign request fails because the backend goes down because This is going to be very hard to debug. Cannot read underscore bn of undefined. Most probably the payload isn't right. What am I sending you, sir? Public key and signature. Oh, what is that? Okay. Public key looks right. Console.log public key, console.log signature. Let's copy this request over and bring it to Postman so we don't have to go through, the GUI again and again to test, because this might take a while for us to fix. Import, paste the curl, and then click on send. Breaks the backend. What does the backend say? Node this/index.js. Let's run it. And the backend does render the public key as well and this thing as well. But what does it say? Unexpected type use uint8 array. Most probably this type is incorrect. I need to convert this buffer to a uint8 array, which shouldn't be too difficult as long as you do .data new uint8 array of this. I think they should do it. I of course could be wrong, but we will see. Think signature should be this, which means this is what you should put over here. tsc-b followed by a node this/index.js. If I go to Postman, click on send. Request is taking longer, which is good. True got printed over here, which means things are working correctly. I am able to verify the public key of a user using a message that they have signed. This message should be a little more fancy. You should have a date in there so you know the user isn't reusing the message again and again. But a great start nonetheless. Let me remove this. If you look at it, I get back the token. That's how we verify. We have sign-in logic implemented on one side. Should be fairly easy to implement it on the other side as well. Let's go back to Google Chrome and actually see if it works. Let's make the how do we know if it works? Let me just clear. I guess the best thing I can do is let me clear local storage. Let me just delete this key called token. Now if I refresh, if I reach the website, it makes me sign a message. If I click on confirm and sign the message, I see 2 errors. The backend is down. Signature.data cannot read property of undefined. Signature.data. Let's log signature. tsc-b. I'm running the backend over here. And if I go to the front end, refresh, connect, and then eventually sign the message, the backend dies because it gets undefined and undefined. Why is that? Why am I not sending anything anymore? The answer lies somewhere in app.bar.tsx. Make them sign a message. Signature public key. Feels like it might just be happening twice because of main.tsx. Oh, this isn't React. Never mind. Restart. Refresh. Oh, you refresh and this happens. That makes a lot of sense. If not public key, then return. There we go. Sorry about that. And now if I reconfirm, you will see it works. Reconfirm, it works. If I open, and maybe let's try that one more time with the network tab open. If I go to the network tab now and disconnect, refresh, select wallet, phantom, sign the message, go to the network tab. Oh, what's up here now? Refresh, confirm, sign the message, go to the network tab. The sign in request succeeds, returns me some token. If I go to application/token, it's right here, which basically means we should have a new user with this public ID in public key in our database. So if I go to neon.tech now, click on login, and go to the database, go to the users, select star from user. I should probably hopefully see the user with this public ID, public address. Yeah, 4N starts with 4N, 4N4. Yeah, that looks right. Let me try signing up using a new user. So let me go here. Let me change my wallet address to be something else. Maybe this account 34. Even if it doesn't have money, it's fine. You can still sign a message for free. Connect, sign the message. If I go here now, I hopefully see a third user. There we go. You can pretty much, keep going from here. We have sign in, sign up functionality. If I create a new task now, new task by the wallet, this thing right here, that, adds a few new images, which, believe it or not, we have the images for this video as well ready now, as in the thumbnail for this current video. There are 3 variants. So good way to test what we're doing. I'll show you very soon. They're in WhatsApp. There you go. Added 2 of them. I click on submit tasks, and now, as you can see, the task happened. We need to make this a little less intrusive. Every time it renders, this message pops up. We should fix that. Should be fairly easy to fix. But yeah, that's how you, new task by wallet, this thing. And if I go to the task, I'll probably see that the task is for the user with ID 3. The most recent task is for the user with ID 3, which means, fairly dynamic stuff we have. Let's go to the Notion doc and see what's next, but this should be straightforward. From here, let the user sign in, make the user pay $50 is next. That's probably the only difficult thing. Verifying the transaction signature on the backend is probably another thing we should do. Storing the private key on the server this is for dispensing the money out eventually. Cool. Let's get it into making the user pay $50 and, generating a transaction signature. That's, the other big thing now the user needs to do before they're able to submit a task. We need to make them pay some money. And only if they've paid $50 should they be, or whatever, 0.1 Sol, should they be allowed to enter the website. Let's do that next. Alrighty guys, lesson for you: generally keep your laptop empty. Mine isn't, so I wasn't recording for the past half an hour or so. So I just completed the whole thing now. And now let me share. How can you actually charge the person and verify on the backend that this is indeed a valid transaction that this user has made? I still think there are some problems in this approach, but let me show what I've built, and then I'll share how I've built it, and we'll go through the code. Right now I have 2 wallets. One is the parent wallet that we have discussed, and this is this other user wallet that a user can come to this website and pay for. Whenever this user comes, they can select Phantom wallet in this case, create their task, what is the best thumbnail, and then select a few images. This one, and then maybe one more. Maybe the same one is fine. And now before they can actually send us anything, they first need to pay 0.1 Sol, which let's say is the amount that we charge currently. The user needs to click on this button. They'll be popped up a transaction by Phantom. Of course, the website cannot take money from your wallet. There needs to be an approval first. That's the whole goal of a wallet. So I can see the transaction and be like, okay, 0.1 Sol is going to the parent wallet. That looks legitimate. Let me click on confirm. When you click on confirm, this transaction confirms. This can take a long time. On a bad day, it can take 30 seconds, 40 seconds. Today, it didn't take too long. As you can see, the transaction has succeeded, which is why I can now submit task. I've paid. If I go over here in Phantom and look at all my transactions, my most recent transaction has been I've sent 0.1 Sol somewhere, which means, this transaction did indeed succeed. I can submit this task now. If I click on submit task, this task is going to the backend, and the backend is verifying my signature that I'm also sending to the backend, not a message signature, but a transaction signature. What is a transaction signature? Basically this thing right here. If I click over here and click on view on Sol scan, this very long string that you see over here is the transaction signature for me. Is the signature of my transaction. Okay, hey, this specific user paid 0.1 Sol. That's the best way to look at it. 0.1 Sol was transferred from this user to this user. And this is our parent wallet address. This is the user wallet address. As long as the user sends me this, I can on my backend verify, okay, was this money sent to my wallet? Yes. Was the amount sent 0.1 Sol? Yes. And hence, on the backend, I know that this person has paid legitimately. Let me create a task for them. That's what's currently happening. If you look at the latest task that has been created, you will see this latest task, what is the best thumbnail that we just created, has a real transaction signature in the database stored, and this transaction signature is the same thing that you saw over here, which means, now our backend is doing the right things, verifying the signature, making the user pay before actually creating a task for them. Of course, the other side still needs to be done. We still need to pay out people, but at least, payment from the user is done. Let's see how I did it. There are a few things I had to do. Number one, I had to get an RPC URL. RPC URLs, I discussed a little bit in the beginning of the video, but basically whenever you want to talk to a blockchain, you need a server very close to the blockchain that can directly talk to it. You need a place to send your transaction to. Usually Solana provides some free ones. They're very, clogged during the day. So usually it's a good idea to get your own RPC URL, which is something I did from Alchemy. Just go to Alchemy, sign up, create a new Solana RPC URL on mainnet or devnet in case you're on devnet, and then, copy over this string. If you go to the code, if you remember in the beginning, I shared in our layout.tsx, this endpoint was something else, something like this. This would work as well, but since the mainnet free server is usually very busy, at least it didn't work for me. So I had to replace this URL with my own, rented RPC. Of course, this is free for now, but if I send a lot of requests there, then these guys will begin to charge me. That's how Alchemy makes money. So the first thing you have to do is get an RPC URL and replace it in the root layout.tsx. Second thing you have to do is, actually implement what happens when you click on the 0.1 Sol button. So if you search for pay 0.1 Sol, I've basically conditionally rendered this button. The button, if there is no transaction signature in the state right now, it renders pay 0.1 Sol, else it renders submit task. So, and if there is no transaction signature, then the function that gets called is make payment function. If I go to this function here, you will see, a bunch of things that might be very new to you. This transaction object, this system program object, get latest block hash and context, send transaction and confirm transaction. All of these, most or if not all of them, come from the @solana/web3.js library. Solana is nothing but, it's a blockchain, but it lets you put programs over there. And one of the most core programs is the system program. What is the system program? The program that lets you transfer money from or Sol from one account to another. That is the program that we have to use today. What is the program? Smart contract. But in the future we might create our own smart contracts, in which case we will write something else over here. We will not write system program.transfer, we'll write something else. But since today we have to use the Solana provided core system program, which again is a program, you can read the code of it. And we just want to transfer money from the user's public key over to the parent wallet address. And this is the amount of money that we want to send, 0.1 Sol, which is equivalent to 10⁸ lamports. This is the sort of transaction we create. A single transaction can actually have multiple instructions. We just have a single one right now. But if you want, you can shove multiple instructions in the same transaction and send them to the blockchain together. We just need one to transfer money from A to B. This section right here, the get latest block hash, is a Solana specific thing. Solana is a little different from Ethereum in the sense that in Ethereum, you can send a transaction and it might stay there for an hour, after which it might get confirmed. It has this concept of a mempool where you just submit a transaction and then, eventually at some point someone will pick it up. But here it doesn't happen. Solana has the concept of time baked in. If you want to submit a transaction, it will either succeed, in some block hashes, which usually is basically it will succeed in a minute or two. Else, there is no probability it can never succeed after an hour suddenly. And this block hash is what, which basically means the hash of one of the latest blocks, is what you have to put into your message, and your message gets signed using it. So if the blocks move really ahead, this transaction signature becomes invalid basically. That is why you always, whenever you're submitting a transaction, you have to get the latest block hash and, send that over whenever you're trying to send a transaction or confirm it. This actually sends the transaction to the blockchain, the system transfer transaction, and asks Phantom to pop up and, makes you confirm. If you do confirm, then this signature is created, and then you await the transaction confirmation. Just because the transaction is sent doesn't mean it will actually succeed. So you wait. Okay, has this actually succeeded? There's a high probability it doesn't. If the Solana blockchain is really clogged, it might not, which is why, you wait for this to actually succeed. And if it does, is when you're good to go, is when, the make payment function has succeeded. The user has made the payment. The user hasn't yet hit the backend. The user still needs to tell the backend it has made the payment. If it doesn't do that, then their 0.1 Sol is gone, which is why this is a slightly weird approach. There are better approaches to, make a user pay and let a backend know that they have paid. This is a pretty rudimentary one, if I'm being honest. What does it do? It creates a transaction, lets the user pay. That's exactly what you saw a while back. I came over here, clicked on pay 0.1 Sol. A pop-up came up. I clicked on confirm. Let me refresh and try that one more time. Confirm, sign, and then pay 0.1 Sol. Pop-up came up. If I click on confirm is when, the transaction actually goes to the blockchain and, we wait for the transaction to succeed. When it does is when we set the transaction signature, this state variable over here. When this gets set, then the button body also changes to submit task, which the user needs to click. Only when the user clicks on it is when, the request goes out to the backend on the onSubmit function, where now we're sending not just the options and the title, but also the transaction signature. So this transaction signature also goes to the backend, and the backend needs to verify whatever signature of this transaction was, is this the right? User can send any transaction signature here. You need to verify, has money gone from account 1 to account 2 in this transaction? You need to pretty much hit the blockchain, do something similar to what this website SoulScan is doing, and figure out, is this transaction actually sending money to my wallet? Is it coming from the original user's wallet? And if that is the case, then you can be like, okay, good to go. This user has legitimately paid. So if you look at the code over here, which I suddenly thought of vulnerability in the code, but I'll discuss that towards the end. If you go to user.ts, what have I done? Whenever the user sends a post request to task, before you do anything, I log the signature. I should be using. It should be this. I was just testing with one transaction, but yeah. All right. On the backend, firstly, we create a connection object. The backend also needs to talk to the blockchain to figure out, is this transaction signature? What exactly is happening in this transaction? And hence we need to create a connection object with a similar RPC URL. Const connection equal to new connection, where this comes from Solana/Web3.js with the same RPC URL that I had. You need this RPC URL, only then can your backend actually talk to a server, right? You can use the default one, but it mostly doesn't work on mainnet. You get a transaction. You specifically want the details of the specific transaction. The second thing, feel free to ignore. Even if you don't add it, it'll just tell you this is a depreciated function. So feel free to add it, not add it, doesn't matter. There's something called version transactions on Solana. Feel free to read about it. But if you pass one, you'll be fine. Then we are doing a bunch of ad hoc checks. This is where I feel there are a lot of problems. This is not the right way to check if someone has paid. This is one way to check, and this might work for some legitimate transactions. This might work for some illegitimate transactions as well, which is why this isn't the best way to check. Has someone paid? You should ideally, if you remember, I said there's a systems program. If you remember over here, I said there's a system program, which is, effectively a smart contract, a program on the blockchain. You should read what that program does. You should figure out what are the bytes that go in a transaction, and then, actually parse those bytes and figure out is this a legitimate transaction or not. This is a hacky way to check the same thing, which is, if you log this transaction object, let me do that. You'll see a bunch of things, specifically, a bunch of balances, pre-balances, post-balances. So you can check, have I received 0.1 Sol in the specific transaction between my post balance and my pre-balance? Was this one check that I should add here, which I haven't yet? Was this money paid by this user address or a different address? And the last thing you should check is, was this money paid to me or some random address? You are expecting the user to send you the signature, right? The user could send you the signature of a random 0.1 Sol transfer to some random person. You need to make sure the 0.1 Sol actually came to you. The recipient of the transaction was you. That is what this guy does. What does it do? Transaction.transaction.message.get account keys.get of 1.toString equal to parent wallet address. This is the wallet address that we gave to the client, at least on the front end. Okay, bhai, you should send money here. But the user can be notorious and send the money anywhere. So you need to make sure, okay, when you're parsing the transaction, you check, is the amount that you have received right? Is it 10 raised per 8 lamports or 0.1 Sol? Has it been sent to the right wallet? So you do both of these checks. Only if they succeed do you proceed. You should do another check to check, is the 0th address .get of 0 user dot wallet address. If you remember, our database stores, if I do a select star from user, we actually store the address of the user. So we should also check that the very first account here is the account of the user. So you should at the top over here do const user equal to await Prisma client dot user dot find first, where ID is user ID. Yeah, basically something like this. Make sure this user's wallet is the one that paid, and make sure that they actually paid us and no random person, and make sure the amount that they've sent is also right. There is still a bug over here. You can fabricate transactions that look like this, even though that transaction does something else. You might have exchanged an NFT with someone else and paid them 0.1 Sol, and you can send that transaction here. Dekho, I've paid 0.1 Sol without the backend checking that this 0.1 Sol was sent for something else. So ideally, you should parse this transaction much more aggressively. This works for now, but yeah, ideally you should not do this at all. You should accepting payments is done a different way, which we will get to if we get to. But this works pretty well for now. And if you add a little more strict checks, I think this will also become completely secure. I don't think it's completely secure yet, though. I think the client can send you some messed up transaction that might be able to pass all three of these tests, even though they might have paid for something else, or they might have gotten money back some way, so on and so forth. All right, let's see if this works now. I've added an extra check. Should probably work, but I just showed you a while back it did. If any of these checks fail, we let the user know sorry. If all of them succeed, or I also log the transaction object. So let me just show you what that logs. It basically gives you a bunch of details of the transaction. So let me restart this. Let me create another task. Refresh. Put a random thing. Put the same image twice. Click on pay 0.1 Sol. That should hopefully trigger a pop-up. Confirm it. Now the transaction is confirming. Once it does confirm, this button's text would change to submit. A lot of times that might not happen as well. The transaction might fail. This user might not even be able to pay if the blockchain is clocked, in which case, you can refresh and pay again, or just pay again over here. Doesn't matter. But yeah, the blockchain is unreliable. But there you go. It did succeed this time. So let's click on submit task now and see if this worked. I added an extra check, so that might fail as well. I don't know if the check is right, but it did work. And then let's also go here and look at the logged transaction object. If you look at the logged transaction object, it'll tell you a bunch of things. It'll tell you, what all programs were run specifically. 1111111. This was run. This is the system program that I was talking about. As you can see, it has a very weird address. If you deploy your own smart contract, it will be on some legitimate public key. But this is like 1111 is the system address, which is something you did interact with. And post balances, pre balances, specifically the second account. The amount of money it made. The post balance here is slightly more. What else? These account keys is how we found, from and to. So this is a very ugly way for us to parse a transaction, if I'm being honest, because there are a bunch of transaction shapes that could look like this. That could have post balances that look like this. That could have account keys that have first account, second account, third account. So it's not necessary that the user only paid. The user did, of course, pay. If your amount went from 3 to 4, of course they paid. But maybe something else happened in this transaction. You should basically parse the bytes of this transaction and figure out, is this just a system transfer, or is it something else? So that's something extra you should add. Even if you don't, it's fine. As you can see, we're able to create multiple tasks now. And if I go here and again, try to get the latest lists of tasks, you will see another fresh task over here with a transaction signature in the database that you can just go here and confirm that there is indeed a payment that happened from here to the parent wallet. That is how you build the first side of, the user being able to pay money. Now you need to build the other side, which is the Turks, the workers. Now the workers will have a bunch of tasks, right? I created a bunch of them. So hopefully you see a next task over here. The new task by wallet this. When I click on something like this, let me click on this one. I voted. It says submitting. After it's submitted, I see the next one. I probably put random images there, which is why you see nothing. Submitting. As I'm submitting, I need to make money, sir. That's why I'm submitting. That's why I'm doing this mechanical task, right? So the question is, how can the user see their balance here? That's fairly straightforward. We already have it stored in our Web2 backend. If I go to select star from worker, this worker, is slowly increasing the amount they're owed. They're owed this many lamp ports, 0.11 Sol or whatever, 0.011 Sol, I guess in this case. If they do another task, this amount will go up. That's done. Let's do this again. And now if you see, that's 12 Sol. So the amount they're making is going up. We need to allow them to dispense out this money, which basically means we need to support another endpoint. Number one, we need to begin with, let the user, connect from a wallet here, sign in. This doesn't support sign in yet. Pretty straightforward considering we've done it on the other side. The other thing this front end needs to do is, so we have to have a button here that says pay me out. That needs to hit a backend endpoint and trigger the asynchronous process to pay out the person eventually. Let's do that next. Alrighty, it's 6:22 p.m., which means the video release is in an hour and a half, which means we need to wrap this up in an hour. Anyways, won't need more than an hour. Let's do all the Web2 bits really quickly. Let's show the user their balance first, the worker more specifically. If I go to localhost colon 3001, I should see my balance over here. I should also be able to connect my wallet, all that jazz. So let's do that really quickly. Let's add all the dependencies we added in the user front end over to the worker front end. So it's the worker front end. Let's do npm install. There you go. I don't know if you need React, but everything else, let's update the app bar. We can just copy everything from user front end, thankfully. So there we go. Yeah, these dependencies are coming. The app bar will sign a message, send the request to /worker/signin. Sign into Mechanical Turks as a worker is something we should do, if I'm being honest. And that is what should be verified on the worker backend. So if I go to worker.ts in the /signin route, we should remove this hard-coded wallet address, very similar to how we did it in user.ts. What did we do in user.ts/signin? We did this. So let me first paste the message here. Okay. We got the public key and the signature, and there you go. We did the result. We never used the result though. If not result, this dot status 411 message incorrect signature. All right, that looks right, and probably need to do something very similar there. So just copy the whole thing, paste it in the sign in endpoint here, and replace sign in to Mechanical Turks with sign into Mechanical Turks as a worker. NACL is something I need to add. I'll add that as a dependency. Oh, that should already be there. In the backend, just need to import it. What else? /signin. Public key needs to be imported from Solana/Web3.js. This message looks right. Result looks right. Let the user know incorrect signature looks right. Public key, signature is here. Oh, don't need that to do anymore. Both the places. Never mind. Get the public key and the signature from the user. Make sure the message has been signed correctly. If it hasn't, return them this. Else, wherever we had hard-coded wallet address, I can simply do a public key now, because the end user is going to send me the real public key, and we don't have to hard-code it anymore. Alrighty, that looks good. Now let's go to app. App bar already done. We need to change the structure of the front end now. To again follow a similar pattern. App/create a folder, call it whatever you want. I'm going to call it root. Add a layout.tsx here, which you can completely copy from the other side. I don't think you need to change anything. Yeah, that should be fine. And then move page.tsx to root, as well as move oh, that's the only endpoint that we have. That's the only page that we have. So great, works even better. Is that it? Is that enough for me to at least sign in, let the backend know, and yeah, basically sign in. Let's see. We should also, we should have some logic here to, oh shoot. Yeah, we'll have to add some logic to make sure that the user sees loading if, they're not logged in, and, when they log in, they should see the contents again, or this request should go out again. Yeah, that'll be hard though, but let's see. Let's click on Phantom. Let's join in as a worker, and then let's sign a message. This time it says sign into Mechanical Turks as a worker. If I click on confirm, seems like it succeeded, else I would have seen a red thingy here. If I refresh now, I should probably see, you know. Okay, let me just create a new user. Let's create a fresh user. All right. Let's go to account 37, which looks fairly empty. Refresh, select wallet, phantom, connect, sign the message, and fresh. And now still says what is thumbnail, best thumbnail fix. Let's see. What is the best thumbnail? ID 26. That looks wrong. Yeah. Phantom, connect. Am I able to sign in? I am able to sign in. Does return me a token. 20. Okay, let me try one last wallet. Maybe I've already used this wallet, which is why this is happening. Let's try wallet number 8 or 38. Sorry. Select wallet, phantom, connect, sign the message. I did sign. I did get. Oh, I did not restart the backend, did I? I did not. That's it. Let's do it. TSC-B node / index.js, refresh, and, you know, confirm. There we go. Confirm. Refresh. Worker, confirm. Sign in request fails with a course error. Why is that? Preview. Backend died. Why did the backend die? Address already in use. What is running on 3000? Okay, I guess that makes sense. Backend node / index.js. It is running on 3000. Now let's start. You need the user front end, but let's start it either way. Where are you running, sir? 3001. All right, refresh. Okay, happened fairly quickly. Let's try that one more time. Select wallet, click on phantom, connect it. Sign in request never goes out, and there's an error. Why? Resource not available. Okay, sign into Mechanical Turks as a worker. Click on confirm. It happens twice. I need to fix something in the rendering, but either way, I get back a token. Hopefully that's stored in my local storage. If I refresh, this is a fresh wallet. I should see things from the beginning. There we go. That looks right. I'm seeing things from the beginning. I need to solve a bunch of problems to be able to make some money. Let me submit problem number 1. Let me submit problem number 2. That should be good enough. Now I need to see my balance over here, so that, or, you know, it doesn't matter if I see it, but the point is I need to be able to withdraw it. So let's just add a withdraw button. Let's not worry about adding how much I have. How much do I have right now? I can just check by doing a select star from workers, and you will notice I have currently 0.0002 sol, something like that, which is something I should have. Every task, the user is paying 0.1 sol, and then, you know, that divided by 50 or 100 is what is reaching. Divided by 100 is what reaching each and every worker. So we need a button here. If you go to app bar along with the wallet disconnect button, we need a button that says pay me out. Needs to be a little bit cleaner though. Alrighty. Pay 0.1. Again, this is where a monorepo would have helped, and I wouldn't have to, you know, copy over a bunch of styles. Right. If you have a pay me out button, we should probably show the user how much money they're owed. The sign in request can return that, I guess, which is good because, you know, you can just store it here. So let's do a const balance comma set balance equal to use state 0. Let's just put the balance in the button, which is, well, right here, balance, and let's make the backend return it, which basically means if I go to worker.ts along with all the magic that happens here, I need to return not just the token but also the amount. If this is a fresh user, then it will of course be 0. If it is not a fresh user, then the amount would be existing user.pending amount. There you go. You get the amount for the user. Just need to restart the backend, tsc-b node / index.js, and then 3001 refresh, payout, it says 0 still. Why is that? It returns the amount. Let's see. Fresh network, refresh, confirm. The sign-in endpoint returns you an amount, and if I go to app.tsx, I never use this amount. I need to do a set balance to be response.data.amount, refresh, and confirm, and you will see pay me out a very big number. It should be divided by this, and it should say pay me out this thing. So alrighty, refresh that. There we go. Pay me out. Eesh. Pay me out. Such a small amount. Probably, yeah. 0.1 sol divided by 100. Oh, I did it times per 8. Should be times per 9 though. No. Into times per 9. That's my bad. That right? Probably is right. I don't know. No, that sounds wrong. That sounds very wrong. Yeah, sounds wrong. How much was stored? 2 into 10 per. What does the backend return? What's the amount? It's probably this only, right? Which basically means you divide by 1, 2, 3, 4, 5, 6. 0.1 divided by 100. How much is that? 0.01 is what the person should have. Why is it? Or if they've done 2 tasks, it should be 0.02. Why is it 0.00? There's like a few extra zeros here. Let's go to worker.ts. Let's see, where are we increasing the pending amount? What is this amount? Task.amount total submissions. What is the total submissions? 100, right? So task.amount is what? It is 1, 2, 3, 4, 5, 6. It should be 8 over here. Why is it 6? Where is the task created? User.ts task process. Where do you create the task, sir? There we go. Prisma.task.file. No. Post task. Everything is fine. Everything is fine. And then there you go. 1 into total decimals. What does that mean? That's okay. That's just wrong, dude. It'll be that makes a lot of sense. Yeah, I messed things up. It'll be 0.1 in total decimals. And then whenever you're returning it on the front end, it'll be divided by that number. So if I go to worker.ts, the amount is /sign-in. It pretty much needs to return amount is this thing into the total number of decimals. And then that should do it, I think. Alrighty. Had some small bug there. Let's see if that fixed it. There you go. 20 sold. That looks wrong. Oh, the task was created incorrectly. The task was created with 1 sol, which means 2 sol. Still divided by 100 is not that big a number. We have some math to fix, guys. Oh god, I can't believe this is taking up so much time. Okay, the number we're storing in the database is up to 6 decimals, which means if someone paid 0.1 sol, then we're storing 10 per 5. 1, 2, 3. Yeah, so we have 6 over here because we were storing 1 sol initially. This is fine. The amount that the other person makes probably should be this divided by 100, which is this much. Now, this much into is this much, and this has 1 2 3 4 5 6 7 8 9. Why? Hold on. Oh, Lamport. 0.1 into this thing. So that's 10 per 5. I should do a 10 per. If you want to convert it to Lamport, you should do it into. Well, no. I should do it divided by. That makes a lot of sense. And that is the exact Sol amount. Alrighty, this looks good. And then I can go to worker.t. Don't even worry about this, guys. If you don't understand, just messed up the math. There you go. That should do it. Yeah. So all the tasks that we've created for 1 Sol right now, which means even though the user paid 0.1 Sol, what we stored in the database was 1 Sol. So this user should probably owed. Wow. Yeah, right. Probably owed 0.2 or 0.02 Sol, I think. Yeah, 0.02. There you go. Alrighty, this is fine. This person is owed 0.02 Sol. They've done 2 tasks, and each task was for 1 Sol for the end user, which means 0.02 Sol is what this guy gets, which is like 1/100th to the pi for every task. Now they need to click on this button and actually get the payout. So when they click on the pay me out button, what needs to happen? The request goes out to worker.ts, inside which we do what? /payout. We get the workers details, we get how much money they're currently owed, which is whatever worker dot pending amount, and then we first need to create an in-memory transaction. We've already done this once. If you remember, in upload.tsx we created an in-memory transaction first by doing this const transaction equal to new transaction, where this comes from at Solana/web3.js. System program also comes from the same place. And where do we need to transfer money now? We need to transfer money from the parent wallet address to the user worker dot address. There we go. This is the transaction that we have created. We have not yet sent it. This transaction ID is what we should store in payouts. Const transaction ID is transaction.id or transaction.signature. And now comes the most dangerous bit. This money needs to go from this parent wallet address somewhere else, which means I need the private key of this parent wallet address. I need to keep that very secure. If you get that, you get my wallet. So let me just share how I'm getting it, but then I'll pause the video, while I'm getting it. This is my parent wallet address. If you remember, it's this wallet number 34, I think, which has $61 right now because 4 people paid 0.1 Sol. So it has $61. This is the public key of it. I need to get the private key of this because I need to store this private key on my server so that over here I can do something like transaction.sign and given my private key so that this transaction can be signed by the private key. I can prove I do own this wallet address and I am approving this transfer of whatever that number is, which also needs to be worker.pending amount into total underscore. This is the amount in 0.1 Sol, something like that. So I need to multiply that by divided by into 10^9. I think that's fine. That's the right amount. This is what the worker is owed in Lamports. 10^9 into the pending amount divided by total decimals. Pending amount divided by total decimals is what they're owed in Sol. So 0.1 Sol, 0.2 Sol, and to convert it into Lamports, we need to multiply it by 10^9. Transaction.sign private key. Here is where I need to, first of all, have my private key handy. The way to do that is go into settings, wallets, or manage accounts, and account 34 is the one which has $61 is where I need to show private key. don't show this to anyone ever. I'm going to click here, click on whatever my password is, and pause the video now, and store it in an environment variable, and then restart the video. All right, I've written a bunch of code as well. I haven't tested it. Let me take you through what I've done. Number one, I created a file called privatekey.ts, which I will delete by the end of this. I have my hard-coded private key there. So I'm not going to open it. It just exports a variable called private key, which I import here in worker.ts. The payout endpoint gets the worker and then creates a transaction to pay money. This should be separate. This should be flipped from the parent wallet address to the worker. And this is the amount that's calculated via some mathematics based on how we're storing data in the database and how you convert it into LAMP ports. Then we create this thing called a key pair, just how public key is something you get from Solana/Web3.js. Key pair is something that you get as well. This basically, if you have both the public and a private key or something, you use the key pair object. Whoever has this can sign your transactions. Public key only has the public key, so it's used for when you're addressing other people, or when you're trying to send money to other people whose private key you don't have. You will use the public key object. This does not have, if you open the class, it doesn't have the concept of a secret key. It just has a public key somewhere here. Like this value, this is a type, but this value is stored somewhere here in this public key variable. Key pair, as the name suggests, is the pair of keys. It has both your public key and your private key. So you create this object when you have a secret, when you have the private key of the user, which in this case we do. This private key I brought from my Phantom wallet here to the code, and created a key pair object from it. This can be used to sign transactions. If you look at this code right here, it says await send and confirm transaction on the connection object, which again I created a connection object here on the top using my own RPC URL. This is the transaction that I want to send on the blockchain, and these are the signers. If you open this, you'll see 1, 2, 3. The third argument here are the signers. Basically, if there is any transaction that needs to debit a certain account, which in this case is this account, of course, this needs to be signed using the private key of the same account, which I've stored in this, private key variable in this file. So that's how you, on a server, for example, create a transaction and, broadcast it out. As you can see, I don't need a wallet. I don't need Phantom here. I don't need Backpack. This is a terminal wallet. As long as I have the private key, I can do whatever I want with this wallet, including sending out LAMP ports to a different address. So that is what this guy does. And then, ideally, we should create a worker. I don't think we'll have time to do it. But if you remember the original architecture, this gets stored in a database, and then, eventually you keep on polling it. Eventually, if the poll succeeds, is when you let the user know, this locked amount goes down to 0, pending amount goes down to 0, so on and so forth. If you remember the original architecture, but what we are doing here is await send and confirm transaction, which basically means you don't even need the worker anymore. We're sending the transaction, we're confirming it. Only if the transaction gets confirmed are we can simply just do pending amount 0 over here. We don't even need the logged logic anymore. But this is bad. Why is this bad? Because if this transaction, let's say, succeeds, but then your backend server goes down, you send the money to the user, yet you weren't able to, create a database entry. That's really bad. That means you've debited money from your wallet and sent it to someone else, yet your database still shows you owe them another 0.2 Sol. So they can recreate a payout and send themselves money again, which is why you always need a very asynchronous architecture when it comes to payouts. When someone asks for a payout, you take their request and put it in a queue, and then you sequentially clear the queue slowly and make sure you don't ever double pay. And this is a recipe for disaster. Basically, the original architecture that we discussed with the workers is actually a much better architecture here. But we're short on time, which is why I've done this. That didn't be too difficult to add, but at the same time, probably would be difficult, if this is the first time you're doing Solana. So happy to create, a doc by the end of it. Happy to just push it to the code. So maybe if you're looking at the code one day after the release, you'll probably see the right code there. Alrighty, so TSC-B node/index.js. Even I haven't tested this, so let's see how the payouts happen. Let's put some logs here, so we can keep checking. Maybe signature, maybe console.log worker.address. I guess that's good enough. All right, let's initiate a payout from the front end. So if I go to localhost 3000 and 1 and select wallet, select the Phantom wallet, click on connect. This person has done 2 assignments, should ideally be paid I would have hoped 0.2 Sol. Let's see. Alrighty, confirm. What's up here? Let's see. Network tab, if you refresh, confirm. What does sign in return? It returns amount 0. Why? Doesn't matter. Let's just make this person go through. I guess I changed my wallet, that's why. Thumbnail 15. Now refresh. Connect. Yeah, there's like a lot of. What wallet is this? Maybe this wallet is. Probably not. Let's see. Let's just change this to. Oh, this is the parent wallet. We probably shouldn't do this. Parent wallet will end up paying itself. Let's choose a random wallet. Empty wallet should be fine. In fact, empty wallet is a great example of, a garib person who doesn't have money came to the website and started to do, these tasks. Sign in is failing. Backend is down. Unable to start a transaction at the given time. Oh, again, I've seen this too many times now. There's something up with this, with our transactions or the way we're doing transactions. But okay. I connect a fresh wallet. I am a new person, a new worker on this website. I start to solve mini tasks. I did one. It failed because it says incorrect task ID. Let me refresh. What does incorrect task ID mean? No idea. Click here, submitting. Looks right. Click here, submitting. Looks right. Click here, submitting. Okay, do a bunch of tasks. And now if I refresh, sign the message again. I have the option of pulling out 0.05 Sol. Pay me. Have we already written some on-click logic here? We haven't, so let's quickly add that. On-click equal to Axios dot post backend URL slash worker slash v1 slash worker slash payout. I don't think I need to give any inputs to this. Let me confirm, but I'm pretty sure this was just a payout endpoint. Doesn't need anything. Alrighty, let's try that. Moment of truth. Let's see what happens when I click on the pay me out 0.05 Sol button. It fails with a 403. You're not logged in. Oh, because I did not send the headers across, didn't I? Let's quickly add the headers. Hey, it's a post. Okay, empty body is fine, and then headers. Authorization header. Local storage dot get item token. Alrighty. Let's try that one more time. Click on pay me out, please, sir. And something got logged on the back end. Still stuck, so the transaction is probably going through. We'll see. What did we log again on the worker? We logged the worker.address, and then we did a bunch of things, and then we logged the signature. We're still waiting for confirmation, I guess. So we will wait. And there we go. We got back a transaction signature. If I go to solscan.io, you will see that this transaction has indeed succeeded. And it transferred 0.05 Sol, which was the money we owed to the person, over to 8HB4U, which is exactly the wallet of this person, hopefully. 8HB4U, as you can see, it now has 0.05 Sol. It was an empty wallet before, which means a garib person came, created a wallet, solved a bunch of these tasks, and then was able to pull out money. If I refresh now, it says 0 Sol because that money has been pulled out. The database still has some incorrect things. We should fix them, but for now this person can keep continuing to submit now, do more tasks. As they do more tasks, they can rake up more money. Let's see how far they can go. That's a lot of them. Okay, I guess that's good enough. Let's refresh the page one more time. Let's make them sign the message, which will, return this. Let's make them pull out another 0.07 Sol. Let's see what happens. Again, log on the backend. This will probably just work. So the person was able to pull out another 0.07 Sol based on the work that they've done over here. Yeah, so pretty much, what you would expect. Of course, there are, as I said, this is slightly vulnerable. As in, person can, if I click this button twice, I guess that's the vulnerability is right there, right? If I click this twice, thrice very quickly, the control would reach here very quickly, and then you wouldn't be able to lock I guess, yeah, I already had a comment somewhere here that said you need to lock the database. Yeah, there you go. You should put a lock here. And this, it becomes even more challenging. Basically, yeah, there's a double spending problem here. If I click on this button multiple times very quickly, send me, it'll most probably be able to pull out 0.07 Sol multiple times, which is like really bad, which is why this should be a very asynchronous process. What does asynchronous process mean? Okay, whenever the request comes, you first lock the database, then you move the amount from the pending amount to the locked amount, and then you slowly process that transaction in stages. You submit a transaction, you verify the transaction, then you moved the money out from the logged, make the logged amount 0. That's what you should do. Yeah, what we've done is basically, there's a vulnerability here. If I click on this button multiple times, I will most probably be able to pull out 0.07 Sol multiple times. Of course, I won't be able to do it infinitely, but while this transaction is succeeding, as you can see right now, it's stuck. I can send another one, and it'll forward another transaction, and I'll be able to pay myself twice. So that is something you should fix. Probably will get fixed in like a day or two when this gets published. Most probably we'll follow the architecture that I originally mentioned of a worker eventually polling transactions. That's how you do it. Even when you're withdrawing money from an exchange as well. That's how you slowly in various stages pull out money, and heavily ensure the person cannot pull out money twice. All right, this transaction seems like it will not succeed. It would have succeeded by now if it would have, which means I can just resend it. Oh no, it did succeed. Fuck. No, it didn't succeed. Sorry. Yeah. So we wait. But yeah, that's the double spending problem right there. There's a transaction we send for sending out 0.07 Sol, and then there's another one I'm able to send. If both of them succeed, the user will be able to pull out 0.14 Sol, which is twice the amount of money we owe them, which is why it's bad. Okay. The first one failed. It also crashed the server. Yeah, I should probably put that into a try catch. This thing right here. And if there's a catch, then just let the user know your transaction has failed. The second one still might succeed. The server crashed, but we might have forwarded the request by now. So let me put a to do here. There's a double spending problem here. The user can request the withdrawal multiple times. Can you figure out a way to fix it? Alrighty, let's try that one more time. tsc-b node index.js, refresh. Just close that. First, let's see, did we get another 0.07 Sol? We did not. So okay, we can still try it out. Maybe the blockchain is clocked right now. Oh no, we did get it. There you go. It's 0.19 Sol. So the person was able to pull out more money. And yeah, now they're back to 0. They can pay themselves more. If I do another task, then if I refresh again, I can now pull out another 0.1 Sol or 0.08 Sol, whatever that amount is. If I click on this button, there's no feedback right now. You don't see an alert that says your money is being processed, but you get the idea. It reaches the backend, and here is the transaction signature, which probably means I was able to pull out another 0.08 Sol. And now this goes up from $29 to $41. So that's a brief how you take money from whales and distribute it out to people in need / creator economy or whatever, Turk economy or worker economy. That was a long video. Let me clean up the code a bit, hide my private key, hide my AWS secrets, and push it onto GitHub. To quickly recap, what have we done? We have one side of our code, which is on localhost 3002, where people can come, rich people who want to get tasks done can come, connect their Phantom wallet or whatever wallet they have, create a task, which is the best thumbnail. And then they're allowed to choose from one of many thumbnails that they want to, estimate the click-through rate for. And they can submit this task, but when they do, they also have to pay 0.1 Sol. That's the amount that our platform charges and distributes amongst the workers who, are helping keep the platform alive. After you do confirm it and the transaction does confirm, we wait for a bit, and then you're allowed to submit the task. When you submit the task, you can also see the results of the task as they keep coming in. More and more people will vote eventually, and when they do, you can why is this not happening? You can see the results in sort of a dashboard. But what happened here? Submit task. All right, there you go. This task was created, and then currently there are 0 votes on both the variants. They're the same variants, doesn't really matter to get the idea. Now if I go to localhost colon 3001, where I'm a worker, I like to get paid, and I get this task suddenly, which is the task ID 28. So I'm solving 27 right now. And now when I solve the 28th task, which is the best thumbnail, if I click over here, I number one get paid for it. If you look at my pending amount now, I am owed 0.011 Sol, which I can eventually pull out. And if you look over here, if I refresh this page, I can eventually see, that 1 vote has happened for this specific thumbnail. So this is probably the more probable thumbnail for me to choose. That is Turkify for you guys. Hopefully that was clear. If not, let me know. But I think we'll call it here. Pretty long video, I think close to 6 hours. I don't know if you're able to stick through it. If you don't want to, that's fine as well. Just go through the code. There are some standard things to learn them and move on. With that, let's end it. I will see you guys in the next one. Bye bye.